And visible to you, just give me a quick yes in the chat section. Hello, everybody. Yes. How are you guys? Can you hear me? Okay. All right. Okay. So, first of all, there are a few kids in the class. First of all, let me just welcome you all. Lakshman, Neha, hello, everybody. Megha, Nishchal, Tilak. How are you guys? Okay. How's the preparation right now? Feeling anxious? Okay. All right. So it's going to be a long lecture, right? So we are going to revise grade 11 syllabus as well as grade 12 syllabus, right? And in this lecture, I have taken a different kind of approach, right? Because at this particular moment, we have to revise everything, right? Now, in general, what happens when we are revising grade 12 topics, right? Grade 12 topics are very clear to us already, right? But grade 11 topics are something that we do the partiality with. The grade 11 topics might not be as strong as grade 12 topics, right? So for grade 11th, I'll be showing you a lot of PYQs from the NEET exam, right? We'll be solving all those PYQs. I'll be giving you some time to solve, right? So you will try to solve those PYQs first. Then I will tell you the concept behind it, and then I will explain you the solution, right? And after that, grade 12th, in the grade 12th, I will give you the theoretical explanation as well, right? And then there will be some numericals in the grade 12 part as well, right? So grade 11th will be numerical heavy, and grade 12th will be a very quick revision of concepts plus numerical, all right? Okay. All right. Hello, everybody. I'm good. Good afternoon. Right. So if you guys are ready, just give me a quick yes, and we will start right away with the grade 11th part, right? So there will be questions from previous year from all the chapters of grade 11th, right? So you will get an idea about what kind of preparation you have right now, okay? So just to attempt the lecture in the best possible way, do one thing. I'll be showing you the quiz, right? Every question is going to be the quiz, okay? Right, I will be giving you some time. If you can solve it, good. If you cannot solve it, I will explain you the concept and I will explain you the solution after that, right? Shall we start? Okay, so let's start with the first question, my dear kids. The first chapter is units and measurement. We will start from the previous year questions of the grade 11th part itself. The first question of units and measurement is this. Read the question. Now this question is from the NEET 2025, right? Very recent question. Read it. A physical quantity P is related to 4 observations A, B, C, and D as follows, right? So P depends on A, B, C, and D in this particular fashion. The percentage errors of measurement in A, B, C, and D is 1, 3, 2, and 4% respectively. The percentage error in the quantity P is going to be very common question, right? So just try to answer it in the chat box. I'm going to start a quiz for you, right? So I'm giving you 60 seconds to solve it, right? And you have, your time starts right now, all right? Okay, your time starts right now. So I'm minimizing it for now, right? For those kids who can solve it, should solve it right away. And those who cannot solve it, I am explaining you the concept of the question, all right? Okay. All right. So keep on trying, my dear kids. Very good. So how to solve it? Let's have a look at that. So the concept is like this, right? Whenever we have a quantity, right, that depends on more than other, different quantities. For example, we want to know the length of the combination of these two things, right? We want to know the total length of this plus this. Now, what is happening? While measuring the first rod, you made an error. And while measuring the second rod, you also made an error, right? So what will happen? When you will join them and try to get the value of total length, whatever error you made in the measurement of the first one and whatever error you got in the measurement of the second one, those errors will be adding up. Yes or no? So errors do add up, right? My dear kids, if the combination is like this, like if the P is equals to like A to the power N, B to the power M, and C to the power N. My dear kids, P depends on A, B, and C, all of them, right? If you are, creating some error while measurement of A, B, and C, all of them, then all of the errors will affect the result, right? So what will be the error due to all of them? So percentage error in the result is going to be delta P upon P into 100, that is going to be, power will become coefficient. Power will become coefficient. N times delta A upon A into 100. All right. Power will become coefficient. So M times delta B upon B into 100. Okay. And power becomes coefficient. N times delta C upon C into 100. Okay. Power becomes coefficient. Just apply this logic and you will get the solution to the previous question, right? So my name is Gaurav. I am Gaurav Tiwari, right? So I take physics lectures on other channels of PPW, right? So I believe, yeah. So this question is clear to everybody, right? Let's have a look at that. Let's have a look at how many kids have actually solved it. Very good. Okay, so let's have a look at that. How many kids have actually solved it? Right? Just a second. So in the previous question, in this one, the correct answer is, let's say how many kids have got the correct answer. Oh, all the kids got the correct answer. The fastest answer was Nishchal, right? And then we have Chandrakala, then we have Pavitra. So basically, any kid can come up first. There are hundreds of questions in this class. So you can practice for the day, right? You can keep on practicing, right? And you can, get on the top, right? So you can see that this is the quantity, right? P is equals to A cube B square C root D. So whatever power is there, that becomes the coefficient. So power 3 becomes the coefficient. 3 delta A upon A into 100. 2 delta B upon B into 100. And the power of C is 1. So 1 into delta C upon C. And this power is half. So half delta D upon D. And 100 is taken outside. Right? So everything is given. The percentage error of A is 1, in B it is 3, in C it is 2, and in D it is 4%. So clearly, delta A upon A, you can put 1, delta B upon B, you can put 3, delta C upon C, you can put 4% and all that, right? 2%, and delta D upon D is 4%. So just add them up and you'll get the 13%, right? Now let's move on and talk about the next question. A metal wire has mass of that many grams, radius is that many mm, and length is that many centimeter. The maximum possible percentage error in the measurement of density will be. Maximum possible percentage error in the measurement of density will be. My dear kids, try to solve this question, right? You have again 60 seconds to solve. Okay. So as I said, now this question confused a lot of kids, right? You see that? First quantity is given in grams, second is given in mm, third quantity is given in centimeters, right? My dear kids, when you are talking about percentage error, the quantity that you have, the unit is something that is irrelevant, right? When you have the units and you are calculating the percentage error, the unit becomes irrelevant. Why so? Think about it. The percentage error talks about the ratio, right? So you don't have to be confused about this part. This is the concept, right? Whenever you are talking about the percentage error, you have this thing, delta A upon A into 100. This is how you write it. Okay. So you see that what will be the unit of delta A, right? Whatever error you have encountered, you see, when I'm measuring the length of this rod, let's say the length of this rod is 20 mm, right? But I made an error of 1 mm. I measured it 21 mm instead of 20. So the error I encountered is 1 mm, right? So the unit of this error delta A is 1 mm, right? And the unit of the actual length is 20 mm, right? 20 mm. So mm upon mm, that will be cancelled out. So units will be cancelled out, right? So make sure that, my dear kids, you don't have to get confused with the units that is given, kilogram, centimeter and millimeter. Many kids got confused between these two units and they said that I have to convert the units. That doesn't really matter when you are calculating the percentage error, because in the ratio the units will cancel out anyway. Okay, so I believe the idea is very, very clear. Okay, so just use it, right? You have to calculate the density, right? You have to calculate the density. Can you solve it? Very good, very good, very good. Many kids are able to solve it. Very good. So we can say that density, let's say it is density is rho. So density is mass upon volume, right? So what will be the volume? This is a metal wire. So volume will be, wire can be taken as a cylinder. If the length of the cylinder is L and the, what is given here, Length is given, radius is given. So radius is given r. So what will be the volume? We can say this area into length. So pi r square into L, right? So volume will be pi r square into L. Okay. So now we know everything. Okay. This is the density. Now you know the error in mass is given, delta m upon m into 100, right? Error in this thing is given. So power of radius is 2. So it will become 2 times delta r upon r into 100. Power of L is 1. So it will become 1 times delta L upon L into 100. And the values are already given to you. These are the values that you encountered, right? So all you have to do is just put the values. You see that error in the density will be delta m upon m into 100, right? Power will become coefficient 2 times delta r upon r into 100, and power will become coefficient 1 times delta L upon L into 100, right? No worries about that, right? So see that delta m is how much? It is written in the mass 0.4 plus 0.002. So 0.002 is delta m, error in the measurement of mass, right? And similarly mass is given into 100. Similarly delta r upon r into 100. So here you have it. While the measurement of radius, this is delta r, this is r. So just put the values 0.001 and 0.3, right? Similarly delta L upon L, you can put the values, and finally you will have the answer of 1.6% or so. Let's see how many kids got the answer correct, right? How many kids actually got the answer correct? Okay, so 78% this time. This time Kohli is the first kid, right? So you see that new kid is coming up in the top, and then we have Abhishek and NZZ, right? So let's move on and talk about the next question. This question is clear with everybody, right? This question is clear with everybody, right? Now let us talk about the next question, right? Now let us talk about the next question. Okay. Okay, so this is from the NEET 2022. NEET 2022. Read the question, my dear kids, and try to solve it. The area of rectangular field of length 55.3 meter and width 25 meter after rounding off to the value of correct significant digits. My dear kids, think about it. Let's say that we have this value 1358.7, and let's say we want to round off to two significant digits. Think about it. This is a conceptual question. This is why I picked up in this particular class, right? Let's say that I have to round off this particular value to two significant figures, right? Now think about it. I can round off from here, and the previous number is 5. So I can look at the even or odd number. So just to make it simple, I can make it 6, right? So I can say that. So I can increase the previous number by 1. I can make it 14, but that will be wrong. Think about it. Let's say that you have to give somebody 1363 rupees. You can say that I am rounding it off to 14 rupees. You have to give 1300 and you are giving 14 rupees. He will say, no, I don't want this mathematics. All right. So how can you deal about that? How will you round off large figures to smaller figures in this situation, right? You have 5 digits, and you want to round off to 2 digits. How can you do that? And why do we want to round off to 2 digits? Have a look at that particular question. Meanwhile, those who can solve it should start solving right away. Look at the question, right? For the area of rectangle, the length is given, right? 55.3 meter, and width is given 25 meter, right? Width is given 25 meter, okay? Right. After rounding off the value of, what will be the area, the value of area we have to calculate. The area will be length into width, right? No problem with that. Multiply this and this, 55.3 multiplied by 25, right? 55.3 multiplied by 25, right? You will get some value, right? You will get some value, okay? You will get some value. So the value that I remember is around 1382.5, right? My dear kids, when we multiply two quantities, right, in the result we have to take the number of significant figures corresponding to the lower value, right? You see that one quantity and the second quantity, they are multiplied. But in this one, there are 2 significant figures. In this one, there are 3 significant figures, right? So in the result, we have to keep the minimum significant figures. So here we have 2. So the answer should have only 2 significant figures, right? When you are multiplying 2 things, and these things have different numbers of significant figure. The first quantity has 3 significant figure. Second quantity has 2 significant figure. So in the resultant, we can only keep 2 significant figures, right? So you see, think about it. If I want to drop off the rest of it, and I want to keep it two significant figures, the answer will not resemble. Think about it. If I say I'm rounding it off, previous the digit is 8 more than 5 and I'm increasing the previous one, I'm making it 4. So I cannot say that it will be 14. It will be wrong. Think about it. The result is 1300 and I'm rounding off to 14. Yes or no? So that doesn't make sense. In this case, in these scenarios, my dear kids, you will always use the scientific notation. So this is the concept, right? Okay. So the area is 1382.5, right? In these scenarios, what will you use? Scientific notation, right? So what is scientific notation? You will convert that into 1.3825 into 10 raised to the power 3. Yes or no? Right? And you want now you can round off this thing to the two significant figures. So you can drop off these parts. So last digit is 8 more than 5. Increase the previous one by one value. So this is how the answer is, right? 1.4 into 10 to the power 3, right? 1.4 into 10 to the power 3. So you see that the resultant is this, right? 14 10 to the power 2. So that doesn't matter, right? If you write it in this way or you write it in this way, 1.4 into 10 to the power 3 or 14 into 10 to the power 2 or 140 into 10 to the power 1 or 1400. All of these things have how many significant figures? Only 2, right? So when you're writing it in the scientific figures like this, right, all of these digits, all of these results have only 2 significant figures, right? Okay. So you can take this one as an answer, which is in the option. So option D is going to be your correct option, right? So this is why I picked up this question, because this question has a concept in it, right? My dear kids, tell me this is clear with everybody. Okay. Tell me that this question is clear with everybody or not. So this is option D. Oh, everybody is correct. Very nice. And the fastest answer this time is Rajeshwari Kohli was first in the previous part, and NZZ, this kid was there in the second part, second number in the last one. So yeah, you are trying. Very good. So let's see that. What is the resultant of the next question? The quantities which have the same dimension as those of solid angle. So out of these quantities, which one will have the same dimension as of solid angle, right? So think about it. Which quantity will have the same dimension as of solid angle? Tell me, first of all, tell me, is solid angle a dimension, has any dimension, or it is dimensionless, right? First of all, tell me this thing. Is solid angle, just put the either 1 or 2 in the chat box. Does solid angle has any dimension, or is it dimensionless? Put it in the chat box first, right? Is it the solid angle has any dimension, or is it dimensionless? Very good. It is dimensionless. It is dimensionless, right? It is dimensionless. So think about it. Out of these things, which is going to represent the same dimension of solid angle? That means that quantity is also dimensionless, right? Very good. Yes, solid angle doesn't have any direct dimension, no? It's the same thing, no? Solid angle is, you see that whenever we talk about the solid angle, right, we think about, let's say that this is the geometry, right, and we want to know that what is the solid angle. Solid angle is the angle subtended by the area on the surface. So let's say that we take an area on the surface like this, right? So this is, okay, this is a small area, right, and the angle subtended by this area, this is the solid angle, right? So you see that to calculate the solid angle, you take this thing, area, and you divide by the square of distance, right? Divide by the square of distance. My dear kids, the dimension for area is L2, right? L2, length into length, L2, and the square of distance, again L2. So L2 upon L2 is no dimension, L0. So M0, L0, T0. This is the dimension of solid angle. So we want to know the dimension of which one of these things is dimensionless. Answer me in the chat box, right? Answer me in the chat box. Very good. So out of these things, we can simply say that angle is also a ratio of, angle is just the solid angle is the ratio of area and the square of distance. Angle is the ratio of arc length and the distance. So this length upon length, again that is dimensionless. So angle is dimensionless, right? So we can have option A or option B, right? Strain or stress, which one is dimensionless? Stress has the same dimension of pressure, force upon area, right? Strain is change in length upon original length. So change in length upon original length, right? Both of these things have same dimension, ratio hai, right? So since it is a ratio, strain is dimensionless. Strain is dimensionless. This is dimensionless, this is dimensionless. So both of these things are dimensionless, right? Option A is the correct option. Let's see how many kids are actually giving the correct answer. Okay. This time I forgot to start the poll. No problem. Next time. Okay. No problem. Sometimes that also happens. Okay. All right. All right. So let's move on and talk about the next one, right? Okay. Right. So let's have a look at this particular question, kinematics. Now we are entering into kinematics. Acha, how many kids got all the questions correct in the units and measurement? You will get one question from the units and measurement, right? So honestly, tell me how many kids got all the questions correct. Okay. Very nice. Clear. Awesome. Awesome. All right. Praneeth got all the question correct. Kohli got all the question correct. Very nice. So that tells you about that 4 marks are definitely there for you, right? Now from kinematics again, one question you will get in the final exam, right? In the NEET exam, right? Let's see how is your preparation in the kinematic sector, right? And again, I have picked only previous year questions from the kinematics. For grade 11th, I have only picked the previous year question, right? Grade 12th, I will be explaining you conceptually. There I'll be explaining you the concept because generally kids don't revise grade 12th very well. So I will be doing that, right? So grade 11th, again, we have a question from NEET 2023 from the kinematics, right? Just look at this question. I have picked only good questions. Look at this question. A vehicle is traveling half the distance with the speed v and the remaining half distance and the remaining distance with the speed 2v. What will be the average speed? What will be the average speed? So try to explain it. Try to explain it, right? Okay. All right. Focus everybody. Okay. A vehicle is traveling half the distance with the speed v and the remaining distance with the speed 2v. What will be the average speed? So my dear kids, we have a direct formula for the average speed as well. But if I have to tell you about the little bit of concept of this thing. So concept is very simple. When you are calculating the average speed, let's say that this is the journey and you are breaking the journey from A to B into two parts, right? From A to, let's call it C, A to C, the distance is D1 and then we have the distance D2, right? Okay. So now we have to calculate, you have traveled the first part with the speed V1, second part of the journey you have traveled with V2, right? So you have to talk about what will be the average speed, right? So average speed is total distance upon total time. Total distance upon total time. My dear kids, total distance is d1 plus d2, right? And total time, you see that in the first part, time taken is distance upon velocity, d1 upon v1. And in the second part, the time taken is going to be distance upon velocity, d2 upon v2, right? That's it. This is the only calculation you have to do every time when you have to calculate the average speed. Okay? All right. So let's have a look at this particular thing and try to do it. Its average speed is going to be, so what will be the average speed? We can say that total distance is d plus d. Let's call the total distance is 2d, right? First half is d, the second half is also d, right? So d plus d, and the first half is traveled with the speed v, right? So d upon v, this is the time in the first half, and d upon 2v, this is the time in the second half, right? So now you can just add it up. So it will be 2d, right? In the denominator, d will be common out. So 1 upon v plus 1 upon 2v, right? You see that? So you have 2 times v1 into v2 upon v1 plus v2, right? You see that? This is the formula that is coming up, right? So when a particle is traveling half of the distance with v1 and remaining half with v2, the average speed is v1 v2 upon v1 plus v2, right? Oh, sorry, 2v1 v2 upon v1 plus v2, which is what we are getting over here, right? So this is the average speed. Okay. So in the question, in the exam, you can directly write it. If the first part is travel with the speed v1, the remaining half is travel with the speed v2. The average speed is going to be 2v1 v2 upon v1 plus v2. This is how the formula comes up, right? And just put the values and solve it. Okay. So let's see that how many kids got the correct answer. Good afternoon, beta. Let's see how many kids actually got the correct answer. Okay. So here you just solve it. It is going to be 4 by 3v. Option A is correct. Okay, so 82%. Those kids who got the answer wrong, I believe they also understood how to solve it. Let's move on and talk about the next one, right? And who was fastest this time? Who was fastest this time? Okay, I'll see it next time. Okay, so look at this question again. In the kinematics, they have asked the graph-based question multiple times, right? So I have picked 2 graph-based question in this session as well. In the NEET 2022, they have asked this question, my dear kids. Look at this question. The displacement time graph of 2 moving particles make an angle of 30 and 45, right? So the displacement time graph of first particle is making an angle 30. The second one is making an angle of 45, right? With an x-axis as shown in the figure. The ratio of their respective velocity is going to be. So what will be the ratio of their respective velocity that we have to find out, right? So answer it in the chat box, right? Answer it in the chat box. Now answer it. Now answer it. Once I start the poll, then start answering, right? Very nice. Dhanush is answering. Very good. Sagar is answering. Ravi is answering. Very nice. Praniti is answering. Abhishek is answering. Very nice. Crazy. Awesome. 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 Right. So this tells us that many kids have prepared the physics really well for the NEET exam, right? And the kinematics is going to give you 4 marks, right? So you know that the slope of displacement time curve, slope of displacement, let's say the displacement is x, slope will be dx by dt. So rate of change of displacement, slope tells us rate of change of this thing. So this is displacement, right? So this is, so rate of change of displacement is nothing but velocity. So higher slope means higher velocity, right? And the slope is also tan of theta, okay? Slope is also tan of theta. So you see that the first one is making an angle 30, second one is making 45. So their slope is actually velocity. So velocity of the first one is tan of 30 and velocity of the second one is tan of 45. Got it? So take the ratio, right? Tan 30 upon tan 45. Just put the values and you will have the ratio, right? Let's see that. How many kids actually got the answer correct? 1 upon root 3 and 1. Just put the value. So V1 upon V2 is going to be 1 is to root 3. Right? 1 is to root 3, which is option D, right? Let's see that. How many kids actually got the answer correct? Okay. So very few kids actually got the answer correct. So this is where we can understand. And here NZ, this kid is there, right, from the beginning of the class and he is answering correctly. So his preparation is really nice. So you understand that this question tells us that our preparation with the graph question is not that good, right? Focus, everybody. Right. So let's have a look at the next question. Again, another good question based on graph. It is from the NEET 2024, right? Very good question based on graph. Very good question based on graph, right? Try to answer it in the chat box, those who can, right? Your graph, your poll is running right now. You can answer it in the chat box. You have the velocity time graph, right? And you have to tell the acceleration time graph, which one of the acceleration time graph is correct, right? Velocity time is given, acceleration time you have to tell, right? So have a look at this particular question and try to answer it. Have a look at this particular question and try to answer it. My dear kids, the slope of velocity time curve, is dv by dt. It is telling you rate of change of velocity, that is nothing but acceleration, right? Slope of velocity time curve tells you acceleration. Slope of displacement time curve gives you velocity, right? Okay. My dear kids, look at this thing. Can I say that if I have to name, this is A, this is B, this is C, this is D. Look at from A to B. Can I say that the angle is constant from A to B? The slope is constant from A to B. If the slope is constant, that means the acceleration is constant. So from A to B, the acceleration is constant. So if I have to plot the graph, right, for acceleration and time, so from A to B, for this journey, I have to draw the constant acceleration, right? Acceleration is constant, okay? From B to C, look at this journey. From B to C, what is happening? Velocity is over here. From B to C, what is really happening? The velocity is constant. It is not changing. If velocity is constant, rate of change of constant is 0, right? Velocity is constant, that means there is no acceleration. Particle is moving with 20 meter per second. That means there is no acceleration, right? So from B to C, velocity is constant. That means there is no acceleration. So acceleration from B to C is 0. From this particular part, acceleration is going to be 0, okay? Look at C to D. The slope is negative. You see that the slope is, angle is more than 90 degree and tan more than 90 degree is negative. So look at that. From C to D, the slope is negative. So clearly, if slope is negative, that means acceleration is negative, right? But the slope is constant. So it is negative but constant. From C to D, in this region, acceleration is constant but negative. So you have this portion and you have this portion. Got it? Right. And B to C, you have the flat portion. So this matches up with the option D. So this matches up with the option C, sorry, not D, right? Option C, right? So option C is the correct option, right? Again, you see that in the graph questions, you are committing a lot of mistake, right? In the graph questions, you are committing a lot of mistakes. Yeah, thank you, Levi. I believe the idea is very, very clear. In the graph questions, you are committing mistake, my dear kids. So this is where you have to work upon, right? So let's move on and talk about the next question. The ratio of distance traveled by a freely falling body in the first, second, third, and fourth second is going to be. It is asked in the NEET 2022 paper, right? The ratio of distances fallen from the first, second, third, and fourth second. My dear kids, those kids who will start solving this question will waste a lot of time in solving this question. But those who know that there is a thing called Galileo's law of odd distances, right? Galileo calculated the distance fallen by the object in the consecutive time seconds, right? In the first second, how much distance is fallen? In the second second, how much distance is fallen? In the third second, what is the total distance that is fallen, right? And he tried to put all the distances in the ratio, and he encountered that the ratio is in the odd numbers, right? The ratio is in the odd numbers, right? So you see that Galileo's law of odd distances, right? So meanwhile, you can solve it. 45 seconds you can take and try to solve it. But Galileo suggested that when you drop a body, in the first second, it will fall from here to here, right? And now it is accelerating. It has some velocity. It will increase, now it has some velocity. In the same 1 second, it will have much further distance, right? So now in the next second, in the first second, this is the distance traveled in the first second. This is the distance traveled in the second second, right? Now the particle is moving much faster. In the next second, it will travel much further, right? So if you take this distance, S3, distance traveled in the third second of the journey, right? And he took all the ratio, S1, S2, 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 S3. It comes out to be 1:3:5 like this, right? Like this, okay? So look at that. So this is the ratio. Option C is the correct option, right? But those who want to solve it, right, there is a derivation I have written over here as well. You see that the distance fallen by the object, you are dropping an object, so initial velocity is 0. In the first second, how much distance is fallen? S1. So we can say that the distance fallen in the first second is initial velocity is 0, right? Yes, u is 0, right? Acceleration equals to g. So in the first second, it is k into t square. T is 1. So 0 plus half into at square. So instead of writing half again and again, we are writing k, right? No problem with that, right? Half at square, k, a is g, right? So this whole thing is always a constant. Half a, instead of that, we are writing k, right? And t square. So you see that in the first second, t is 1, so it is k. In the second second, k is 2, so just put 2, it is 4k. In the third second, it is 3 square, 9k. In the fourth second, it is 4 square, 16k. Now you take the this is the distance traveled. This is 4k. 4k is the total distance it is traveling in the 2-second journey, right? This is 4k. Okay. In the 3 seconds, how much distance is fallen? 9k. So from the initial point till here, the total distance is 9k. Okay. In the 3 seconds, right? So clearly we can say that in the first second, distance traveled is k, right? In the 2 seconds, in the first 2 seconds, the total distance is 4k. So how much distance is traveled in the second? So we have total minus this. So it is 4k minus k, which is 3k, right? And again, from here to here, in the 3 second, the total distance is 9k, right? So how much distance is traveled in the third second? So we can say that the total distance is, my dear kids, 9k. And from here to here, it is 4k. So 9 minus 4 is 5k, right? Now you take the ratio. The distance traveled in the first second is k. The distance traveled in the second is 3k. The distance traveled in the third second is 5k. So k is to 3k is to 5k. All right. And that is why the ratio comes out as 1:3:5. I believe the idea is very, very clear, right? I believe the idea is very, very clear. Any problem in that? This is in the 10th, you may have understood that. Clear. Now, again, a very interesting question. And on this particular concept, multiple questions have been asked, right? They can ask you the question like this, or they can ask you about the energy, right? Look at this. This is asked in the NEET 2023, right? Very relevant question. Look at that and try to answer it. Let's see how many kids actually got the answer correct in the previous one first. So 1, 3. So yeah, most of the kids got it correct. That means that part is fine. Okay, so you guys are committing mistakes in the graphical portion. Okay, but let's look at that. How many kids actually solve it? Now you try to answer it, my dear kids. Now try to answer it in the poll. Now I have started the poll. Try to answer it. Here a body is launched at an angle of 20 degree, angle of 60 degree with a speed of 20 meter per second. At the point B, what will be the velocity? Velocity at the topmost point will be, right? This is what you have to answer. My dear kids, we know that when a body is moving in a projectile motion, at the topmost point, the vertical component of the velocity becomes 0 and the horizontal component of the velocity remains constant in the entire journey, right? The horizontal component of the velocity remains constant in the entire journey. And this concept is something which is very important for a NEET. I believe you can get one question from this particular concept. What is that? The horizontal component of the velocity, on the body performing projectile motion, projectile motion on a flat surface, on a flat horizontal surface. That means it has to move like this. Okay. So in this case, there is no confusion. We can say that if a body is moving on a flat horizontal surface like this, the horizontal component of the velocity, this is the velocity, this is the horizontal component, v cos theta, this is theta, and this is the vertical component, v sin theta, right? Vertical component is accelerated, right? At the topmost point, the vertical component is 0. Horizontal component everywhere is same. U cos theta, U cos theta, U cos theta, U cos theta, right? So it remains same. Same. I believe the idea is very, very clear. And we can apply this logic at so many types of questions, right? The horizontal component of the velocity remains same during the journey. So we can say that at this point as well, it is going to be 20 cos 60 everywhere as well as this point. 20 cos 60 is 20 into 1/2, which is 10. So option D should be the correct option. Let's see how many kids got it correct. Only 20%. Why? Right? Only 20% kids got it correct. Why? Okay, so those kids who got it wrong, have they understood this question right now? Okay. The horizontal component of the velocity remains constant during the journey, right? This question is clear with everybody? Okay. Any problem with this part? Option D is the correct option. My dear kids, On the similar concept, there is one more type of question which can be asked. It looks like this, right? The question, you try to solve it, right? And tell me, a body is launched at a velocity of 20 at an angle 60. It is performing projectile motion. What will be the kinetic energy of the body at the topmost point? Right? First of all, tell me, will it be equals to 0? Will it be more than 0? Right? Try to answer it either A or B in the chat box. A body is launched at an angle 60 with a velocity 20 meter per second, right? At an angle 60 degree with a velocity 20 meter per second. At the topmost point, the kinetic energy of the body is 0 or more than 0. Answer it A or B. A or B. Okay. Nishagra is saying A. Okay. Sangapa is saying B. Dhanush is saying B. Pallavi is saying A. Dhanush is saying B. Okay, think about it. At the topmost point, the kinetic energy of the body. Okay, A is coming up. My dear kids, everyone who is saying A is the correct answer, that kinetic energy at the topmost point is wrong. Right? Try and understand that. Which component of the velocity does not change during the journey? Horizontal component. Right? Think about it. If I'm launching this body, right now, the horizontal component is 20 cos 60 and vertical component is 20 sin 60. At the topmost point, only vertical component is 0, right? This component becomes 0 over here, but at the topmost point, the horizontal component remains as it is. So over here also, the velocity is 20 cos 60, right? 20 cos 60 means 20 into 1 by 2, which is 10 meter per second. My dear kids, if at this place there is a velocity in the body, can I say that the kinetic energy will become 0 over here? Let's say the mass of the body is 1 kilogram. What will be the kinetic energy over here? Kinetic energy is half mv square. So kinetic energy at the topmost point is half, mass is 1, and in place of velocity you will put horizontal component of velocity, right? Whenever you have to calculate kinetic energy at the topmost point, you will put velocity as a horizontal component of the velocity, because vertical component will become 0, right? So it is 10. So 10 is square. So clearly you can write down kinetic energy is going to be 50 joules over here, right? So the option B is correct. I believe the idea is very, very clear. Now all the kids have the correct concept. My dear kids, concept is clear with everybody? Okay. My dear kids, concept is clear with everybody or not? Okay. All right. Let's move on and talk about the next one. Now look at this question. A bullet is fired from a gun at a speed of 280 in the direction 30 degree above the horizontal. The maximum height attained by the bullet is. It is asked in the NEET 2023. My dear kids, why I put this question? Because I just want to tell you that most of the time from the question of projectile motion, right, they ask you simple formula based projectile motion question, right? Try to answer it. You have 60 seconds, right? And meanwhile, I can tell you that you can remember just the basic formulas, right? And you can still get the question correct, right? So if you do not know the projectile motion in very depth, right, just remember the basic formulas and revise them well enough, right? Do not do the problems with the formula itself, right? So the maximum height, you know that when a body is launched at an angle theta, the maximum height attained by the body is u square sine square theta upon 2g. The maximum height attained by the body is u square sine square theta upon 2g, right? So everything is given to you, right? You just put the values and you will get the answer correct. Okay. So let's see that how many kids got the answer correct, correctly. When you try to solve it, right, just put the values and you will be able to get the answer 1000 meters. Let's see that how many kids actually got the answer correct. Option A should be the correct option. Only 27%. Just you have to use the formula, right? So just understand that for formula for maximum height, formula for time of flight, formula for range. These things should be clear, right? Okay. My dear kids, I'm asking one more question. Okay. Right. Answer it. And let's see how many kids answer it correctly. A body is launched at an angle of 60 degree at a velocity v, and the range it obtained is 100 meters. If I want to launch the body at the same velocity, at what angle other than 60 I must launch it so that I can get the range 100 meters again, right? So see, think about it. At 60 degree, I got the range 100. At what other angle I should launch so that I can again get the angle, I can again get the same range, right? So theta for the same range. This is the question, right? You have the option range, right? You have the option A, B, C and D, okay? Option A is 30, B is 45, C is 60 and 120. 60 is already we have launched. So 80 and 120. So try to answer it in the chat box, right? At what angle I must launch it so that I can get the same range if I'm launching it with the same velocity. The session is just started, no? Why the break in first hour? You have to practice a lot so that, you can attempt the question correctly in the exam, right? If you cannot solve, let's say, all these questions right now, okay, how can you solve all the questions in the exam itself? You need to have a habit of solving at least 200 questions in one sitting. Option A is correct. Very good. Very good. Very good. I can see that. Rajeshri, Sangapa, Parvati, Kirti, Kohli. Very nice. Sagar, Dhanush. Very good. Very good. Sanjana. Very good. So everybody is giving the correct answer that you have to launch at an angle. These are called complementary angles. Question on this is also asked in the NEET exam, right? If you are launching at an angle theta, there is another angle 90 minus theta, at which if you launch the body at a given velocity v, you will get the same range, right? The time of flight will not be same, the height of the projectile, the maximum height will not be same, but the range will come out to be same. So if you are launching one body at an angle 20 and another body with the same velocity at 90 minus 20, so both of these projectiles will have the same range, okay? All right. Now the next question is from the laws of motion. Let's start with this particular part, laws of motion, right? A ball of mass 0.5 kg is dropped from a height of 40 meters. The ball hits the ground and rises to a height of 10 meters. Right, it is dropped from a height of 40 meters. It is dropped from a height of 40 meters. You see? Okay. Look at this surface, right? Look at this surface, okay? And here I am doing this thing. You look at that. You are launching from the top of the smart board, right? You see that. And you see, after jumping, right, it doesn't jump back to the same place. Why is so? You see, the ball is dropped and it doesn't jump back to the same level. Why is so? Because when the ball is jumping off, it is transferring some of the energy and momentum to the surface itself to compress it, right? This can be compressed, right? So some of the energy is compressed, some of the momentum is transferred to this particular surface, right? To compress it. Can you see? Right? So how much momentum is being transferred? How will you know that? Okay. How will you know that? Right. So try to answer it, right? Those who can solve it should start solving. Oh, this is the previous question, right? So that was the option A. Okay. And now we have to start a new bowl. Right. So try to solve this particular question, right? For those who can solve it, should try to solve it. And those who cannot, I am explaining you the concept, right? Okay. My dear kids, as I have just shown you, I had a box like this, right? And I have dropped a ball, right? So the surface was not rigid. and the ball was also not rigid. So what really happened? When the ball is dropped, it has a certain momentum just before hitting the ground. Okay. And you see that after hitting the ground, it compressed the surface, and the ball might be compressing itself as well, right? So it could not jump back to the same level. Now it is jumping back to this level, right? So whatever momentum we had, we have transferred some of the momentum to the surface itself, right? So how much momentum is transferred? We can say that we can calculate by impulse momentum equation. You see that a force is applied on the surface for a very short amount of time, right? Let's call that time, this ball, when it is going to hit the surface, it will apply a little force, right? That force, when it is applied for a very short time, that is called impulse, right? So when the ball is going to hit the ground, it will apply some impulse, right? So impulse momentum equation. So we can say that F delta T, this is the impulse, that is equals to change in momentum, right? F delta T equals to change in momentum, right? So I believe the idea is very, very clear, right? Impulse momentum equation. This is called impulse, this is called momentum. So impulse transferred, how much impulse will be transferred, that is equals to change in momentum. Got it? Momentum of the body. Okay. All right. So think about it. When the ball is hitting the surface, let's say just before hitting the surface, it has a velocity v1, right? So what is the momentum right now? We can say that the mass of the body is m. So momentum just before hitting is m into v1, right? And just after hitting the surface, it has velocity v2. So momentum just after hitting is m into v2. So what will be the difference of momentum? Delta P, that is P2 minus P1, right? mv2 minus mv1, right? So once you calculate that, you can calculate how much impulse is being transferred, right? That's all. I believe the idea is very, very clear, right? Okay. Okay, let's first of all, let's see that how many kids actually gave the answer correctly, right? Or we will look at that when I will give you the solution of this thing. So here you have it. The logic is very, very simple, right? When you are dropping the ball from a height of 40 meter, so from the height of 40 meter, how much velocity the body will achieve? The velocity just before hitting the ground is going to be under root 2 gh. Yes or no? The body is dropped from here, initial velocity is 0, right? It is dropped from here. So you know that S equals to ut plus half at square, half at square. So you see that the height for which it is falling, let's say it is h, initial velocity is 0, so half gt square, right? So you see that, okay, no, not this one. We have to talk about the velocity it will achieve, just before hitting the ground. So you see that initial velocity is 0. So you can say that v square is u square plus 2gh, right? Initial velocity is 0. So clearly we can say that v square is 2gh. So v is going to be under root 2gh. So clearly, if a particle falls for a height h, it acquires a velocity root 2gh. If a particle falls for a height h, it acquires a velocity 2gh. So what is v1? Root 2gh. Right? It falls for 40 meters, the velocity will be root 2gh. Now, after hitting the ground, it bounces back to only 10 meters. So, what will be the velocity just before hitting the ground? v2. It is again, v2 is going to be under root 2gh2. Here you will put h2 equals to 10, right? So, now you know the values of v1 and v2 both, right? Now you know the values of v1, which is root 2gh1. h1 is 40 meters, right? So, v1 is 28 meter. Just before hitting the ground is 28 meter per second. And just after hitting the ground, h2 is only 10 meters. So put h2 is 10 meters, right? So just after hitting the ground, v2 is 14. So body was moving at 28 before hitting the ground, and after hitting it is only 14. It is striking with 28 and bouncing off at 14. So there is a loss of momentum, right? So whatever loss of momentum we have is delta P is this much. mv2 minus v1. Clearly, if you are calling this velocity as positive, the other velocity will be negative. Or if you are calling this velocity positive, v2, this will be negative. So we are calling it mv1 is negative, right? No problem with that. So just put the values 14 minus 28. So this is the loss of momentum, right? So the impulse transferred is equals to loss of momentum. So here the equation impulse equals to change in momentum, right? So I believe the idea is very, very clear. My dear kids, tell me the concept is clear or not, right? 21 is the answer that you are getting, right? My dear kids, tell me. Very good, very good. Let's see that. Who was the... So let's see that. Let's move on and talk about this particular question, right? Very good question from the NEET 2025. Okay. Look at that. A 1 kilogram object strikes a wall with velocity 1 meter per second at an angle of 60 degree with the wall and reflects at the same angle, right? So there is a ball, right? It strikes the ball like this. It strikes the wall like this at an angle of 60 degree, right? So you can imagine in this way, right? It strikes at an angle of 60 degree and then it is bouncing off at the same angle. It will hit like this and it will come like this, right? So what will be the change in momentum like this? Okay. So what will be the change in momentum? Then the force exerted on the wall is. So clearly there will be a change in momentum as it hits the wall, right? There will be a change in momentum as it hits the wall, right? Like this. So whatever change of momentum we get is equals to the applied momentum, applied impulse, right? So we have to talk about the force exerted on the wall. So we can say that impulse equals to change in momentum. Impulse is force into delta t, that equals change in momentum. So force applied is change in momentum upon the time. That's it, right? Force equals to change in momentum upon time, right? Because it is saying that it remains in the contact with the wall for 0.1 second. So ball stays in the contact with the wall for 0.1 second and then it bounces back. So delta t is equals to 0.1, right? Delta p you have to put and delta t you have to put and you can easily solve it. My dear kids, right? You can solve it while I'm explaining you this, right? First of all, tell me which part of the momentum will change. You see, the ball is going to hit the surface like this and then it will bounce off like this, right? The ball is going to hit the surface like this and it will bounce off like this, right? So think about it. What will happen? Question is saying it is making an angle 60 degree with the wall. So this angle is 60 degree, right? With the wall, the angle is 60 degree. So think about it. If I talk about this component, and if I talk about this component, so clearly this angle is 30 and this component is 60, right? Okay. So you see this angle is 60. Now think about it. We are launching it with the velocity v. This component is v cos 60 and this component is v sin 60. Now think about it, right? I will be asking you a very simple question and you have to answer me. After bouncing, it will move like this, right? And the question is saying that it reflects at the same angle from the wall. So this angle is also 60 degree. So this is also 60 degree, right? This is also 60 degree, right? So this is going to be V2 call, let's say V2 cos 60 because it bounces off at the same velocity. So I will not be using V2 again. So V2, this is V2 cos 60 and this is V2 sin 60, right? These are all the angle considerations, right? I have just shown you. That was not very much needed, right? But I have shown you anyway. My dear kids, just tell me one thing, that momentum is changing because of which component? You see that V sin theta and this component, right? V sin theta here is into the wall and here after striking V sin theta is out of the wall, right? First this component is into the wall and then after striking this component is out of the wall. Look at this component V2 cos 60. V2 cos 60. This component is downwards here and downwards here. It is V cos 60 here and V cos 60 here. Is this component changing? Look at this component, right? Is the vertical component changing right now? V cos theta over here, this component, is it changing right now? We can say that there is no change in this component which is parallel to the wall, right? the component of velocity which is parallel to the wall stays unchanged, right? So this is the observation we have, right? In the wall striking problems, this is the observation you have, right? The component of velocity parallel to wall does not change, right? Okay, and only the component of velocity perpendicular to the wall changes. So what is the change of momentum in this case? We can say delta p is p2 minus p1, right? So p2, let's call it, this thing is mv2 sine 60 minus, if you're calling this is positive, so this one you have to call it negative, so minus mv1 sine 60. Because here in this particular scenario, v1 and v2 both are same because it bounces off at the same velocity. So v1 and v2 both are same, you can call it v. So here it is, for this question, it is mv sine 60, minus and minus will become plus mv sine 60, right? So the change of momentum is 2 mv sine 60, right? So just this is the concept that you have to understand, right? So when a ball hits the ground or wall, a ball hits the wall and bounces off at the same angle with the same velocity, what is the effective change of momentum it gets? So upon solving such a condition, in such a condition, when it bounces off at the same velocity, at the same angle, then the change of momentum is 2 mv sine theta. Got it? In that situation, the change of momentum is 2 mv sine theta. Got it? So 2 mv sine theta upon time, change of momentum is 2 mv sine theta and time is 0.1 second. Just divide it. Okay. 2 mv sine theta upon delta t. That is the answer. So mass is given 1 kg, velocity is given 1 meter per second, sine theta is sine 60 and delta t is 0.1. So just all the values are given to you. You have to put the values only and you will get the answer, right? So let's see that. When you put all the values, you get the answer 10 root 3, right? So 10 root 3 is the answer, which is option C. Okay. Let's see how many kids actually got the answer correct. So 20% kids got the answer wrong. And here, Nisagra got the answer correct. Parvati got the answer correct and Kirti got the answer correct. These are the first 3 kids. Then we have Pallavi and we have Sagar, right? So I hope the idea is very, very clear, right? Okay. Any problem in this part? Now let's move on and talk about the next one. Right. Look at this question and try to solve it. This question is from a very old paper from NEET 2014, but it's a good question because, as I said, graph based questions are good questions and they generally ask questions from graphs from these simple chapters, right? Look at this question. The force F is acting on a particle of mass m and it is inclined by the it is indicated by the force time graph. So whenever they're talking about the force time graph, they are interested in impulse, right? Force and time gives you impulse, right? Okay. Force time graph as shown in the figure, the change in momentum of the particle over the time interval from 0 to 8 seconds. So from 0 to 8 seconds, what will be the change in momentum? From 0 to 8 seconds, what will be the change in momentum? My dear kids, let's say that this is the force curve and this is the time curve, right? Here, look, think about it. This is, let's say, the force is, if you calculate the area under the curve, you are essentially multiplying the value of force with the time. This is time and this is the force, right? You are multiplying the value of force with the time. And when you're multiplying force with the time, you are essentially getting the impulse, right? Force into time. My dear kids, that is also area under the curve. So area under the force time curve gives you change in momentum, right? Try to answer it. That is a concept, and try to answer this question based on this concept, right? So you can write down this concept somewhere. Concept is very simple. Area under the force displacement curve, area under the force time curve gives us the change in momentum. Got it? Area under the force time curve gives us the change in momentum. Now we have to think about what will be the change in momentum from 0 to 8 seconds. We have to talk about what is the change in momentum from 0 to 8 seconds. From here to here, we have the force time graph. So from this, in this duration, we have to talk about the change in momentum. That means we have to take the area under the curve in this duration. So take this area, and this area and add them up, right? You have to add them up. Right, my dear kids, clearly you can say that this particular part is below the axis, right? So this is negative area. These areas will be adding up and this will come out with a negative sign, and just put all the values together and add it up. So here we have 1 upon 2 base into height. So this is 6 into 2 into 1 upon 2, which is 6. So this one is 6. This one is 2 into 2, which is 4. And this one is from 4 to 8, it is 4. And this particular point is 3. So 4 into 3 is 12. All right. So this is negative and this one is positive. So 6 plus 12 plus minus 4. So all add them all up. So 18 minus 4 is 14. All right. So for, okay. I hope the idea is very, very clear. Okay. Okay, let's add them up once again. So this is 6, this is 2. So the first area of this particular part is 1 upon 2 into base into height. So this is the area, 6, correct? And the area of this thing, oh, this is 3 only, not 2. Okay, this is where we got the mistake, no problem. Right, the area of this thing is, this height is 3 units and this is 2 units. So this is 6. All right. And the area of this thing is length into width. So this from 4 to 8, it is 4 units. And the height of this thing is 3. So it is 12. Now you can add them up. Now you will get the correct answer. So the answer will be this and this will be cancelled out. Plus 6 and minus 6. And then 12 will remain. The answer should be 12. Right? The answer should be 12. So option C is the correct option. Again, few kids got the option wrong. But here I can say Kirti, Pallavi and Sagar. And ends that this kid is again, these two kids are again coming back to the same equation, right? And they are answering it correctly. Very good, very good. Okay, so let's move on and talk about the next one. Read the question and try to solve it. Okay. There are two inclined surfaces of equal length L and same angle of inclination 45 with the horizontal. Right, there are two inclined surfaces of equal length L and same angle of inclination 45 with the horizontal. One of them is rough, and other is perfectly smooth. Okay. All right. So both of the surfaces have same length and same inclination. Right. Okay. Just one is rough and one is smooth. Okay. A given body takes 2 times as much time to slide down on a rough surface than that on the smooth surface. The coefficient of kinetic friction between the object and the rough surface is close to. So the question is very clear, right? Meanwhile, it's a very good question. Those who can solve it, you have 2 minutes now to solve this question. It's a good question. It'll take some time to solve. It is asked in the NEET 2025, and these kind of questions can be solved only by those kids who have prepared it really well, right? So it's a good question, right? So let's have a look at that, how to solve it. First of all, it involves the concept of friction. Okay. So here we have two surfaces, same length, and angle of inclination is 45, right? When the body is falling on a smooth surface, it takes lesser time. And here we have the friction. So this one has friction, right? And when the body falls here, it takes more time. So the time taken on this surface is time on a smooth surface, S. And here when the time taken by the body to slide on this thing is time taken by the body on the rough surface, TR. So we have said the time taken on the rough surface is twice as much. Time taken on the rough surface is twice as much time taken on the smooth surface. My dear kids, when you are going to calculate the time to fall, time to slide down, right, there will be one differentiating factor only, right? Or every other thing, just equation of motion you have to use. Only one differentiating factor will be there. What is that differentiating factor? When the body is sliding down here and the body is sliding down here, what is one difference in the acceleration of the body? Think about it. When the body is sliding down, what is the one difference between the acceleration of the body? What is the acceleration of the body here at which it is sliding down? And what is the acceleration of the body here? Think about it. Right. What is the acceleration of the body here and what is the acceleration of the body in the previous situation? Right. So my dear kids, we know that this angle is 45, or let's call it theta, right? And if I take this thing, this angle will also be theta, which is 45, right? Now think about it. So if you call it g, right, acceleration due to gravity which is acting on the body this way, which component of acceleration is acting along the sliding direction? We can say that this is going to be g cos theta and this is g sin theta. Yes or no? So along the motion, the acceleration is g sin theta on the smooth surface, right? Along the motion, the acceleration which is acting is g sin theta, right? Yes or no? I believe the idea is very, very clear, right? So here on the smooth surface, the acceleration on the body on the smooth surface is g sin theta, which is g sin 45, which is g upon root 2. This is the acceleration of the body when it is sliding down on a smooth surface. But when it is sliding down on a rough surface, clearly kinetic friction will be acting upwards. The body is sliding downwards, the kinetic friction will be acting upwards, right? What will be the value of kinetic friction? So when the body is sliding downwards with a velocity v, the kinetic friction is acting upwards. So let's not talk about the velocity. We are only interested in acceleration for now. We are calculating acceleration. So you see that in the downward direction, the acceleration, the component of acceleration is g sin theta. There is no worries about that. So g sin theta is acting in the downward direction. Okay. Now the kinetic friction will be acting up. So mu k is acting up. This is the force. Fk I should call it. Right. The kinetic friction is acting up. And you know that if a force is there, force is F, the acceleration caused by that force is force upon mass. From Newton's second law, force is equals to mass into acceleration. So acceleration caused by the force is force upon mass, right? So acceleration caused in the upward direction because of kinetic friction is kinetic friction upon mass. Yes or no? All right. So what is kinetic friction? Kinetic friction is mu k into normal reaction upon mass. What is kinetic friction? Coefficient of kinetic friction between these two things is mu k and normal reaction is n. Then this Fk, that means the force of kinetic friction is mu k into n upon mass, right? What is n over here? We can say that the normal reaction, the weight of the body is acting downward and this component is mg cos theta. So clearly normal reaction is mg cos theta. This is balancing out. So normal reaction is mg cos theta. No worries about that. So put the normal reaction over here. It is mu k into mg cos theta upon mass. Right. So it is mu k into g cos theta. I hope the idea is very, very clear. Right. Mu k into g cos theta. Right. So right now, what is the effective acceleration? You see that this friction force, kinetic friction, is creating an acceleration or retardation, which is mu into g into cos theta, right? Mu into g into cos theta, right? And the gravity is creating the acceleration in the downward direction. See that gravity wants to make it faster. It wants to accelerate downwards with this acceleration, right? And friction wants to slow down and will call the retardation with this much value, mu k into g cos theta. So the effective acceleration in the rough surface, on the rough surface, so acceleration on the rough surface is g sine theta minus mu k into g cos theta. I hope the idea is very, very clear, right? Once you know that part, remaining question is very, very simple, right? So you see that in this question, only one difference is there, right? What is that difference? When the body is sliding down on a smooth surface, the acceleration is g sine theta, and when the same body is sliding down on a rough surface, the acceleration on the rough surface is g sine theta minus retardation caused by the friction, which is mu kg cos theta. I hope the idea is very, very clear. If you have understood this concept, then solving this question is very, very easy, right? Okay. Now, clearly we can say that this is given. Time taken on the rough surface is 2 times time taken on the smooth surface. No problem with that. How to calculate the time? Basically, when your body is moving from here to here, the displacement, in both cases, the displacement is same, na? Because the length of the track is same in both cases. So the displacement is going to be ut plus half at square. Initial velocity is 0, right? So s equals to ut plus half at square, right? You see that this part will become 0. So displacement is going to be half at square, right? And clearly in both cases, the particle is traveling the same displacement. So we will calculate this part in the first equation. Again, we will do the same thing in the second rough surface, and we will equate it. You see that? So on the smooth surface, acceleration on the smooth surface we will put over here, and time taken on the smooth surface we will put over here, right? Acceleration on the smooth surface is g sine theta. Put it g sine theta, right? Acceleration on the smooth surface is g sine theta or g sine 45, right? So we just put it over here, g sine theta, which is g upon root 2. So just put it over here. The time taken on the smooth surface is this, okay? 4s upon g root 2, right? And now the time taken on the rough surface, again, the time taken on any surface is half acceleration into t square, right? So acceleration on the rough surface we have already calculated. That is this g sine theta minus mu k into g cos theta. This is acceleration on the rough surface, right? And time on the rough surface is tr, let's say. So clearly, upon putting the values and solving it, you will get this is the time taken on the rough surface. This is the time taken on the rough surface. This large equation, right? This one, right? And now what is happening? Time taken on the rough surface is 2 times of time taken on the smooth surface. Just put the values, both the values we have calculated. Rough surface time and smooth surface time. So this length of the track is same. We can cancel it out, right? And then we can solve the remaining part. We can remove the under root square on both sides and we can solve it. So upon solving it, only you see that g will also be cancelling out. So only mu k is the only unknown in the equation. So mu k will be calculated, which is 0.75, and that's how you can go about this particular question, right? A very interesting question, I would say. And the entire question, you know, hangs from a single concept, right? And that concept is this: at what acceleration the body will slide down on a smooth surface, and at what acceleration the body will slide down on a rough surface. Just you need to know the acceleration. Once you know the acceleration, the distances are same, ut plus half at square. Just apply the equation of motion and you can put the value of acceleration over here. Remaining is only solution. My dear kids, tell me this question is clear with everybody? This question is clear, is everybody? Okay. All right. 0.75 is the answer. So option B is correct. Okay, great. So Abhishek, NZZ, okay, Neha, Kohli. Okay, these two kids are always there in the chat, in the leaderboard. So again, let's see that and talk about another question. Okay, so good question. It is asked in the NEET 2024. So in the NEET 2024, in the NEET exam, generally they are asking a very simple interaction based question, right? They are not getting too deep into the constrained motion and all that. Simple questions from these parts. Have a look at this particular question. A horizontal surface, a horizontal force of 10 Newton is applied to a block A, right? in the figure, the mass of the block A and block B are 2 kg and 3 kg, 2 kg and 3 kg. The blocks slide over frictionless surface, there is no friction, and the force exerted by the block A on the block B will be. How much force the block A will exert on the block B? This is what we have to calculate. How much force the block A will exert on the block B? So answer it in the chat box. A very interesting, a very simple question, right? My dear kids, those who can solve it definitely should try to solve it, and those who cannot, I will give you the concept and then the solution. What is the concept? My dear kids, when the entire system moves under one force, we have one body, we have other body, right? And this is the force, pulling force, pushing force, right? So we have said that force is same on the entire system. And when the entire system moves together, whenever that happens, when the entire system moves together, right? These are not independent, yes or no? You apply the force and both of them have to move. Both of them will accelerate. In that situation, the acceleration, the common acceleration of the system will be net force upon total mass. Net force upon total mass. So this is F upon m1 plus m2. So this will give you the value of acceleration. This particle will accelerate with the same value. Same goes with this one. This will also accelerate with the same value. So if a common force is accelerating the entire system, the common acceleration of the system is this much, right? The common acceleration of the system is this much. I hope the idea is very, very clear, right? So now you see that this is 10, this is 2, this is 3. What will be the common acceleration? We can say that 10 upon 2 plus 3, 10 upon 2 plus 3 is 5. It is 2 meter per second per second. This is the acceleration of the system, right? And now we have to talk about how much force will be applied. So for that, you have to look at the FBD of these bodies, right? FBDs of these bodies, right? So FBDs we can apply, right? 2 and 3 kg. So simple question. This is one body, this is another body. This is the force, right? This force is applied on the first body, right? So just separate them. And this force is acting on this body, right? Common system is accelerating in this direction with acceleration A. Same goes on with this one, right? Now, at this surface, they are pressing against each other. So this block is pressing this block in this direction. And again, it will also get a reaction force. Let's call it N, right? And now we know that how to solve it. This is force. So clearly, we want to know that the normal reaction over here. The normal reaction is going to be mass of this body. Let's call it M1. And here it is M2. So M2 into A. So mass of the second body is 3 kilograms, right? 3 kilograms. And acceleration is 2. So 3 into 2, which is 6. This is the force that is exerted by the first block on the second one, right? My dear kids, you can also practice that if the force was acting instead of a smaller block, the same force was acting on a bigger block. Then what will be the normal reaction, right? This is the homework problem I'm giving you, right? Think about it. Situation is same. Again, we have same blocks, 2 and 3 kg, same surface, same force of 10 Newton is acting, but not here this time. The force of 10 Newton now acting on the bigger block. Now you have to tell that what will be the normal reaction. Okay. Think about it. And this is your homework. For this particular question is your homework. Clear? All right. Break time. But we have just studied for around 90 minutes or so. I'm not tired. I'm standing up. I'm shouting. So if I'm not tired, how are you tired? Okay, keep on solving, right? You have NEET exam just 2 days after, right? And you are supposed to be solving around, 90 plus 90, 180 questions, right? So a lot of questions you have to solve. And so far you have solved around 30 questions or so, 20, 30 questions, right? So don't get tired so fast. So here this question is from the NEET 2020, right? And try to solve this one, okay? Let me solve Newton's laws of motion. Then please let me solve work power energy. Then please let me solve one more chapter, right? Whatever chapter I have placed over there. So if there is gravitation or system of particles, whatever is there, so we will try to solve that one. So let's solve two more chapters, right? And then I will give you break. So otherwise there will be too many breaks in the class, right? I don't want to keep too many breaks in the class, right? Okay. So just make a habit of at least studying for 2 hours. Okay. Look at this question and try to solve it. This is the previous question. Previous question. In the previous question, what was the answer? 6. Very nice. 80% give the correct answer. Okay, let's move on, talk about the other one. Okay. So here again, there are two blocks, 4 and 6, the hanging off a frictionless pulley, right? We have to talk about the acceleration of the system in terms of gravity. Acceleration of the system in terms of gravity. Very simple question, right? These kind of devices called Atwood's machine. So what will be the common acceleration of the system, right? What will be the common acceleration of the system? We can say that both of these blocks will move together. If you move one block, the other will be moving as well. Magnitude of acceleration will be same, just the direction will be opposite. This is accelerating downwards, so this will accelerate upward. If this is accelerating downward, this will accelerate upwards. This one is heavier, so clearly here this will go down, this one will go up, but the magnitude of acceleration will be same, right? So what will be the magnitude of acceleration? So here we can say that if I only had one block, right? So the weight is, let's call the mass is m2g. So with this much force, m2 into g, this is accelerating downward. Let's say that there is no other rope on the other side, that rope is not there. So this is going to freely fall with this much weight, right? But here we have attached a smaller weight as well. Let's call it m1. So this one is trying to lift it, right? m1g. So effectively now m2g is not accelerating in downwards. Right now, the net force or net pulling force is different. It is m2g minus m1g. Yes or no? So the system is moving with this much force. m2g is trying to move downward while m1g is lifting it upwards. Okay. Upon net force upon total mass. Total mass is m1 plus m2. m1 plus m2. This is the acceleration of the system. So acceleration of this particular system is going to be net force upon total mass. So it is m2g minus m1g upon total mass m1 plus m2. I hope the idea is very, very clear. Okay. So now just apply the same idea over here. 6 into g minus 4 into g upon 6 plus 4. Right. So 6g minus 4g is 2g. 6 plus 4 is 10. 2g upon 10 is g by 5. So option C is the correct option. Everybody is correct. And who's fastest? Pallavi is fastest. So Pallavi is coming up in the top leaderboard for a while. Dhanush is there. And Dhanush is also there, very active in the chat. And then we have Sanjana, Sagar and Parvati. Parvati is also there, very frequent. Okay. Okay, let's have a look at another question. Okay. This is good. It's a good question, right? It's a spring-based question, right? So what is happening? We have a spring. We have two masses attached on the spring. The first mass is 3m, second mass is m, right? What is really happening? Look at that. We have two masses attached with this thing, right? And the string is inextensible, so it will not be stretching at all, right? The whole system is suspended by a massless spring as shown in the figure. The magnitude of acceleration of A and B immediately after the string is cut. So right now, the system is under equilibrium, nothing is accelerating. But as soon as you cut the string, what will happen? Right now, the weight of this thing and the weight of this thing is pulling the spring in the downward direction. So spring is right now stationary. But as soon as you cut it, the weight of this thing will stop at, pulling it. It will go back. So clearly it will accelerate in the upward direction, right? It will accelerate like this, and this one will be under free fall, right? Because you just cut the string. So this will be under free fall, and this one will be going up because the force is reduced, right? So you want to calculate just after cutting the string between A and B, what will be the acceleration of A and B? We can say that just after cutting the string, B will be accelerating downward under free fall. So acceleration is G. So this one will have acceleration G, right? So clearly you see that out of 4 options, this cannot be the option, this cannot be option, right? We have to know we have to tell the acceleration of A and B. B cannot have acceleration G by 3, G by 3. Either A is correct or B is correct. You see, just a simple observation and 2 options are out, right? And now you have to tell what will be the acceleration. So clearly you can look at the FBD of these things, right? You can look at the FBD of these things and talk about it. Okay. So think about it. You have 60 seconds and answer it. My dear kids, 60 seconds you can answer. Kohli, it is confusing. No, it is not. What is confusing you, Mr. Kohli? Right, there is nothing to be confused about. You see that the whole thing is attached with this particular situation, right? It is under equilibrium, right? As soon as you cut the string, what will happen? The second block is under free fall, right? There is nothing to stop it. It is under free fall. It will fall with the acceleration G. The second block is now the spring is not pulled by the so much force, so it will try to go back. What is that acceleration? Look at the FBD and try to solve it. Focus, focus. Very nice. Sagar and ZZ. Very nice. All right. So I hope I have not started. Okay, this poll is starting out. So let's see that how many kids are actually correct. Then I will explain you the solution as well. Every kid has given the correct answer, and the fastest answer is given by Pallavi, then Kirti, then Suchit. Dhanush is again there, right? Okay. So we have NZZ and Kohli. These kids are there, but in the downward direction. So here we have it. So clearly we can say, simply, we just have to look at the FBD, right? Before cutting the string, so let me try to make the diagram again here so that you can collect it. This is 3M and this is a string, this is M, okay? Now, before cutting the string, what is really happening? This spring is pulling in the upward direction with the force Kx, okay? And look at the FBD of this block. In the downward direction, there is clearly tension force, right? Plus weight of this body, right? So weight of this this whole thing, right? So this is 3 mg acting downward, right? So tension force plus 3 mg acting downward, okay? Now look at this one, second one. It has its own weight acting downward and tension force acting upwards, right? So upon solving it, right, look at the first equation, Kx equals to T plus 3 mg, right? And the second one is T equals to mg, right? So clearly you can put it over here and you can call Kx is equals to 4 mg in the first case. Kx is equals to 4 mg in the first case, right? Okay. Now, when you remove the second block, when you cut it from here, this tension will become 0, right? When you remove it from here, the tension will become 0, right? And this is how the equation will look like. So Kx will become now 3 mg, right? And now the acceleration A will be, net force upon mass, right? So Kx minus 3 mg on mass of this body is 3m. So just divided by 3m, right? So upon cutting this particular thing, net force is Kx minus 3 mg upon mass, right? That's it. And once you do that, Kx, the value of Kx you have already calculated 4 mg, just put it over here. So it is mg upon 3m or g by 3, right? And the second block is under free fall because the second block is simply falling. You just cut the string, second block will fall. So that acceleration is g, right? So g by 3 and g is the correct answer, which is option A. Let's move on and talk about the next question, right? Again, this question is asked in the NEET 2023, simple question, right? So what is really happening? A block of mass 2 kg is placed on an inclined rough surface of coefficient of friction mu. The net force on the block will be, what will be the net force on the block, right? What will be the net force on the block? What is really happening? A block of mass 2 kg is placed on an inclined but rough surface, right? It is placed on the inclined rough surface of coefficient of friction mu. So we have to talk about the net force on the block. My dear kids, before you solve this question, I want you all to solve this question. Right? Very good question. You see, there is a rough surface and a rough body is placed on that particular rough surface. The coefficient of friction between these two surfaces is 0.75, right? The mass of this body is 5 kilograms, right? You have to tell me right now what is the net force acting on the body, right? You have to tell that what is the net force acting on the body. The net force is equals to 0 or the net force is not equals to 0. Answer it in the chat box, right? Let's talk about the, not talk about the net force, let's talk about the friction force only, right? Friction force, all right. Friction force is 0 or friction force is non-zero. A or B? Answer it in the chat box. We have a rough surface and a rough body with a coefficient of friction 0.75, right? Both of them are stationary. So is there any static friction? Is it 0 or is it non-zero? Answer it in the chat box. NZZ. Okay. You can continue to eat. All right. So they are saying, most kids are saying, Lakshman is saying B, Sudha is saying A, NZZ is saying B, Kirti is saying B, Tejas is saying B. Very good. Sudha is saying B, Dhanush is saying B. Very good. Chetu is saying okay. Dhanush is okay. Very good. Sagar is saying B, Sudhanshu is saying A. All right. Come on. Every kid that is giving the option B is wrong. Yay! Every kid that is giving the option B is wrong. You can tell that, sir, how is it possible? A rough body is placed on a rough surface and you are giving me mass and everything. Why there will be no static friction? Why the static friction is 0? Every kid that is saying that there will be non-zero friction, it will have some value, is wrong. The friction over here is 0. Try and understand it. Is there any other force acting on it? We can say no. And you say that, sir, there is some static friction. Think about it. Then in that case, there is only one force, which is static friction, and the body will start moving on its own because of static friction. Okay. Does that happen? My hand is rough, this remote is rough. If I put it over here, is it moving on its own because of there is some friction between them? No. Think about it. Static friction is self-adjusting in nature. We forgot that line. Yes or no? Static friction is self-adjusting in nature. Static friction is, this is the concept I want to tell you. This is the concept, my dear kids. Static friction is self-adjusting in nature. Static friction is self-adjusting in nature. Adjusting in nature. For example, let us say that Dhanush, right? Dhanush had a birthday, right? And this is another kid, right? Okay, NZZ, right? This is Dhanush. Now, when he celebrated birthday, right? He invited NZZ, okay, that kid. So what is really happening? He gave him a gift. After the birthday party is over, what will you do? You will just open up the gift. You'll see what that guy has given me. Okay. He said he just opened up the gift and he found that, okay, there is an old crockery set he might have got somewhere in some party, and that he just, gave that gift to me. Then he said, okay, right, I will give the same stuff in his birthday, right? So what will happen? When he invited Dhanush to his birthday and opened up the gift, now NZZ is opening what Dhanush has given. He found that again, the same crockery gift. So whatever you give, right, similar kind of gift you will get, right? That happens or not, right? My dear kids, friction is just like that. Static friction is self-adjusting in nature, right? even if this is, he is eating biryani, he could have given something, but he is not giving because he's saying, Dhanush, he didn't get, told me that particular answer in the exam. Okay, I will not give him, I'll give him a crockery set. So you see that even if static friction can be 50 Newton, but 50 Newton will not act all the time. Static friction is self-adjusting in nature, right? Understand that static friction is mu s into n. That is the maximum possible value of static friction. Let us say the normal reaction is mg 5 into 10. Let's say g is 10. So mg, normal reaction equals to mg. So which is 5 into 10, 50, right? Let's say mu s is 0.75, right? So 0.75 into 50. That is the maximum possible value of static friction. That will not act all the time, right? My dear kids, then when will the static friction act? Dhanush is thinking, when will the static friction act? Understand that, my dear kids. Static friction acts between two rough surfaces when two rough surfaces are in contact. Okay. Sir, previously two rough surfaces were in contact, but you said no static friction. Yes. But there is a tendency of motion, right? Two rough surfaces, when they have a tendency of motion, then the static friction starts coming into the picture. What is the meaning of tendency of motion? You see, this is the body, right? Or it's a very heavy almirah, right? Very heavy almirah placed on the surface, right? And I call Dhanush, come up, start pushing this almirah from point A to point B. Clearly, almirah is rough, surface is rough, almirah is very heavy, packed with this stuff. Now, Dhanush has all the crockery sets that he got in the birthday. That is packed in the almirah. Now he's pushing it, but the almirah is not moving. Right now, the static friction is there. And right now, what is happening? You see, because Dhanush is applying the force, right? Now the static friction is opposing it. Since he is applying a force, the body is not moving, almirah is not moving, but there is a tendency of motion. Got it? And since there is a tendency of motion because of the force applied by the Dhanush, there will be an opposing force. Got it? Right. So tendency of motion must be there so that static friction can act. You see that Dhanush is applying force, the almirah is not moving, the situation is static, right? It is static. But right now, you will get the static friction. Dhanush is applying, let's say the maximum possible value of static friction, which is mu s into n. Let's say that the coefficient of static friction over here between the almirah and the surface is 1. And let's say that almirah is 100 kg or 200 kg, right? So normal reaction is going to be 200 into g, right? So which is 200 into 10. So it is 2000 Newton, right? Dhanush applied the force of 100 Newton. How much, what will be the static friction right now? Tell me in the chat box, right? The static friction, the maximum possible static friction mu s into n comes out to be 2000 Newton, right? Dhanush is applying 100 Newton. What will be the static friction in this situation? What will be the static friction in this situation? Very good. What will be the static friction in this situation? Very good. Very good, Dhanush. Very good. All right. You see that? Even if 2000 Newton can act, this is the maximum possible value, but you will not get 2000 Newton, right? You are only applying 100. So right now the static friction is 100. When he applies 200, the static friction is 200. And think about it. When he is not applying anything, the static friction will not be anything. It will be 0. Got it? Right? This is the main idea I want to tell you, right? And this is why in this situation, there is no external force. There is, even though there are rough surfaces, there are two rough surfaces in contact. But in this situation, when the block is placed on the surface, there is no tendency of motion, right? There is no tendency of motion. That's why there is no static friction, 0 static friction right now. I hope the concept is clear, everybody. Very good. Concept is clear, everybody? Okay. Now look at this question and try to solve it. Now you can solve it, everybody. I knew that most of the kids will commit this mistake, which is why I picked this question from the NEET 2023. Right here, the body is placed on this block, right? But right now, this is not placed on the horizontal surface; it is placed on an inclined surface, right? So a component of weight wants to push it, right? There will be a weight will be acting downward, mg. A component of the weight is trying to slide it downwards, right? But still the block is not sliding. That means it is being opposed by the static friction, right? Look at the question. A block of mass 2 kg is placed on the inclined rough surface of coefficient of friction mu. If g is 10, the net force on the block will be, because it is placed, it is not moving. That means the static friction is balancing the force which is pushing it. Yes or no? Dhanush is pushing the Almira with 100 Newton, but the Almira is not moving. That means the static friction offered is same as the force applied by Dhanush, 100 Newton. So clearly, the component of weight is moving it, trying to move it downwards. There is a tendency of motion, but there is no real motion. So we can say that right now, these two forces must be same. These two forces must be same. Okay. What will be the net force on the block? What will be the net force on the block? Very good. Try to answer it in the chat box. Everybody has, everybody has understood the concept. So you can now explain it very well. Right. Whoa, whoa, whoa. Awesome. Everybody understood the concept? Concept is the king, right? Those who have understood the concept can solve any question. B 0. Clear? Because it is placed clearly, the whatever force is acting downward, same force must be acting upward. That is why it is not moving. We don't have to solve it. It is B, right? But if you want to put the values, you can just put the values of everything and you will again get the value 0, right? Now circular motion, and a few kids are talking about the brake thing. Acha. Acha, do one thing. Let's do circular motion, then we will do the brake, right? Okay. Let's take circular motion and after that we will take a little break, right? Okay. Let's do circular motion, then we will take a little break, right? So read the question of circular motion. Question is saying that a mass m is attached to a thin wire and whirled in a vertical circle. Right? The wire is most likely to break when inclined at an angle of 60 from the vertical. The mass is at the highest point. The wire is horizontal. The mass is at the lowest point. Right? Think about it. We have a mass hanging off over here and it is moving in a vertical circle, at which point the rope is most likely to break, right? Answer it in the chat box. And we have starting the poll. This is the previous poll. Yeah. Just a second. Okay, so now this is the question. Try to solve it. Now answer it in the chat box. Think about it. With common sense, you can think about that the rope is most likely to break at the point where the tension in the rope is maximum, right? When the rope is at the topmost point, when the bob is at the topmost point, think about it. The weight of the bob is acting downward, right? And when the weight of the bob is acting downward, the rope wants to slack. Yes or no? But over here, when the bob is over here, the weight of the bob is acting downward and there is maximum tension in the rope. So the maximum chances are there when the bob is at the downmost point, bottommost point, right? So option D is correct. Some kids gave the correct answer and the fastest answer was given by Dhanush, right? Now let's move on and talk about the next one. What is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop, right? So what will be the velocity at which it should enter the loop, right? So that it can complete the loop. So what will be the velocity over here at which it must enter the vertical circle so that it can complete the loop? So very simple standard problem, right? Tell me the minimum velocity it needs to have. Answer it in the chat box. The minimum velocity it needs to have at the starting point so that it can complete the loop is how much? Very good. Option B is correct, root 5 GR. Array, what is the velocity at which you must launch it, right? You must be launching at root 5 GR so that it can complete the loop, na? Root 5 GR. Now let's move on and talk about the next one. A child is sitting on a swing. Its minimum and maximum height from the ground is 0.75 and 2 respectively. Its maximum speed will be. What will be the maximum speed? What will be the maximum speed, right? You see, a child is there. The minimum height from the ground is something which is given as 0.75 meter. And maximum height from the ground is 2 meter, right? So what will be the maximum speed? So you see that you take the swing backwards. Now the height is maximum, right? Right now the height is 0.75 from the ground. You take the swing backwards and the height from the ground right now is 2 meters. Now you release it. So clearly it will gain the kinetic energy, right? What you have done, you have increased the potential energy by increasing the height of the swing, right? You have increased the potential energy and all the potential energy will convert to kinetic. And over here, it will have maximum velocity, right? Now you have to answer. Think about 60 seconds. Whatever difference of potential energy you have created, that is now slowly transferring to the kinetic energy. And at this point, again, the kinetic energy is maximum. Answer it in the chat box. So what is the difference of potential energy you have created? Over here it is mgh1, over here it is mgh2. So difference is created as mgh2 minus h1. This is the difference of potential energy you have created, right? Whatever difference extra potential energy you gave, that will convert to the kinetic energy, right? And will give you half mv square, right? So mass is cancelled out. The value of g can taken as 10. It is 1.25 and 2 will be taken out here, right? And it is v square. So v square is 25, right? 25. So v is 5. I hope that is clear. Option B is correct. Okay. Let's look at the next one, right? It was a very simple question, right? It was a very simple question, right? Why did this question had a mistake? I believe you understood that where was the problem, right? Okay, so 25 is the answer. Velocity is going to be, you see there, 1.25 into 10 is 12.5, 12.5 into 2 is 25, and the root of 25 is 5, right? So it's a very common sense based question now. Whatever increase of potential energy you have, right? Whatever increase of extra potential energy you have, that will convert to kinetic energy, right? And that will give you the velocity value. Look at this question. As shown in the figure, A mass is performing vertical circular motion. The average velocity of the particle is increased. Then at which point the string might break, right? A, B, C, D. At which point the string might break? So answer it in the chat box. At which point the string might break? We can say that the string might break at a point where the tension in the rope is maximum. We have done this particular problem, right? You see that it is repeating. Why I picked this particular question? Just to show you that in the NEET question, the concept of the question can repeat. Definitely the language of the question, the diagram is changed, but the concept is exactly the same, right? Very good. Every kid is giving the correct answer. Every kid is giving the correct answer. All right. And let's see that how much time is remaining. Every kid is giving the correct answer. And let's see. Yeah. But still, few kids always manage to give the wrong answer. Why? Why? At point D, you are breaking the rope at point D for no reason. Why? All right. So now let's talk about the next chapter, which is work, energy, and power. Should we solve it or should we take a break right now? If you have energy, I have energy, I can go ahead. If you guys can go ahead, then I will go ahead, right? So let's solve the question of work, power, energy. How many kids want the break right now? Hello, Rajeshri. Hello. Break. Banking of road concept. That particular banking of road concept, I can explain in a separate video, but it's a large concept, right? So there are 3 variations in it. Okay. So at this particular moment, what I'll suggest you, my dear kid, if you are weak with a certain concept, make sure that like in this particular lecture, I have already given you the previous year questions only. So they are not asking very difficult question from these chapters, right? So you can keep it for now. Don't study anything new specifically right now, right? Chalo, koi baat nahi. Okay, so I'm giving you a little break, right? Of 15 minutes, right? We'll come back. It is 3:28. So we will come back around 3:40, 3:45. Let's call it 3:40. 12-minute ka break. So we will come back at 3:40, right? Okay. So this is it, right? Have some water. We will come back at 3:40. Okay. All right. Hello. All right. So let's continue. Okay. So let's continue with work power energy. Let's solve some questions from here as well. Right. Okay. Shall we? Okay. Quickly come up and we will start right away with the part where we left from work power energy. We will start right away from here. Okay. All right. So let's start. Okay. So this is the first question of work power energy. Have a look at this question and try to solve it. Okay. Have a look at this question and try to solve it. The kinetic energies of two similar cars, A and B, are 100 joule and 225 joule. Right? The kinetic energy of two similar cars is given. That means the mass is same and everything. 100 joule and 225 joules. On applying brakes, the car A stops after 1000 meters and car B stops after 1500 meters. Okay, so the friction force is doing some work, right? So if FA and FB are the forces applied by the brakes on the car A and car B respectively, then the ratio of FA upon FB is, then what would be the ratio of FA upon FB? Right? What would be the ratio of FA upon FB? Okay, this is what we have to figure out. My dear kids, this particular question is based on a very simple concept, but if you know, you can directly go ahead and try to solve it. You have 90 seconds to solve it by yourself, and meanwhile I am explaining you the thing, right? My dear kids, the simplest form of work energy theorem says that this question is based on work energy theorem. It says that whenever work is done by all the external forces, right, then the total work done by individual forces, if you just add it up, right, that will reflect in the change in kinetic energy, right? So work done by the force 1 plus work done by the force 2 plus work done by the force 3 plus and so on, that will reflect as a change in the kinetic energy of the body. Okay, right? So right now we are looking at a body, we are looking at the car number 1, right? Let's call it car A. And then we are also looking at another car, let's call it car B, right? So the car A has a kinetic energy of 100 joule and the car B has a kinetic energy of 225 joule, right? It is given in the question. Now on applying the brakes, 1000 meters and 1500 meters. So the car A stops at 1000 meters and the car B stops after 1500 meter. Clear? So what is actually stopping the car? Clearly the work done by the brakes, right? Brakes are applied. That means a braking force is there. So brake is applied in this direction. Let us say that brake is working in this direction, right? So those brakes are trying to stop the car. Here the brakes are continued working for 1000 meters and then the car is stopping. That means the final kinetic energy is 0. And here the brakes kept on working for 1500 meters and after working for that much displacement, the final kinetic energy becomes 0, right? So my dear kids, you know that the change of kinetic energy that we get in the body is equal to the work done by the forces. So the change of kinetic energy is from 100 to 0. We eventually stopped the car. So change of kinetic energy is equal to the work done. Let's call it the friction force here is F, right? And the work done is displacement is 1000. Both of them are in the same direction, right? So the friction force into F into 1000 is going to be this much. Yes or no? Right? F into 1000 is going to be this much. I believe the idea is very, very clear. Any problem with this part? Right? This is the friction force on the first car. Let's call it friction force on the first car. And here what is happening? The change of kinetic energy 225 minus 0, which is 225. The change of kinetic energy equals to work done. So what is work done? Force in the B into 1500. Right? Now what you need to do is you have to talk about the ratio of FA and FB. So you can just divide the whole thing. Right? You just put the whole thing over here. This is 225 and this is FB into 1500. Now you just have to solve it. These zeros will cancel out. This is 2, this is 3, right? And here it is 20 and all right. and this is all right. So now we can continue to solve it. Four is to 9. So this become 2 and this becomes 3. So 2 is to 3 comes out to be the ratio, right? I hope that is very, very clear. So option D comes out to be the correct option. All right. So here the first answer was given by Mahesh and then we have Vagesh. All right. Good. So D 2 by 3 is the correct answer. 2 by 3 is the correct answer, right? Okay. All right. So let's move on and talk about the next one. Now look at the question. A particle of mass 5m at rest, right? At rest suddenly breaks on its own into 3 fragments, right? A particle has a mass 5m. Suddenly it breaks into 3 fragments. My dear kids, are you applying the force to break it? No. Is there any external force which is written in the question that is applied on it and then it broke? No. Suddenly it broke into the fragments, right? 2 fragments of mass m each move along mutually perpendicular direction with speed v each, right? 2 fragments of mass m each move along mutually perpendicular direction with speed v. The energy released during the process is, how much energy is released during the process, right? Let's try and understand that. Let's try to understand the concept of the question, and meanwhile those who can solve it should move ahead and try to solve these kind of questions, right? This is the concept of the question. My dear kids, clearly here we can say that this particular body is exploding, right? And there are 3 parts that are coming out of it. The total mass right now is 5m, right? The mass right now is 5m. It is breaking into 3 fragments, right? 2 fragments of mass m each move along the mutually perpendicular direction. So one fragment of mass m moves here, other fragment of mass m moves here, right? And they move with the same velocities, right? 2 fragments of mass move perpendicular in the direction with the same speed v, right? So it is moving with the speed v in the speed v, all right? Okay. The energy released in the process. So my dear kids, the third fragment total is 5m, m and m is removed, the remaining mass 3m has to move as well. So right now you see that after explosion the remaining third mass is also moving in this direction, 3m, right? With a velocity, let's call it v dash, right? How much energy is released in the process? We can say that this one has an energy half mv square. This one has an energy half mv square. And this one has an energy half, m is 3m and v is v dash square, all right? If we can calculate v dash, because we don't know what is v dash, we have assumed it, right? We know this is the known variable in the question. So we have to just add up the energy of all 3 particles. That will give us the value of total energy released in the explosion, right? Total energy released in the explosion. My dear kids, our journey is just to calculate about the v dash value. How can you do that? So to do that, we can simply use the law of conservation of momentum. My dear kids, before we had one body of mass 5m, and due to the explosion, suddenly it broke apart into 3 parts. Here, the external force was 0, right? And you know that force is rate of change of momentum. That rate of change of momentum is 0. That means the momentum of the body is not changing, right? There is no external force. That means the momentum of the body will not change. Initially, the body was stationary, so momentum was 0. After splitting into 3 parts, the net momentum is still be 0. Because the previous momentum was 0, so net momentum still should be 0. I believe that is very, very clear, right? So total momentum before and after splitting must remain same. This is the main concept, right? So over here, what is the net momentum? We can say that the resultant of these two must be balancing out this one. So 3m into v dash, right, must be balanced out by the resultant momentum of these two things. So under root mv so this is 0. I hope that is very, very clear. So just from here, you can get the value of V dash, right? So just equate it. The resultant of these two momentum must be balanced out by the third one. You can say that, and you can get the value of V dash from here, right? So over here, you can see, right, 3mv dash is equals to root 2mv from here. 3mv dash, resultant of this V and V is root 2V, right? So the root 2mv, right? And from that, we can get the value of V dash is root 2V upon 3. So from here, we can get the value of V dash is root 2V upon 3. No problem with that. So now the net kinetic and the net energy released in the process is half mv square plus half mv square plus half 3m into V dash square. Just put the value and just add it up. And that should give you the answer. So here you just add it up, right? 2 times half mv square. So half mv square plus half mv square is 2 times half mv square plus the energy of the third body, which is half m is 3m and V dash square. So mv square and V dash is this. So just square it and you will have the final value 4 by 3 mv square. That is the answer, right? So let's see that how many kids actually could solve this question. 4 by 3 mv square is option D. So no problem. Right. So it was a good question. Right. So these kind of questions are repeated, right? When a body is breaking apart into 2 parts or 3 parts, right? So we have to talk about those situations, right? This is a very repeated kind of pattern, right? So if you don't know how to solve it, I believe right now I have explained you the concept and you can solve it going further, right? Okay. So have a look at this particular part. A body constrained to move in the y direction is subjected to a force given by this equation, right? The work done by this force in moving the body through a distance of 10 joule, 10 j meter along the y-axis, 10 j cap. J cap is a unit vector along y-axis. So this is how much displacement we are giving it. This is what is the force we are giving it. We know the force, we know the displacement. We want to know that the work done, right? It is asked way back in 1994, right? But it's a very good concept. Okay, the similar kind of concept is repeated multiple times. The force is given in the vector format, displacement given in the vector format, and you have to talk about the work done. So try to answer it. Very simple question, and everybody should be able to answer it, right? Force is given in the vector format, displacement is given in the vector format. What will the value of work done? So concept is simple. Work done is equals to force vector dot displacement vector, right? So force vector is given to you minus 2i plus 15j plus 6k dot displacement vector. So displacement vector is 10j, right? So dot product of same unit vector becomes 1. For different unit vector, it becomes 0. So with 2i and 6k, there will be no unit vectors. With 15j and 10, it will be some value. So 15 into 10 is 150. Right, dot product of this I and j and I and k, dot product of perpendicular vector will become 0, right? So this is how the 150 will be the correct answer, which is the option A, right? So I hope that it is very, very clear. Okay, so this time Praveen, Sudha and Dhanush, they give the fastest answers. Very good. So I believe that is very, very clear. So here we have this particular thing. Right. Let's keep on moving and talk about one more part. Work done by variable force. So far what we have done, we had a constant force. The car is moving, we applied the brake, the car is stopping after some distance and all. In all those situations, we have a constant force. But right now, we will be looking at situations where we will be having variable force, right? So what will be the value of work done by the variable force? Have a look at this situation, right? This question is asked in the previous year NEET again. Look at that. Force is 20 plus 10y. It is acting on a particle in y direction where force is in Newton and y is in meter. Work done by this force to move the particle from 0 to 1 meter is going to be. My dear kids, how to do that? Think about it. For 60 seconds, you can solve it. For those who cannot solve it, there is a concept over here. So clearly we can say that work done by variable force is integral of f dx, initial value of displacement to the final value of displacement, right? That's how you can get it, right? Simply you have to just integrate and you will get the answer. Okay, that's it. So you see that the force is 20 plus 10y, the particle is moving in the y direction, right? And the work is done from 0 to 1 meter. So clearly just have to do that integral. We are integrating with respect to y now, 20 plus 10y dy, and the initial point is 0 and the final point is 1. So 20y learn 10y square by 2 and put the limits 0 and 1. Upper limit minus lower limit, that is the answer. At lower limit it will be 0. At upper limit it is 20 plus 5, which is 25. I hope the idea is very, very clear. So 25 joule is the correct answer. Let's see how many kids actually gave the correct answer, which is option D. Okay. All right. So option D is the correct option, right? In this situation, option D is the correct option in this situation, right? Okay. Look at one more question, right? Look at one more question. Again, we have variable situation going on, right? But the graphical part is involved, right? A force F is acting on the particle, right? Acting on an object, and the force is varying with distance as shown in the figure. The force is in Newton and x is in meter. The force is in Newton and the displacement is in meter, right? The work done by the force in moving the object from x equals to 0 to x equals to 6. The work done in moving the particle from x equals to 0 to x equals to 6 will be. So what will be the value of work done in this situation? What will be the value of work done in this situation? This is what you have to answer, right? Again, very simple question. What will be the value of work done in this situation? My dear kids, we have force displacement diagram, right? In the force displacement diagram, area under the curve gives us the value of work done, right? In the force displacement diagram, area under the curve gives us the value of work done. So clearly, either you can take the area of rectangle and triangle and add them up, or you can take a trapezium and get the value of total work done, which is 1 upon 2 summation of parallel sides, right? Which is, how much is this? 3. And this side is 6 into distance between them, which is 3, right? That's it. All right. So let's keep on moving and talk about the next one. $13.5 should be the correct answer. And let's see how many kids actually gave the correct answer. So option B, yeah. Fastest answer was given by Dhanush here. Then Rajashri, when we have another Dhanush Naik, and then we have Sudha. Okay, good. Let's keep on moving and talk about the next one. The potential energy of a long spring when stretched by 2 cm is U. If the spring is stretched by 8 cm, the potential energy stored in it will be, right? So what will be the potential energy? Now you know that in a spring, when you stretch it for a displacement x, the potential energy is half kx square, right? The potential energy is half kx square, right? This is the concept. Okay. The potential energy stored in the spring is half kx square. Now, because we have the same spring, a long spring is stretched by 2 cm, the potential energy is U, right? And when we are stretching it by 8 cm, what will be the new energy? So let's say that you are stretching it by 8 cm. So in place of displacement, you can put 2 square, and now in place of U dash, you can put 8 square. Na? All right. So just divide it. Half k and half k will cancel out. It will be 4 upon 64, which is 1 by 16. So clearly you can say that U dash is 16 times of previous value, All right. So you see that now you are stretching. You are stretching by 4 times. Previously you were stretching by 2. Now you are stretching by 8, right? You are stretching by 4 times, right? And the potential energy is 4 square times. Clearly, from the equation it is clear. We don't have to solve it. The potential energy depends on a square of deformation. So if the deformation is doubled, potential energy will be square of that. So 2 square potentially become 4 times. If the deformation is tripled, so the potential energy will be 3 square, which is 9 times. If deformation is 4 times, the potential energy will become square of 4, which is 16 times. I believe the idea is very, very clear, right? All right, so let's keep on moving and talk about the next one. 16U is the answer, my dear kids. Okay, I didn't start the poll this time. No worries. Let's talk about the next part. B is correct. Very good, Mahesh. Very good. Very good. Let's talk about the next one. Look at this question. A bomb of mass 30 kg is at rest. It is exploding into two pieces of masses 18 and 12. The velocity of 18 kg mass is 6. The kinetic energy of the other mass is going to be. So 30 kg is dividing into 18 and 12. It is exploding. So explosion happens because of external forces or internal forces. Explosion happens because of external forces or internal forces. We can say that. Explosion will happen because of external forces. So we have a mass of 30 kg. It will split up into two parts, 18 and 12, right? The velocity of 18 kilogram mass is 6 meter per second. So it is moving with 6 meter per second, right? Now let us say that is moving with velocity v, right? Now, what will be the kinetic energy of the other mass? They are asking about, first you need to get the velocity of the other mass, right? By conservation of momentum, before exploding, the body was stationary, right? So its momentum was 0, okay? After explosion, the net momentum should be the same, right? So, or you can say momentum of this and momentum of that should be same. So 18 into 6 is equals to 12 into v. So we can say one step over here. 18 into 6 is same as 12 into v. So 2 and 9. So the other body will move at 9 meter per second and the kinetic energy will become 12 into half mv square. So that's it. Just multiply it and that should give you the answer, right? That should give you the answer. Any problem in that? All right. So let's move on and talk about the next one. A particle of mass m1 is moving with a velocity v1. Another particle of mass m2 is moving velocity v2. Both of them have the same momentum, but their different kinetic energies are e1 and e2 respectively. If m1 is more than m2, then which of them is following? Which of the following is actually correct? Right? So look at that. If particle of mass m1 is moving with velocity v1, particle of mass m2 is moving with velocity v2, right? Both of them have the same momentum, but their different kinetic energies are e1 and e2 respectively. If m1 is more than m2, then which of the following relation is going to be correct? Very simple question. Very simple question. Think about it. m1 is moving with velocity v1, m2 is moving with velocity v2. Both of them have same momentum, but their kinetic energies are e1 and e2. So you can also use the relation between, you can also use, first you can try to solve, right? Dhanush is saying C. Okay. Another Dhanush is saying A. Good. Very good. Mahesh is saying C. All right. Rashri is saying C. All right. So let's think about it. Is there any relation between kinetic energy and momentum? You can say yes. Momentum depends on mass and velocity. Yes or no? And kinetic energy also depends on mass and velocity. Okay. Kinetic energy is half mv square and momentum is m into v. So if I multiply and divide by mass, you see that m square and v square we have in the numerator and we have 2m. So we have square of momentum and twice of mass. This is the kinetic energy. Square of momentum and twice of mass, right? Now in the question they are saying both of them have the same momentum, but their different kinetic energies are even in E2. Clearly, momentum are same, but the kinetic energy are different. Okay. So the particle have mass m1 and m2, velocity is v1 and v2, right? Mass m1 and m2, velocity are v1 and v2. Both have same momentum. Let's call the momentum is p and p, right? The kinetic energies are E1 and E2. The kinetic energy of this one is E1 and E2. So we want to know that what will be E1 and E2. So clearly E1 can be written as momentum of first square. So momentum is same upon twice of mass ratio. For the second one, momentum is same, mass is different, right? E1 upon E2 is going to be M2 upon M1, right? We want to know the ratio of E1 upon E2, right? And it is given M1 is more than M2. M1 is more than M2. M1 is more than M2. Put like this. M1 is more than M2. Now think about it. What will be the ratio? E1 is lesser and E2 is higher. Yes or no? E1 is lesser and E2 is higher. Got the idea? So E1 is less than E2. Right? Because M1 is more than M2. So that means whatever in the denominator is higher. So E2 is bigger than E1. Right? E2 is bigger than E1. Is that clear? Option C is the correct option. Right? Most of the kids are correct in this one. And the fastest kid was, I could not read it, no problem. Let's move on and talk about the next one. Now the next question is from the gravitation. Read the question. Radius of Martian orbit around the sun is about 4 times the radius of orbit of Mercury. Okay. The Martian year is 687 Earth days. Then which of the following is the length of 1 year on Mercury? Which of the following is length of 1 year on the Mercury? Right. 172 Earth days, 124 Earth days, 88 Earth days to 25 Earth days. Think about it. Right. I'll give you 2 minutes to think about. Very simple concept is there. A Martian orbit is, a Martian orbit is around the sun is about 4 times the orbit of Mercury. Right. So clearly we can say that the planet which is further away from the sun will take more time to complete the orbit. Okay. And Martian orbit is 4 times bigger than that of Mercury. Mercury is close, Mars is further away. So Martian orbit is 4 times that of Mercury. So clearly it will take more time to orbit as well, right? And here we can use Kepler's law of orbiting time, right? So Kepler's law for the orbiting time is this: a square of time period is proportional to cube of radius, cube of orbiting radius. A square of time period is proportional to cube of orbiting radius. So clearly we can say that time period for Mercury is equals to, let's say, k times radius of orbiting radius of Mercury ka cube. And here Mercury, and after the Mercury we have the other thing called Mars. So square of Martian time is orbiting radius cubed, right? So just take the ratio, k will be cancelled out, and the time period of time period of Mercury versus Mars will come into the picture. Time period of Mercury versus time period of Mars will come into the picture. That is squared, right? And here they are giving us the orbiting, the radius of Martian orbit is around 4 times of radius of Mercury. So you see that Martian orbit is 4 times that of Mercury, right? So we have radius of Mercury and radius of Mars, right? So in place of that, we can put 4 times radius of Mercury and the whole thing is cubed. So this is cancelled out, right? So time period of Mercury and time period of Mars is under root 1 upon 4 cubed. So 4 cube is 64, right? Under root of 64 is 1:8, right? So this is the ratio, okay? Time for Mercury and time for Mars, this ratio is 1:8. Now they are giving us Martian year is 687. So 687 by 8, Mercury year will be Martian year by 8. 687 by 8. And that's it. That gives you the final answer, right? 687 by 8. I hope the idea is very, very clear. Right, so 687 by 8 is around 87 point something something. So around 88 days you will get. Right, so tell me, let's see how many kids actually got the correct answer. So everybody got the correct answer. Right, and Kohli was first this time. Tejas, and then we have Manjulata, then we have Sudha, then we have Rajashri. Very good. Let's keep on moving and talk about the next one. So the question is, a planet is moving along elliptical orbit, is closest to the sun at a distance r1 and farthest away at a distance r2. If v1 and v2 are the linear velocities and these points respectively, then what will the ratio of v1 is to v2? So try to solve it. A planet is moving along elliptical orbit and it is closest to the sun at a distance r1, farthest away at a distance r2. If v1 and v2 are the linear velocities of these points respectively, then what is the ratio of v1 is to v2? My dear kids, Kepler's law, according to Kepler's laws, we know that there is a law called Kepler's law of aerial velocity, right? We know when the planet is moving around the sun in the elliptical orbit, right, its velocity does not remain same all the time, right? Its velocity continues to change, but one thing stays the same in the entire journey. This is the elliptical orbit. Here we have a sun, right? And then we have the planet. So if the velocity of the planet here is v1 and the velocity of the same planet is v2 over here, you can say that the velocity continues to change as it moves around the orbit. But one thing that remains the same is the angular momentum, right? As you know, if a particle is moving on the angular path and there is no external torque acting on it, right, we can say that the angular momentum will stay conserved. Yes or no? The angular momentum of this thing will stay conserved. That means if the mass of the planet is m, right, so we can say that m v1, and when it is at distance r1, so m v1 r1 is the angular momentum over here, and when it is at a distance r2, the angular momentum is m v2 r2, right? So that angular momentum will not change as the particle moves around the sun, right? So the angular momentum will not change. So we can say that m1 v1 r1 and m2 v2 r2, that should remain same. Yes or no? When the particle is moving in this particular fashion, it remains same, right? And here, since we are talking about the same planet, so m1 and m2 are essentially the same. So we can say that m1 and m2 are same. So v1 r1 is same as v2 r2. All right. So v1 and v2 are the linear velocities at these points respectively. Then the ratio of v1 upon v2 will be, so ratio of v1 upon v2 will be r2 upon r1. Right. Ratio of v1 upon v2 will be r2 upon r1, which is option B. Right. Let's see how many kids actually got the answer correct. Okay. Only few kids actually got the answer correct. Right. Okay. Only few kids actually got the answer correct. Very good. So this new kid is there, and then we have Sangeeta, and then we have Sudha. All right. Very nice. Okay. Let's keep on moving and talk about the next one. Let's keep on moving and talk about the next one. Look at this. A body of mass 60 grams experiences a gravitational force of 3 Newton when placed at a particular point. Okay. A body of mass 60 grams. A body of mass 60 grams experiences a gravitational force of 3 Newton. 3 Newton. 3 Newton. Okay. When it is placed at a particular point. The magnitude of gravitational field intensity at that very point is going to be. So what is the gravitational field intensity out of these things? My dear kids, the gravitational field intensity, how will you describe it? Gravitational field intensity is the force experienced by the unit mass placed at that particular point. Yes or no? For example, the gravitational force experienced by a mass which is at a distance r away from another mass, what is the gravitational force experienced by it? It is g m1 m2 upon r square, right? Or let's call m1 m2 is capital M and small m to make things easier. So you see that Here this is a small m and this is capital M. Now instead, here this is telling us force acting on the mass m, right? At the same point, at that particular place, if I put unit mass, right? If the mass is 1 kilogram, right? Then whatever force is experienced by the unit mass over there is the gravitational field intensity at that point. Yes or no? So if the mass is unit, that means force acting per unit mass. This is the gravitational field intensity over there. I hope that is very, very clear, right? Gm over r square. Gm over r square is the value of this thing. My dear kids, here it is written that the mass of the particle is 60 gram, right? And the value of force which is experienced by that is 60 gram particle is 3 Newton. So 3 Newton upon 60 gram, convert that into kilogram. 3 Newton upon 60 grams, convert that into kilograms. So divided by 1000. So this will become kilogram now. So 3 Newton upon 60 by 1000. That will be that this ratio of force per unit mass is actually the gravitational field intensity, Ig, right? This ratio is gravitational field intensity. That's it. This ratio is gravitational field intensity, right? So 3 upon 60 into 10 to the power minus 3. 60 into 10 to the power minus 3. That's the answer, right? So 3 is the force and 60 into 10 to the power minus 3 is that particular mass, and you divide it, the answer comes out to be 50. So 50 is option B. Let's see how many of you actually got the correct answer. Oh, no problem. Have a look at this particular question. An object of mass 100 kilograms falls from the point A to B. Object of mass 100 kilograms falls from the point A to B, as shown in the figure. The change in its weight corrected to the nearest integer is. The change in the weight corrected to the nearest integer is. My dear kids, when the distances are large, then in that case the value of g changes appreciably. Here, when the particle is at point A, it is at a distance twice of radius of Earth. So clearly there will be a very little value of acceleration due to gravity. And when it falls for a significant distance, here we will have another value of g, right? We have to talk about, due to that variation in the value of g, the weight will also change. We have to talk about what will be the change in the weight, right? We have to talk about what will be the change in the weight. So you can think about it and you can try to answer it. Right. You can think about it and you can try to answer it. Very good. Very good. All right. So as you know that from the surface, if there is a point at a height h, then what is the value of acceleration due to gravity at that point? So it is Re upon Re plus h whole square, right? So this is how you can get the value of the new value of g, you can say, right? And by comparing it, this is a new height. So the effective height that you will have over here, h 2Re minus Re upon 2. So it is 4Re by 2 and Re by 2, it is 3Re by 2, right? So at both the places you will get the new values of g dash, and by doing so you can get the weight at both places and subtract it, right? So how will you do that? So weight is mga first of all. So Re upon Re plus height at this thing. So it is 2Re, right? So we can say that the weight is mg upon 9, okay? In the second case, when it is dropped to a certain place, so now the height is 3Re by 2, right? The height is 3Re by 2. Just put it and you will have 4 mg upon 25, right? And now you can just subtract it. What is the difference of weight? The difference of weight, you can just subtract it. 11 mg upon 225, that is the answer, right? So yeah, upon solving, it comes out to be 49, which is option A. Right. Okay. So here the fastest answer was given by NZ. Finally is coming back to the picture. Sangeeta is she was there in the previous question as well. And then we have Patil, and then we have Mani and Yashvita. Okay. Let's move on and talk about the next one. Very simple question, right? Now this question is again coming from the previous year NEET question from the 2016, right? Look at the question: at what height from the surface of Earth the gravitational potential and the value of G, the gravitational potential and the value of G are respectively this. Take the radius of Earth is 6400 kilometers. So at what height you will have these values? At what height you will have these values? So the value of gravitational potential at a height h. What is the value of gravitational potential? We can say Gm upon Re plus h. Yes or no? Gm upon total distance, right? At a height h, this is Re, right? What is the total distance from the center? Re plus h. So R is the distance from the center. All right. So gravitational potential is given, right? And the value of at what height, surface of Earth, the gravitational potential and the value of G. So for the value of G at a certain height h, you can simply calculate Gm upon R plus h whole square, right? Gm upon R plus h square, right? So both the values we know already, right? We know what is the value of gravitational potential at a height h. We know what is the value of acceleration due to gravity at a height h. By looking into these things, right, all the values are given to you. By looking into these things, we can calculate the value of height, right? Everything is given to you, right? Vh is given and G is given, right? Everything is given to you, and by doing so, you can just calculate it, right? Two equations will be there, only h will be the unknown variable. Okay, so you see that in the first case Vh is Gm upon Re plus h, right? And the value of Gh is this. So just do that, right? And you will have the simple ratio, just equate it and you will have the simple ratio. H is coming out to be 2600 kilometers, right? Nothing very serious about this particular problem. I hope it's a very simple thing to solve, right? I hope this is very simple thing to solve, right? Okay, so let's have a look at some questions from the rotational part, right? And again, in the rotation, there can be indefinite number of difficult problems. But when you try to look at the PYQs, we will see that most of the questions are based on very simple concepts, right? So we are not going to leave those things, right? Okay. Look at this question for that matter. Omega 1, omega 2, omega 3 are the angular speed of second hand, minute hand, and hour hand of a smoothly running analog clock. So it's not tick analog clock, it's a smoothly running analog clock. Okay, respectively, but that tick doesn't matter at all. If x1, x2, x3 are their respective angular distances in 1 minute, then the factor which remains constant is, so you see that omega 1, omega 2 and omega 3 are given to you. So which factor is going to remain constant? Which of these things will remain constant, right? X1, X2, X3 are the X1, X2, X3 are the angular distances in 1 minute. So try to calculate the angular displacement of each one of them in 1 minute. Think about it, right? I'll not immediately tell you the solution for this one. It's a very good question and simply based on common sense, right? No special formula is applied in this particular question. It was asked in the NEET 2024. Very good question. Think about it. Think for a minute by yourself, right? We have three hands, right? Omega 1, omega 2, omega 3 are the angular velocity of the second hand, minute hand, and hour hand, right? Okay. And in 1 minute, this one is covering the displacement x1, angular distance x1. Second one is completing the angular displacement x2. The third one is completing the angular one x3, right? Right. X1, X2, X3 are the displacement covered in 1 minute. Think about it. All right. So those kids who are thinking about it should continue to think about it. For those kids who cannot think through, I am telling you the solution, right? So the concept is very simple, right? We just have to think about two things: angular velocity, omega, and we have to think about displacement, angular displacement, x. These are the two variables we have to think about in the question. Right, now you look at the clock. In the clock, you have seconds hand, right? Seconds hand, then you have minutes hand, and then you have hour hand, right? For the second hand, you can say that what is the angular velocity? How many radians it will cover per minute? Because we are talking about in 1 minute, no? So how many radians per minute, right? Omega 1, omega 2, omega 3 are for second hand, minute hand, and hour hand. So omega 1 is for the second hand, right? Omega 1 is for the second hand, omega 2 for the minute hand, and omega 3 for the hour hand. Angular velocity. What is omega 1? How many radians per minute? In 1 minute, second hand will complete the entire thing, right? 2 pi radian. So 2 pi radian per minute. What is the angular velocity of the minute's hand, right? What is the angular velocity of a minute hand? My dear kids, to complete the entire thing, minute hand will take 60 minutes, right? So 2 pi by 60 radian per minute. That is the angular velocity of minute's hand. What is the angular velocity of hour hand? Think of hour hand. My dear kids, hour hand will take 12 hours to complete 2 pi radians. So 2 pi divided by 12 into 60, that many radian per minute is the omega 3. My dear kids, now think about their angular displacements x1, x2, x3 in 1 minute. My dear kids, angular displacement x1 in 1 minute, what is the angle covered by the second hand? We can say 2 pi. Yes or no? In 1 second, what is the angular displacement covered by the thing? 2 pi. Right? 2 pi radian will be covered by the second's hand in 1 minute, right? Now, tell me, what is the angular displacement covered by the minute hand in 1 minute, right? Minute hand in 1 minute, x2. So 2 pi by 60. So these are all common sense, right? If you just think through, right, these things will be done very quickly, right? Okay, just to explain you, I am solving it in this way. So x3, similarly, x3 will be, we can simply say that the third one will complete how much angular displacement will it cover in 1 minute? We can say that 2 pi is the angular displacement, right? And in 1 minute, what is the angular displacement it is going to cover, right? So you see, 2 pi divided by, or 360 I should use, otherwise it will come out in radian per minute only, right? That doesn't matter. If I'm talking about the angular displacement, we can also write it down in radians as well. That doesn't matter. So it could be 360, right? It could be 360 by 60. So the second hand is covering every second 6 minutes, 6 degrees, right? And here we have 360 divided by, it will take 12 hours, right? So like that, right? So you see the ratio of omega 2 pi radian, and if I call this 360 also 2 pi radian, so omega 1 upon x1 is 1. Omega 2 pi by 60, this is also 2 pi by 60, it is coming out as 1. 2 pi by 12 into 60, 2 pi by 12 into 60, that is also coming out as 1, right? So we can simply say that the ratio of omega upon x1, omega 1, omega 2 upon x2, omega 3 upon x3, that stays constant, right? So we can say that the ratio of omega 1 upon x1, omega 2 upon x2, and omega 3 upon x3, that stays a constant. All right. That stays a constant. So option A is the correct option in this situation, right? Option A is the correct option in this situation. Okay. I believe that is very, very clear. Let's move on and talk about the next one. Look at this particular thing. First of all, let me see how many kids actually got it correct. So option A, I believe, is correct. Oh, most of the kids actually got it correct, which is nice. The angular acceleration of the body moving along the circumference of a circle is. Angular acceleration of a body moving along the circumference of the circle is. Tell me very quickly. Right. Angular acceleration of a body moving along the circle is. Yes. Fast. Chalo. Very quickly, just do that. 60 seconds. Angular acceleration of a body moving along a circle is along the tangent to its position, along the axis of the rotation, along the radius away from the center, along the radius towards the center. Quickly answer it. Very good. So the direction of angular acceleration is along the axis of rotation. Along the axis of rotation, right? So option B is the correct option, right? Option B is the correct option. Right? All right. So we are talking about the angular acceleration, right? So you see, some kids are saying that they are along the radius, but that is the centripetal acceleration, right? Some kids are giving the option A, along the tangent. That is the tangential acceleration, right? Angular acceleration is along the axis of this particular circular motion, right? So you see, this is the particle moving along the circle of this thing, right? There are three things associated with it, right? The first is acceleration, which is acting toward the center, centripetal acceleration. And this acceleration, which is linear, changing the linear velocity, this is the tangential acceleration. Centripetal acceleration keeps it on a circular path. Tangential acceleration changes the magnitude of linear velocity, right? We are talking about angular acceleration, the one that changes the angular velocity, right? So angular acceleration is perpendicular to the or you can say surface, or you can say along the axis of rotation. Got it? My dear kids, listen it one more time. Centripetal acceleration is towards the center, which is option D. Tangential acceleration, that changes the magnitude of linear velocity, which is tangential, which is option A, right? But you talk about the angular acceleration, it is along the axis. Angular acceleration is alpha. This is along the axis, right? Or axis of rotation. So it's a very good question. You see that you don't have to solve anything, but it is very conceptual question asked in the NEET 2023. Clear? Okay. All right. So let's move on and talk about the next one. Torque and angular momentum. Torque and angular momentum. Right. So let's have a look at this particular thing. Find the torque about the origin where the force is 3j cap acts on a particle whose position vector is 2k cap. Right. So the force is 3j cap. Right. And it is acting on a particle whose position vector is 2k cap. So r vector is given 2k cap, right, meter. We have to talk about the torque. Torque about the origin. So what is torque? Torque is r cross f, right? We have to take the cross product of these two things. Okay. R cross f. So you know that I, j and k. So I cross j will give you k. K cross I will give you j, and if you go in the opposite direction, j cross I will give you minus k, I cross k will give you minus j, and things like that. So when you are taking r cross f, right? Okay, I forgot to start the poll. 30 seconds. When you are doing r cross f, it is 2k into 3j, right? It is 2k cap into 3j cap. So it is 6 times k cap into j cap, right? So k cross j is minus I, right? K cross j is plus I, right? R cross f, right? So 3j cap and 2k cap, I, j and k. So we have to take j cross k or k cross j. K cross j, so it is minus I, right? K cross J is minus I. K cross J is minus I. So just put minus I here. So minus 6 I cap is the answer. Minus 6 I cap is the answer, which is option C. Minus 6 K cap is the answer, which is option C. Right. Everybody is correct. Very good. I don't need to explain it. That means, okay. So let's move on and talk about this one. The moment of force is F at this, about the point this is given by. So what will be the moment of force at this particular point? The force is acting at this point, right? You see that? Imagine that on the axis, X, Y, Z axis, the force is acting at this point, right? And we have to talk about the moment of this force. We have to talk about this particular point, right? So first of all, you need to know the position vector, R vector, which is R2 minus R1, right? Position vector you need to know, right? And once you know the position vector, R vector, and then F vector, you just multiply it, right? So you see that the force vector is given 4I, 5J, 6K. It is acting on a point 2, 0, minus 3. 2, 0, that means 2I, 0J, 3K, minus 3K, right? So this is the point where the force is acting. And we have to calculate the torque of this force about this other point. So the other point is 2I, 2 minus 2 minus 2, 2I minus 2J minus 2K, right? So you know that we know the position vector of these 2 points. So R2 minus R1 will give you the actual vector between these two, displacement vector. So R2 minus R1, subtract them. So R vector, this is R vector, is subtraction of these two. So 2I minus 2I plus 0J minus minus 2J, right? And plus minus 3K minus minus 2K, right? So that will give you the R vector. Once you know the R vector, you can multiply that cross product with F vector and you will have your answer, right? So here you have it. R2 minus R1, you will subtract it, right? And you will have this, you subtract it, and you will have, after subtraction, this is the final value, 0I, 2J minus K. And clearly, this position vector is there, and the force vector is already given to you. You just have to take the cross product. And how will you take the cross product? First line is IJK. You know, R vector has coefficient 0, 2, minus 1. So 0, 2, minus 1, R vector. And then we have the force vector. Force vector is 4, 5, minus 6. The coefficients are 4, 5, minus 6, and just solve it. You will have the value of torque, right? Okay. All right. Now let's move on and talk about the next one. Equilibrium of a rigid body. Equilibrium of a rigid body, right? So let's talk about this part. Here we have it. This is a rigid body, right? Forces are acting because of the weights are hanging 2 kg and m over here. This is this particular weight is hanging 20 centimeter from the point O. This particular point is 40 centimeter from the point O, and this weight is hanging at 160 centimeter from the point O, right? So we have a uniform rod of total length 200 centimeter. That means its weight will act at the center, right, which is at 50 centimeter from the point O, right? And the mass is 500 grams. So at 50 centimeter, sorry, at 100 centimeter, because 200 centimeter is the length, at the center the weight will act, right? How much is the weight? Half kilogram, 500 grams. So half into 500 grams into G. That is the weight acting downward. All right. So all these values are given to you. Find the value of M. Okay. So my dear kids, we can simply say that about this fulcrum or about any other point, you can calculate the total torque, and that net torque comes out to be 0, because this whole thing is under equilibrium, right? Because it is written that the whole rod is under equilibrium, right? So for that to be under equilibrium, we can say that the turning effect of all the clockwise torques and all the anti-clockwise torques must be same, right? So here you see that the weight is applied at 500 Newton, right? So we are calculating the net torque about the point C over here, about the balance. We are providing the balance over here now. So we are calculating the torque about it. So we can say that 2 kg, this is 20, this entire thing is 40, so the remaining thing is 20, right? And this is 100, and this is 40, so the remaining thing is 60, right? And clearly the other force is 160, right? 160, and from here to here it is 40. So this particular distance is 120, right? So clearly you can form an equation, 2 kilogram into 20, right? That is equals to 60 into 500 into g plus m into 120, right? So if you do that, 2g into dc, which is dc as I said is 20, right? 40 minus 20 is 20, and then we have zero point 0.5 g into this distance. So whatever distances I've already given you, you just have to put those distances. 60, that is the distance, right? That 60 is the distance, right? 100 minus 40, and just multiply it. So upon saying the clockwise torque is equals to anti-clockwise torque, you will get the net value of mass, right? Now, look at these questions of moment of inertia, right? This is the question I believe you can solve. Very interesting question. The radius of gyration of a solid sphere of the mass 5 kilogram about xy, right, is 5 meters as shown in the figure. The radius of a sphere is 5x upon root 7. Then the value of x is going to be, think about it and try to solve it. Think about it and try to solve it. Just a second. Hello. Thanks for waiting, everybody. So here we have to solve this particular question. So just tell me if you guys were able to solve it or not. Okay. All right. Kannada. You will get a teacher from Kannada as well. But for now, I believe you know English as well because the southern kids are very good in English, I believe. Right? Okay. Focus everybody. Focus everybody. Poll I can give you. Okay. Poll I can give you. The radius of gyration of a solid sphere of mass 5 kilogram about xy is 5 meter as shown in the figure. The radius of a sphere is 5x upon root 7. Then the value of x is, what is the value of x? Very good. Hello? Yeah. All right. So let's see. Most of the kids are giving an answer. Let's see who is actually correct. Okay. So I have solved this question multiple times. So I know the option D is correct. So let's see that. The fastest answer was given by Rajashri. Then we have Pallavi, we have Sudha. Kohli is also there. Dhanush is also there. So let's see that how to solve this particular question, right? So now to understand this particular situation, we have to talk about the radius of gyration, right? So we know the moment of inertia, right? Moment of inertia of solid sphere about this axis, which is touching it and passing from here, right? So it is 7 by 5 mr square, 7 by 5 mr square. The radius of gyration is this, right? 7 by 5 mr square, right? Okay, right. Now if I put Ixy equals to mk square, where k is radius of gyration, from here we can get the radius of gyration, just solve it. From here we can get the radius of gyration, which is this, right? Okay. Now, or we can get the radius in terms of radius of gyration like this, right? So here by comparing it, in this question, the radius of the sphere comes out to be this, right? In this question, the radius comes out to be this, 5x upon root 7. And instead of that, instead of x, we have root 5. So that will become your answer, right? So it's a very simple question. Look at this question. The moment of inertia of a thin rod about an axis passing through the midpoint of an x and perpendicular to the rod is 2400 grams per centimeter square. The length of the 400 gram rod is nearly how much? The length of the 400 gram rod is how much? Student asking, sir, is there any other way to solve this particular question? Yes, there are multiple ways to solve this question, right? First of all, you need to figure out what is the moment of inertia of this thing, right? And then with a standard formula for radius of gyration, you can go about that, right? Okay, focus everybody, right? The moment of inertia of a thin rod about an axis passing through the midpoint and perpendicular to the rod is 2400 grams, right? The length of the 400 gram rod is nearly how much? The length of the 400 gram rod is nearly how much? Very good. Think about it. These questions are free marks. These questions are just like free marks for you. बहुत बढ़िया. Very nice. Jayant, Dhanushri, very good. Nagacharya, Jayant, Vagesh, Sudha. Everybody is giving a very good correct answer, right? You know that for a rod, the moment of inertia is going to be ml square by 12, right? By simple logic, you can just go ahead and solve it. The radius of the moment of inertia for a rod is ml square by 12. Now you know that The moment of inertia of thin rod about an axis through the midpoint and perpendicular to it is given, right? Now, the length of the rod is 400. The length of the rod is this. 400 is near, and the mass is given, and the length is something you have to figure out, right? Just put the values. I is given to you, right? Mass is given to you. The length is something you have to figure out. Just put everything already, right? Free marks. These are free marks for you, right? It comes out to be 8.5. And let's see that how many kids are actually giving the correct answer. Most of the kids are giving the correct answer. Those kids who are not giving the correct answer might not be using the formula correctly, right? ml square by 12 is the simple formula for the moment of inertia, right? The ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the radius of gyration of thin hollow of same mass and radius about its axis is. So we have a solid sphere, and for the same mass and same radius we have a hollow sphere, right? So moment of inertia for this one and moment of inertia of this one, we are trying to the ratio of radius of gyration for this one and radius of gyration we are calculating, and then we are taking the ratio of both radii of gyration. What will be the ratio of, right? What will be the ratio of radii of gyration? Sir, can you take 2025 moment of inertia question? Yeah, sure. If I get another session here, I'll be definitely doing it. But for that, I have to take out some time. Very easy question again, right? Radius of gyration for the solid sphere, root 2 by 5 r. For the hollow sphere, root 2 by 3 r. Take the ratio, root 2 by 5 r is to root 2 by 3 r. That's it. So it 2 and 2 will cancel out. Root 3 by 5 will be the answer. So don't have to even solve it. Actually, none of these options is actually correct, but I hope they have not considered the under root part. Root 3 by 5 should be the answer, right? Root 3 by 5 is the answer. None of the option is correct, but 3 by 5, I believe all the options are considering an under root. So if you consider an under root by common sense, maybe they could not print it or something. So in that case, root 3 by 5, which is option C, should be correct answer. Right. All right. Let's move on and talk about the next one. Theorem of perpendicular and parallel axis. My dear kids, it's like I'm expecting that question from this particular theorem could be there in this year NEET, because what I've observed in the previous year patterns, this particular topic is becoming favorite of NTA from this chapter, right? So let's try to do it. Look at that. The ratio of radii of gyration of a thin uniform disk about an axis passing through its center and normal to its plane to the radius of gyration of the disk about its diameter is. So we have to talk about the radius of gyration for two different things. My dear kids, by considering the problems of radii of gyration, I am checking two concepts. Moment of inertia concept and the radius of gyration concept, right? Which is why I have picked those questions in which radius of gyration is asked. Right? So think about it. Very simple question. The ratio of the radii of gyration of thin uniform disk about an axis passing through the center and normal to the plane to the radii of gyration, right, of the disk about its diameter. It's a direct formula based question. Okay. So about the axis passing through the center, the radii of gyration will be r upon root 2, right? And about the diameter, it will be simply r upon 2, right? R upon root 2 and r upon 2. You just have to take the ratio of these two things. Yes or no? You have to just take the ratio of these two things. R upon root 2 and r upon 2. R upon root 2 and r upon 2. You just have to take the ratio of these two things. So option B will become correct. Very good. Everybody is giving the correct answer. Very good. So the fastest answer were given by Nagrajya, then Pallavi, then Vagnesh, and then we have Yashasvi, we have Kohli as well, and then we have Sudha and Timraj. All right. So let's continue to keep on moving in forward direction. From a circular circular of mass m and disk and radius r, an arc corresponding to the 90-degree sector is removed. Okay. All right. The moment of inertia of remaining part of the ring. So we have a circular ring. Ring is missing. We have a circular ring and we are removing an arc from the circular ring. This part we are removing. Okay. The moment of inertia of the remaining part of the ring. So this is the remaining part of the ring. Right. The moment of inertia of the remaining part of the ring and perpendicular to the plane of the ring is k times mr square. Then what will be the value of k? Right. So very simple question. Right. I believe you guys should give it a try. Okay. Think about it. Sagar is solving very good. Sudha is solving very nice. What is the moment of inertia of the ring about the axis mr square? Right. 1/4 is removed. So what will be the moment of inertia for the remaining part? mr square minus mr square by 4. 1/4 is removed. All right. So 3 mr square by 4. Yes or no? And to know the radius of gyration of any structure, the moment of inertia is 3 mr square. Total mr square minus mr square by 4. So 3 by 4 mr square for the remaining structure. The moment of inertia is this. And if the radius of gyration for this structure is k, then mk square must be equals to moment of inertia. M and m is removed. Yes or no? Yes. The moment of inertia of the remaining part of the ring about an axis passing through the center of the ring is perpendicular plane is k times mr square. So radius of gyration, they are not talking about the radius of gyration, right? So no problem with that. So 3 by 4 mr square is there. 3 by 4 mr square is there. So that should give you the answer itself. It's a very easy question then. Yeah. 3 by 4, option B is the correct option. No problem with that. Oh, everybody is correct this time. And Vagnesh is first. And then we have Dhanush, we have Sudha, we have Pallavi, we have Sagar. Okay. And Kohli is there from the beginning of the class till here. And Dhanush is also there. Very good. Very good effort. Center of mass. Try to solve some simple problems of center of mass. My dear guys, center of mass problems are not asked every single year. Sometimes they don't ask it. But in the previous years, if you may find it, that they are asking it. Right. And very simple set of questions are there. Right. Have a look at this question. This is asked in the NEET 2022. Two objects of mass 10 kg and 20 kg are respectively connected to the two ends of a rigid rod. Two masses are connected at two ends of a rigid rod. Okay. With negligible mass. The distance of center of mass of the system from the 10 kilogram mass is. Okay. The distance of center of mass of the system from the 10 kilogram mass is. So we have 10 kilo mass, 20 kilo mass, and this is the situation. 10 kilo, 20 kilo. Right? Okay. And the rod itself has negligible mass. The distance of center of mass of the system from the 10 kilogram mass. So let's say this is the center of mass, C, right? So what will be the location of center of mass? This is something you have to talk about. Very simple. 60 seconds are more than enough to solve this kind of question. 60 seconds is more than enough to solve this kind of question, right? Okay. So we have to talk about the distance from the 10. So we will assume that this particular mass is at the origin, 0, 0, right? We will assume that this mass is at the origin and then we will try to calculate it. We will assume that this mass is at the origin and then we will try to calculate it. All right. So assume that this is at the origin 0, comma 0. Okay. So location of center of mass is m1x1 plus m2x2 upon m1 plus m2. Right. So this is at the origin itself. So x1 is 0. So m1 into 0 plus 20 into this distance. Right. This rod is 10 meters. So m2 into x2, which is 10. So 20 into 10 upon m1 plus m2, 10 plus 20. Right. So 200 upon 10 plus 20 is 30. So 200 upon 30 is the location of center of mass. 200 upon 30 is 20 upon 3. So option B is the correct option. You don't have to solve it again. Very simple question. And most of the kids gave the correct answer. Fastest answer was given by Sagar this time. Then we have Nagaria, Rajashri, Dhanush, Pallavi, Yash, Dhanush. Okay. And Kohli is still there. Very good. Very good effort. Dhanush is also very regular right now. Rajashri, your name comes in and out. Both the Dhanush are very, very regular. Pallavi is also there. Very nice. Okay. Let's move on and talk about the next one. Two particles of mass 5 and 10 respectively are attached to the two ends of a rigid rod of length 1 meter with negligible mass. Okay. The center of mass of the system from the 5 kilogram particle is nearly at a distance of what? Center of mass of the system. So we have two particles, they see 5 kg and 10 kg respectively. They're attached to the two ends of a rigid rod of length 1 meter. So we have 1 meter rod and we have 5 kilogram and we have 10 kilogram. Right? And the length of this thing is 1 meter. Okay? With negligible mass. The center of mass of the system from the 5 kilogram particle, the center of mass of the system is nearly at a distance of, so this is the center of mass of the system, let us say. Again, you will assume that this is at the origin 0, comma 0. m1 x1 plus m2 x2 upon m1 plus m2. Same relation you have to apply. This itself is at the origin. So 5 into 0 plus 10 into 1 upon 5 plus 10. So 10 upon 15, 2 by 3. Right? 2 by 3. But the length we have used in meters and the answer is in centimeters. So 2 by 3 meters is how many centimeters? Convert it. Multiply by that by 100. 66, 67. 66.6 will come up now. 2 by 3 into 100. 33.3 into 2. 66.6. Round of 67. So option C should be the correct option. Oh, I didn't start the poll. But no worries. Let's continue to move on in the forward direction. We have two bodies, 1 and 3 kilograms. I have position vector, this and this. The center of mass of the system has a position vector. So we can say that center of mass is a position vector m1 r1 plus m2 r2 upon m1 plus m2. Simple. No worries about that. Right? It's Nagraj. Nagraj. Okay. I got it. I got your name. So m1 r1 plus m2 r2 upon m1 plus m2. No worries about this particular question. Right? Same questions is this as well. So these questions are very, very simple. Right. Now we have a second set of chapters, which is mechanical properties of solids, mechanical properties of fluids. Right. So this is what we are going to do. Right. And then we also have thermal properties of matter. Okay. So this is what we are going to do. We will enter, after this we will enter into the thermodynamics part, and then we have oscillation and waves, and then grade 11 part will be over. Right. Can this question comes in NEET or concept? In NEET, many times we have seen the concept is repeated. So nobody can tell you that this particular concept will be repeated. But yeah, what I have picked is from the previous year question papers, I have picked most interesting concepts, right? So I believe these questions are definitely going to help you in two ways. First, they will help you to assess that what is your level of preparation, because these are PYQs only. Na? So they will help you to understand where is your preparation level right now, right? And post that, they can also help you in other ways as well. Break. All right. So let's take a break of 10 minutes. Okay. So it's 5:06. We will come back at 5:20. Okay. We will come back at 5:20. Okay. And then we will start from mechanical properties of solids and then fluids and then this thing, right? These are the things we are going to start. All right. So have some water and we will come back. Hello. All right. So let's continue, my dear kids. Okay. Let's continue, my dear kids. Okay. Nagraj, very nice. I'll never forget your name now. Chalo. Okay, everybody. So let's allow everybody to join and start the lecture right away. Okay. All right. All right. So let's start right away, my dear kids. We'll be starting our journey with a chapter of mechanics of solids, right? And then we will talk about the remaining parts, right? Okay, let's have a look at that. So mechanical properties of solids, this is the first question that we have. The stress strain curve are drawn for two different materials, X and Y. It is observed that the ultimate strength point and the fracture point are close to each other for material X, but are far apart for material Y. We can say that the material X and Y are likely to be ductile and brittle, brittle and ductile, brittle and plastic, plastic and ductile. So these are the things that we have to think about, right? So now think about it. If we are trying to draw the stress strain curve, right, and we found out that this is the point of ultimate strength, and then before fracture, the particle can actually stretch a long wire, right? So if these 2 points are further apart, that means lot more strain, lot more deformation can happen before it fractures. If the fracture point is very close to this particular thing, ultimate tensile strength point, that means as soon as the body reaches its limit and you stretch it further, it doesn't stretch, rather it breaks, right? That means that's brittle. Okay. So what do you get from this particular part? What do you get from this idea? Think about it. We can say that the material for which the ultimate tensile strength point and the fracture point are further apart, that is ductile, and the other material is brittle. All right. Okay. Nice. It is observed that the ultimate strength point and fracture point are close to each other for material X and far apart for Y. So for the material for which it is far apart is ductile and the other one is brittle. So brittle and ductile is the answer, option B. Brittle and ductile is the answer, which is option B. Yes or no? Okay. Let's see that. How many of you are actually correct? Most of you are correct. But and out of these kids, Pallavi is fastest, then Vagnesh, Viv Sanjana, and Nagraj, Mamta, Rajashri, Dhanush, Kohli. All right. So slowly kids are coming back. So 2 or 3 questions they will miss and then they'll come back, I believe. The maximum elongation of a steel wire of 1 meter length, if the elastic limit of the steel and its Young's modulus respectively are this and that. So what will be the maximum elongation of steel wire if the elastic limit and its Young's modulus are given? Elastic limit is given and Young's modulus are given, right? So elastic limit will not help us, but the other things will help us definitely. Right. So yeah, try to think about it for a minute. Very simple kind of questions are there from these chapters. Very simple kind of questions, right? Direct application based, direct just formula based. All right. So for those kids who don't know the concept, let me just quickly brief you about the concept. Young's modulus is stress upon strain, right? So now they are giving us the value of elastic limit, right? So here we have it. And strain is something, maximum elongation of a steel wire we have to talk about. So strain is change in length upon original length, right? So the elastic limit we can put over here, right? When we put stress is maximum, right? At the elastic limit, the stress is maximum possible value, right? At the elastic limit, when you put stress equals to elastic limit, when you put stress equals to the elastic limit, you will have deformation as maximum deformation, right? Maximum deformation, right? So here, just if you want to solve it further, so maximum deformation you can calculate. This L will go up, right? L will go up, and Y you can take over here. So delta L is equals to elastic limit. Elastic limit in the numerator is in place of a stress, you have maximum value, which is elastic limit, and in the denominator you have length also will go up and Young's modulus will come down, right? This is the final expression. So elastic limit you can put 8 into the power 8. Y ki value, the value of Y you can put over here 2 into the power 11, and the value of length is 1 meter. Put L equals to 1 and you will have the final solution, right? Nice. All right. So let's see that many kids are giving the option A. So let's see that. By the way, it is also correct. So yeah, everybody gave the correct answer this time. I'm very happy. Pallavi is fastest. Then we have Nagraj, Sangeeta, Mamta, Rajashri, Sanjana, Kohli, and we have Sudha. Very nice. Let's move on and keep on talking about the next one, right? In grade 12, we will not be like solving these many problems. We will be quickly revising things, right? Concepts and all. And we will also look at some simpler problems just to refresh. That was my approach. Grade 11th, I will show you a lot of previous year questions. And grade 12th, I'll show you a lot of concepts, right? So let a wire be suspended from a ceiling. Wire is suspended from a ceiling, from a fixed rigid support, and it is stretched by the weight attached at its free end. The longitudinal stress at any point of cross-section area A of the wire is. So this is the fixed end and the wire is hanging and a weight is attached, right? So longitudinal stress we have to calculate. Very simple, right? I think you should not even invest 15 seconds to answer it, but I'll give you the minimum time, which is 30 seconds. Quickly answer it. What is the longitudinal stress? Deforming, we can say that in this situation at equilibrium, we can say that deforming force upon cross-sectional area. Deforming force is weight over here, W upon area. Quickly answer it. Quickly answer it. 15 seconds, that's it. Very nice. Very nice, very nice. So we can say that deforming force, stress is deforming force per unit area. So option D is correct. Nothing need to be solved. It is asked in NEET 2023. So from this chapter, you can always get a very, very simple question, right? Free marks. All right. Next question. A wire of length L, area of cross section A is hanging from a fixed support. The length of the wire changes from L1. The length of the wire changes to L2. Original length of the wire was L and it changes to L1. Original length was L and it changes to L1. Okay. When the mass M is suspended from its free end. When the mass M is suspended from its free end, it is stretching by a small amount. The expression for the Young's modulus is. What is the expression for the Young's modulus? What is the expression for the Young's modulus? Expression for the Young's modulus is stress upon strain. Stress is force per unit cross-sectional area. Strain is change in length upon original length, right? So you see that when the mass M is hanging, what is the deforming force? Mg, right? Stress, you can say that. Meanwhile, you can solve. Option D was correct in the previous one. Meanwhile, you can solve, right? So you can say stress is deforming force Mg upon cross-sectional area. Strain is change in length upon original length. Change in length is L1 minus L upon original length, right? Stress upon strain is the Young's modulus. So Mg upon A and strain is L1 minus L into L, right? So which expression is this? Option D. Very good, Dhanush. Very good, Nagarjun. Nagraj. Very good, Pallavi. Very good, very good, very good. Sangeeta. Sanjana, very good. Everybody. So option D is coming out to be the correct option. Everybody gave the correct answer. And the fastest answer was given by Pallavi Gowda. We have Nagraj, then we have Mamta, where we have Dhanush, Shankar. Kohli is always there. I mean, that's very much appreciable. Rajashri, Sudha, Sangeeta, Gagan, right? Great. Let's move on and talk about the next one. Two wires are made of same material and have the same volume. The first wire has cross-sectional area A and the second wire has cross-sectional area 3A. If the length of the first wire is increased by delta L on applying the force F, how much force is needed to stretch the second wire also by the same amount? Read the question. Very good question, or you can say decent enough question. You have the poll started right now. You can solve it, right? Two wires are made of the same material. Same material means same Young's modulus, and they have the same volume. Okay. If the first wire has cross sectional area A and the second wire has cross sectional area 3A. First wire has a cross sectional area A, right? The second wire has a cross sectional area 3A. My dear kids, because they have the same volume, second wire is much thicker, so it has to be shorter so that it can have same volume, right? If it is thicker, it has to be shorter so that it can have same volume, right? Now, the cross-sectional area is A, the length let us say is L, and the cross-sectional area here is 3A, the length let us call is L dash, right? Okay. If the length of the first wire is increased by delta L, right, on applying a force F, when you applied the force F, the length is increased by a small amount, delta L, right? How much force is needed to stretch the second wire by the same amount? So we want to stretch the second wire also by the same amount, delta L. And what is the force required? F dash. Simple, right? Simple or not? We can say that. Let's add a page. We know we will be using this formula again and again. So let me just quickly derive it for you. This is stress upon strain. Young's modulus is stress upon strain, right? Stress is F upon A, strain is delta L upon L. So Y is FL upon delta L into A, right? This is how you can use the Young's modulus, and every time you have to use deformation, delta L equals to FL upon AY, right? Now, this formula we'll be using again and again. So this is how it comes up, and every time in the future we are going to use it. This is how we can use it, right? So delta L deformation is FL upon AY. So here we have two wires, right? So for the first wire, in both the wires we want same deformation, right? In both the wires we want same deformation. In the first wire we have force F, length L, right? Length L, area A, and Young's modulus Y. In the second wire, because the same deformation we want in the second one as well. So force is F dash. Let's call the second one has force F dash. Length we don't know. Let's call the length of the second wire is L dash. Area of cross section is 3A and Young's modulus is Y. Okay. How can you get L dash? Because volume of both the wire is same, and volume is cross sectional area into length. Cross sectional area here is 3L and length is L dash. So we can say that L dash is going to be L by 3, right? So the length of the second wire L dash is going to be L by 3. In the same step, I am removing it. So L will be cancelled out, area will be cancelled out, Y will be cancelled out, right? So it is F dash upon 9. So F dash is equals to 9 times F. Alright, F dash equals to 9 times F. I believe the idea is very, very clear. Very simply we have solved it. Option A turns out to be correct. And let's see that how many of you are actually correct. Most of the kids are actually correct. And the fastest kid is Dhanush this time. Very good, Dhanush. And then we have Preetham, Mamta, Kohli is coming up, like he is consistently rising. Okay. Shankar is there, Pallavi is there, Risha is there, Sangeeta is there, Rajashri is there. Very nice. So I can see that. Nagraj is also there. So very good effort, Nagraj. Okay. Continue putting out effort, and you see that. The next question is this: the bulk modulus of the spherical object is B. The bulk modulus is B. If it is subjected to the uniform pressure P, the fractional decrease in the radius is going to be, right? Try to solve it. What will be the fractional decrease in the radius, right? Bulk modulus of the sphere is B, right? The bulk modulus of the sphere is given, and we have to talk about it is subjected to the uniform pressure, the fractional decrease in the radius. So with the help of bulk modulus, we will get the fractional change in the volume, and by using that, we can talk about the radius as well, right? What is bulk modulus? We can say pressure and delta V upon V, right? So B, this negative sign can be dropped. P delta V upon V, right? So with the help of bulk modulus, we can calculate the change in, or you can say volumetric stress delta V upon V, right? And by solving it, you can get the further value. Fractional decrease in the radius is going to be, right? Fractional change in the volume you can calculate, and by doing so, you can also go ahead and talk about the fractional change in radius. Right? What do we know? We will calculate, see that pressure is given, delta V upon V we will get from here, right? We know delta V upon V. What do we want to know in this one? Fractional change in the radius, delta R upon R. So we can easily get that. We can easily get that, right? Very good, very good, very good. So let's have a look at that, how to solve it. You know that bulk modulus is P upon delta V upon V. This V we are taking it on the numerator. P upon delta V upon V, right? Now volume is given this 4 by 3 pi r cube, right? And delta V, change in volume, is this, right? Change in volume is going to be this much. Okay, no problem with that, right? Okay, so what are we doing basically? So you just look at that, we have just differentiated it, right? So differentiation of r cube is 3r square into delta r, that's what we have written. So now we have V upon delta V, we are solving it, we will get this thing. V upon delta V is R 1 upon 3 R upon delta R. This is what we want to know, R upon delta R. Delta R upon R, in fact, right? So upon solving it, right, we will get B is PR upon 3 times delta R, and delta R upon R is going to be P upon 3B, right? So yeah, so let's look at this particular thing. Oh, by the way, who is correct in this one? P upon 3B, P upon 3B, option C. Okay, so let's see how many of you are actually correct. Most of you are actually correct. And again, Pallavi is again first in this one, and Kohli is in the top 3 now. And Rish, Govinda, Govda, Risha Goda is there as well. Very good. Sudha, Sangeeta. Okay, very nice, very nice, very nice efforts. Okay, all right. So let's talk about the next part. Okay, so the copper of fixed volume V is drawn into wire of length L. When the wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graph is a straight line? Which of the following graph is a straight line? This is what we have to calculate, right? Focus, everybody. Which of the following graph is going to be a straight line? Think about it. Copper of fixed volume V is drawn into the wire of length L. All right, so we are stretching it. When the wire is subjected to the constant force F, the extension produced in the wire is delta L. Which of the following graph is a straight line? My dear kids, we have to convert the formula for deformation. Deformation we have already calculated, right? I have already derived it. Delta L is equals to FL upon AY, right? My dear kids, this is dependent on length and area both. We want to talk about the length only. So you know that volume is area into length, right? So from here we can remove length and we can call it volume upon area. Volume upon area into Y, right? So now look at that. Oh, we have to remove area from here because we want to get the final expression in terms of length, right? So length, in place of area, you can put volume upon length. So volume and length will go up like this, right? So see that if you try to plot the graph between delta L and L, so here the power is 1, here the power is 2, the graph will come out parabolic, right? Delta L and L. But if you try to plot the graph between delta L and L square, then it is linear, right? You see that we want to plot the graph between delta N and in L, right? Both of them are proportional, good. But how will you get a linear graph, right? Which of the following graph is a straight line, right? So you can see that if A is proportional to B square, then if you try to plot the graph between A and B, you will get a parabolic graph, right? But if you try to draw the graph between quantity A and quantity B square, then you will get a straight line. Take B square as a single quantity, right? So we can say that the graph between delta N and L square will be a straight line. Okay. Right. So option B will be the correct option. Very good. Most of the kids are actually correct. And Risha Gowda, again, from the second, she is coming up to first. Then we have Nagraj. Very good. Rajashri, again, very consistent. Shankar, Sudha, very consistent. Sudha, Sanjana, Sangeeta, Pallavi, Tiganish, Preetha. Okay, very good. New kids are coming up in this one. And Dhanush is also there. So Dhanush, there were 2 Dhanush. Now there is only 1. Dhanush Gowda and Dhanush Nair. 2 people were there. Look at this one. The following 4 wires are made of same material. Which of these will have the largest extension when same tension is applied? Largest extension when the same tension is applied. So try to get an expression first, right? Try to get an expression first. You know that deformation is FL upon AY. Okay. So we know the length, we know the diameter, right? So these 4 wires are made of the same material. That means Y is same for all of them, right? And they are under the same tension. That means F is also same for all of them. So delta L depends on F upon Y, let us say, is a constant K, right? L upon A. So this ratio L upon A will decide the deformation, right? Take the ratio L upon A. The particle for which L upon A is higher will get more deformation, right? Remaining part is constant for every wire. So the particle for which L upon A is highest, right? You will get the highest deformation in that one, right? Think about it. Take the ratio of L upon A, L upon A, L upon A, L upon A. The highest one will have the highest answer, right? Instead, because the diameter is also given, so you can take the area as pi d square by 4, right? You can take L, you can take L upon pi d square by 4. So this pi and 4 will also become a constant, right? Pi and 4 can also be assumed to be constant. So it depends on L and d square. So it is much better to solve L and d square, right? Okay. So delta L depends on L and d square. So take the ratio of L and d square and say, where are you? Right. So L and D square, just take the ratio, and wherever you get the highest ratio will get the highest value of delta L. Think about it. Okay. Okay. All right. So let's see that how many kids are actually giving the correct answer right now. Everybody gave the correct answer. And again, the Pallavi is first. Dhanush is jumping up straight to the second point. And then we have Sudha, Parish, Mamta, Sanjana, Kohli and all. Right. Rajashri is there. Nikhil is new. And Kishan and Nagraj. Okay. Very good. Very good. So let's move on and talk about the next one. Right. So here you can see that delta L depends on L and D square. Right. We have just tried to get a single expression. And we got the L and D square for all of them. So the highest value of L and D square we have for the third one, which is the INSR. Now, here what is happening, if the ratio of diameter, length and Young's modulus of a steel copper wire are P, Q and S, ratio of diameters, length and Young's modulus. Okay. So ratio of diameter of steel and diameter of copper is P. Ratio of length of steel and length of copper is Q. Ratio of Young's modulus of steel and Young's modulus of copper is S. Then the corresponding ratio of increase in their length will be, the corresponding ratio in increase of their length would be. So very simple. Delta L, we know that delta L is FL upon AY. You see that? We are using this formula again and again. This is why I derived it, right? And you see that we are using again and again. We can simply talk about this particular part, FL upon AY, right? We can convert it into terms of diameter, right? And every other thing is same. Length, the ratio of length is given, the ratio of Y is given, the ratio of area is given. Delta L can be taken out as well. Pole. I forgot to give you the pole. Right. So here you have the pole. So over here, just a common sense, on the steel wire, we have this and this both, right? So 2 mg and 5 mg, 7 mg tension is there on the steel wire. So the deforming force F for the steel wire is 7 mg, and for the copper wire is only 5 mg, because only this much is hanging off a copper wire, right? Okay. So when you're going to take the delta L for steel wire, you will put the deforming force of both of these things, 7 mg. And when you take the deforming delta L for this copper wire, you will put the 5 mg. You see, very simple kind of questions are asked from this particular chapter, and these are free marks for you, right? Free marks for you. Yesterday you did this question, very nice. Crazy. And you see that same formula is helping us in so many different ways. Delta L is Fl upon Ay. So let's have a look at that. You see that delta L is Fn upon Ay, right? So just convert this in terms of diameter, because diameter is given. So pi d square by 4 and all, right? And now you try to take the ratio. All the constants will cancel out. So force on steel and force on copper. Then length of steel and length of copper, diameter of copper, diameter of steel, because it is in denominator, it will reverse. Similarly, Y is in the denominator, it is also reversed, right? So this is the ratio we are talking about, and all other things are given. We just put the values and we will have the final ratio. Okay. Nothing to be worried about. Simple question, simple answer. Option B is correct. And let's see that. Majority of the kids are giving the correct answer. And the fastest answer this time is Kishan, then Nagraj, then Nikhil. Okay. Abhishek, Pallavi, Sanjana, Dhanush. Both the Dhanush are there now. Okay. Pramod, Yashasvi, Sangeeta and Risha. Risha, very nice. Okay. Now let's move on and talk about the other part, which is mechanical properties of fluids, right? Mechanical properties of fluids. Okay. Leaderboard I will show you by the end of the class, right? Leaderboard I will show you in 2 stages. After grade 11th, I will show you the leaderboard for the grade 11th. It will tell you where you stand in the grade 11th PYQs, right? And after the grade 12th, in the grade 12th portion, I have not included many PYQs. Most of the concepts I have included in grade 12th, because as I said, grade 12th, we practice a lot because it is recent, but we don't revise the concepts. So that's why we do a lot of silly mistakes in formula. Grade 11th, we do very partiality with grade 11th, right? So grade 11th, I have picked all the PYQs, only PYQs, right? Okay, let's continue. Class duration, it is infinite. Mechanical properties of fluids, let's talk about that. So here it is, very interesting question. A U-tube with both ends open into the atmosphere is partially filled with water. Oil, which is immiscible with water, is poured into one side, right? Oil is poured on one side, okay? So immiscible means it will not mix with water. And it stands at a distance of 10 mm above the water level on the other side. So here we have water level is 10 mm above it, okay? All right. So you see, the oil on this side is higher. You see that water is still here only. This is water. This is water. The part which I am shading is water, right? And this is the oil. So you see that the level of oil is higher than the level of water by 10 mm. Okay. Meanwhile, the water rises by 65 mm from its original level. So this was the original level and the water rises by 65 mm. Okay. So initial water level was here and the water rises by this particular thing. So situation is like this. We have a U tube like this. Okay. Initially, the water was filled. Now you are pouring some oil into this side, right? So what is really happening? Oil is less dense. So it is pushing down the water on this side and the water on the other side is rising. So from the original level, the water rises by 65 mm, right? From the original level, the water rises by 65 mm, okay? All right. So meanwhile, the water rises by 65 mm from the original level. The density of the oil is, we have to talk about the density of the oil, right? My dear kids, look at these questions as balancing equations, right? We are balancing the weights on both sides. What is the balancing reference axis? You see that in these kind of problems, we will always talk about the reference axis, right? Meanwhile, you can solve it. In these kind of problems, we will always talk about the reference axis, right? So you see that, first of all, we have to choose an axis below which we don't have different liquids. For example, if I take an axis over here, so on this side, we have oil as well as water below it. So this cannot be my reference axis in calculation. On this side, we have only water, so that is fine. But here we have oil and water both. So this cannot be my reference axis. I will take the reference axis from here, because below that, I have only one type of liquid. So reference axis is sorted. Okay. Now you see that whatever load is there of this column acting on the reference axis must be balanced by the load of this side on the same reference axis. They are at the same level. So whatever load this is exerting over here, same load must be exerted by the other side over here, right? They must be exerting the same load. Yes or no? They must be exerting the same load. Yes or no? They must be exerting the same load, right? So how will you get the load? We can say mass, right? Or you can say mass into G. That is the load we are talking about, the force we are talking about, right? So just take the reference axis, take this part and take this part, right? And try to solve it. So here we have it, pressure at the point C, right? Pressure at the point C. Where is the point C? This point C, right? We have pressure due to this water column plus air, okay? So we have pressure at A plus rho GH, okay? Water column is exerting the pressure over there. And similarly, so just put the values over here and you can get the pressure at the point C. Similarly, at point B, this is the point B and this is the point C, right? Because here we have a balance. That means whatever pressure is exerted on this side, same pressure is exerted on the other side. So on the B side, we have this plus atmosphere, right? So we have pressure at point B is atmosphere plus rho GH for oil, okay? Now we have PA and PB, they must be same. So we just equated PB and PC. We just equated PB and PC. Pressure on this side and pressure on this side must be same, right? We equated that PB and PC. We have rho GH for oil, rho GH for water. Atmospheric pressure will cancel out from both sides. And we have rho of oil, density of oil, which is this many kilogram per meter cube. Very simple. The whole idea is we have to choose the reference axis. And after taking the reference axis, we have to equate the pressures on both sides. That's it. Okay. So let's have a look at who is giving the correct answer. Right. Let's have a look at who is giving the correct answer. Most of the kids are again correct. And I believe those kids who were not correct can actually get it. Sudha is there, very good, very regular. Kohli is consistent, very good. Mamta, nice. Dhanush, friends at creation, okay. Sanjana, Rajashri, Kishan, Shankar, Dhanush, Chaya, Sangeeta. Very good. All right. So let's keep on moving and talk about the next one. We have two non-mixing liquids of densities rho and n times rho are put into a container. The height of each liquid is h. A solid cylinder of length L and density D is put in this container. The cylinder floats with its axis vertical and length PL in the denser liquid. The density D is equal to. So what will be the value of density? The density D is equals to what? Okay. Again, the same stuff. Again, exact same type of problem is this, right? So we can definitely go ahead and talk about this problem, right? Okay. Look at this one. The cylindrical tube of a spray pump has radius r, one end of which has n fine holes. This is a good question. Right. The cylindrical tube of a spray pump has a radius r, one end of which has n fine holes, each of radius small r. If the speed of liquid in the tube is v, the speed of ejection of liquid through the hole is. My dear kids, we can say that one thing is for sure, that the tube is not holding anything, right? The tube is not holding anything, right? That means the flow of liquid must be continuous, right? The flow of liquid must be continuous. So we can say that A1 V1 is same as A2 V2. We have this tube, or we can say over here. Those kids who know can solve it. This is the tube and this is the other end with lot of holes, right? So see that if the liquid is entering from this side, so A1 into V1 must be same as, let's say, from one hole, the liquid coming out, let's say the area of one hole is A2 and V2. This is the flow rate of single hole. There are n holes, so n into A2 V2. They must be same. Whatever fluid is entering, same must be exiting. Nothing can be stored permanently in it, right? The fluid cannot be compressed, right? So A1 V1 must be same as n times A2 V2. A1 V1 must be same as n times A2 V2. So what is A1? Pi capital R square. What is A2? Pi small r square. For A2 is area of one of these small hole. Okay. So just equate it and you will have your solution. So you have this thing, exact same stuff. Pi r square into b is n times pi r square into b. Right. A1 V1 n times A2 V2. So from here we will be calculated VR square upon nr square. Okay, very good. So I forgot to start the poll, but Kohli is giving the correct answer, Nagraj is giving the correct answer, Nikhil is giving the correct answer, Mamta is giving the correct answer. Very good, right? So let's move on and talk about the next one. Here we have it. An ideal fluid is flowing in a non-uniform cross-sectional tube XY. So it's a non-uniform tube XY. If K1 and K2 are the kinetic energies per unit volume of fluid at X and Y respectively, K1 is the kinetic energy here, K2 is the kinetic energy here, then the correct option is, which of them is correct? Try to think about it. Very simple, common sense based question. You don't have to solve much in this question. It's a very simple common sense based question is this. Think about it. What will be the correct option? We have to definitely think about the ratio of K1 and K2. Ratio of kinetic energies K1 and K2. Kinetic energy depends on the velocity, how fast the particle might be moving. Think about it. Here the cross-sectional area is lesser. Here the cross-sectional area is higher, right? So where we will have, where are we going to have higher velocity? We can simply say that in this area, the volume is, the area is lesser, right? So when you have lesser area, the liquid comes out at a much higher velocity. So velocity is higher over here, V1, than V2. Yes or no? V1 is higher than V2. So clearly kinetic energy at 1 must be more than kinetic energy at 2. All right. So option C must be the correct option. Yes. So for this one, Nagraj is first, then we have Nikhil, we have Mamta, then we have Friends and Creation. Okay. Dhanush, Sangeeta, Tejas, Aya, and Dhanush. Okay. So the Venturi meter works on the principle of simple, direct application based thing. 30 seconds. Tell me. Venturi meter works on the principle of Venturi meter. These are all application of Bernoulli's theorem, right? Bernoulli's principle. They are all application of Bernoulli's principle. So clearly option D is correct. Venturi meter works on the principle of Bernoulli's, right? Okay. Now let's move on and talk about some better problems, right? Let's move on and talk about the thermal physics now. I'll give you 2-3 questions from this particular chapter as a homework, right? Let's talk about some question from thermal physics. Okay. Just a second. It's a very big PPT. Thermal physics. We'll start from thermal physics now. Right, 2-3 questions I'm giving you as a homework. So we are starting with thermal properties of matter, right? And here we have it. On a scale, on a new scale of temperature, and called the W scale, the freezing and okay, on a new scale of temperature and called the W scale, the freezing and boiling points of water are 39 degree and 239 degree. Okay, respectively. What will be the temperature on the new scale corresponding to the temperature of 39 degrees Celsius on the Celsius scale? Okay, right. On the Celsius scale, we start from 0, freezing point, and boil at 100, right? But on this new scale, we freeze at 39 W and we boil at 239 W, right? We want to know that 39 degrees centigrade on this scale corresponds to what value on this new scale? Think about it. Simple question. I'll give you 90 seconds to solve this one. If you have studied thermal physics in earlier foundation as well, these kind of questions are also there in the foundation part. We try to convert centigrade to Fahrenheit to Kelvin following the same logic. What kind of question paper I expect? Hard or easy? It will not be like 2024 level easy, or again, as I said, after 24, in 25, the paper was lot harder, right? Nobody was expecting the level of hardness that we had in the year 2025. But I guess that was an eye opener. That also reduced the what can we say, maximum marks, right? If I have to tell you, just a year before that, around, if you have around 690 or 700 marks, you had a rank more than 2000, right, out of 720. But last year at the mark 663, if I'm not wrong, you had a rank 33, right? So many kids think about, like, I want to get 700 marks so that I can get into AIMS Delhi. AIMS Delhi had around 40 seats, 48 seats, 48 seats. AIMS Delhi had 48 seats, and kids aim for 700. But previous year, if I'm correct, 684 was the highest marks obtained by the topper, right? So even the topmost candidate could not get a 700 mark. So if you are thinking that I want to get 700 marks, that will unnecessarily put pressure on you, because the exam paper is tough. That is why the topmost highest marks are 684. And you see, at 663 marks, you have a rank 33. Again, less than 48. There are 48 seats in AIMS Delhi. This kid is also sitting around 40 marks less than 700, but still he is also sitting in the same AIMS, right? So my dear kids, do not keep a particular score in your brain. Just try to maximize your whatever marks you have, right? Yeah. Okay. So yeah, let's talk about this part now. So clearly, it starts from 39. So you have to add 39. And here you see the 100. And here you have 239. So clearly, double it and add 39. That is a clear presumption that we have. So double 39 will be double it first, 39 into 2, plus add the reference value 39 to it. And that will give you the answer, right? So 39 into 2 is 78, plus add 39 because it starts from 39. So just add it up. You will have 117 degree. And that is the option D, right? So let's see how many kids are giving the correct answer. Okay, most of the kids are giving the correct answer. And friends, Adda Creations, okay, she's fastest. Then we have Nikhil, Mamta, Yashasvi, Kohli, Manjulata, Dhanush, Sangeeta, Anu. Okay, many kids gave the correct answer this time. But anyways, let's move on and talk about the next one. A metallic bar of Young's modulus 0.5 10 to the power 11 and coefficient of linear thermal expansion 10 to the power -5, length 1 meter, area of cross section 10 to the power -3, is heated from 0 to 100 without expansion or bending. The compressive force developed in it is. What will be the compressive force developed in this one? It's a very good question, I would say. Very good question. My dear kids, you can try to solve it. But those who cannot solve it, I will be explaining you the concept. Read the question. This is the metallic bar and it has certain value. Young's modulus is given, coefficient of linear thermal expansion is given, length is given, area of cross section is given. These are the properties of that bar that are given to you. Now you see what we are doing. The question is saying that this rod with these properties is heated from 0 to 100. We are heating this rod from 0 to 100. Okay, so this rod with all the Young's modulus, length and area, this is heated from 0 to 100. Okay. But without expansion or bending, we are heating. It should expand, but we don't allow it to expand. That means we have blocked it at the ends. We have blocked it at the ends. We don't allow it to expand, right? We are heating from 0 to 100 without expansion or bending. The compressive force developed in it is going to be. So my dear kids, when you heat it, we don't allow it to expand, but it wants to expand. Heating does that to metals. It wants to expand. And when it is expanding, it is hitting against the walls. And when it is hitting against the wall, walls are pushing it back. Yes or no? When it is trying to pressurize the wall, walls are trying to pressurize it back. So right now it is under compressive load due to the forces applied by the wall. Yes or no? All right. So now you can say that what will be that compressive force developed in this situation? So we can say compressive force we can easily calculate. During the expansion, whatever force is exerted on the wall, same compressive force will be there divided by the area. That is the compressive stress. But here we have to calculate the compressive force only, right? Here we have to calculate the compressive force only. Okay. So no worries about that. Young's modulus is force per unit area. So this is stress upon strain. So in case of thermal stresses, Young's modulus will be thermal stress upon thermal strain, right? So thermal stress is force per unit area, right? And thermal strain is going to be alpha delta T, right? Alpha delta T. Okay. Thermal stress F upon A, thermal strain alpha delta T. I believe the idea is very, very clear, right? So what will be the value of forces that will expand it? Ya alpha delta T. This is the value of deforming force. Thermal strain, you see, thermal strain is alpha delta T, right? If a material with a thermal coefficient alpha is heated for the temperature delta T, the thermal strain in that one is alpha delta T. Total deformation, if you have to talk about, delta L upon L is thermal strain, alpha delta T. Total deformation is going to be alpha delta T into L. If they are asking about the total deformation due to heating, it is going to be alpha delta T into original length, right? So my dear kids, over here Y is given to you, this cross-sectional area is given to you, this alpha is given to you 10 to the power minus 5, delta T is given 0 to 100, 100, everything is given. Just put the values and multiply, right? Everything is given to you, just put the values and multiply and tell me what is the value that is coming up. Tell me what is the value that is coming up. Put the values and multiply, that's it. Right? Concept I have explained, 15 to the power 3. 15 to the power 3, option B is coming out as correct. Okay. Many kids have done it wrong now. Calculation error you have done, because 5 into the power 3 and 15 into 10 to the power 3, there's the calculation mistake might be there, right? So now the next question is, a copper rod of 88 centimeter and an aluminum rod of unknown length have their increase in length independent of increase in temperature. The length of aluminum rod is, what will be the length of aluminum rod? Right, my dear kids, here we have to talk about the original length, and in the previous question I have just explained you how to get the original length when you know the deformation, right? All right. So clearly you know that the total thermal strain delta L upon L is alpha delta T. Okay. Thermal strain is alpha delta T. So total deformation in the entire length alpha delta T into L. We have a copper rod, we have an aluminum rod. So for the copper rod and aluminum rod, we are getting what? You see, a copper rod of that much length and aluminum rod of that unknown length have their increase in length independent of increase in temperature. That means the increase of length is same. Delta L is same for both of them. So we will try to put this expression same for copper and aluminum, and from that we will get the length of aluminum rod. Okay, meanwhile you can try to solve it. Now you put the solution in answer in the chat box. So you see that for copper rod and aluminum rod, this is going to be same. Alpha delta T into L for copper is same as alpha delta T into L for aluminum, right? So put alpha for aluminum and everything for aluminum and just solve it. You can get the unknown length of aluminum rod, L. Every other thing is given. Every other thing is given to you. Class duration is infinite, as I said. I guess I'll take 1 more hour in grade 11th part, and then grade 12th part I will revise in you 2 hours. That's all, right? In the grade 12th, I'll be giving you mostly formula revision and the concept revision, right? Numerical problem mostly I'll be giving you as a homework. Okay. But if you have any good question, if I see any good question, I will solve that question as well, which I feel is good for you to know. Okay. So I hope you can solve it. And now the option is A, right? So let's see that. So here again, Kohli is first. Okay. Tried so long. And now he is first. Mamta is there. Chaya is there. Nagarjuna, Nagarjashri. Okay, very nice. Sanjana. Cool. So some kids have done the calculation mistake. They are getting 6.8. So you see that sometimes we get these kind of options, right? We do the calculation mistake. Now, let's move on and talk about some better problems. So let's keep 2-3 questions for you as a homework. This question is good. Now this is asked in the NEET 2025. It's a very good question, right? Yeah, so you can just go ahead and try to solve it. So what is really happening in this question, my dear kids? 3 identical heat conducting rods are connected in series. 3 identical heat conducting rods. They have same length, same cross sectional area. 3 identical heat conducting rods are connected in series, right? As shown in the figure. The rods on the sides have thermal conductivity 2K. The rods on the sides have thermal conductivity 2K, while that in the middle has thermal conductivity K. That in the middle has thermal conductivity K. The left end of the combination is maintained at the temperature 3T. This end is maintained at temperature 3T. Okay. And the right end is maintained at the temperature T. This end is maintained at the temperature T. Okay. The rods are thermally insulated from outside. The rods are thermally insulated from outside. Okay. In the steady state, this line, in the steady state, temperature at the left junction is T1, right? Left junction, junction is this. Junction is where 2 rods meet. This is left junction, this is the right junction. So temperature at the left junction is T1 and at the right junction it is T2, right? What will be the ratio of T1 upon T2? My dear kids, we are talking about steady state, right? At steady state, the rate of heat transfer through all 3 of them must be same, right? Yes or no? At steady state, the rate of heat transfer must be same. Yes or no? Right. And now, meanwhile, I should give you the time to solve and poll. Right. My dear kids, you know that through conduction, the rate of heat transfer through conduction is Ka into delta T. Yes or no? Ka into delta T upon L. My dear kids, this expression is going to be same for any of these 2 rods, right? So my dear kids, we can just equate it and we can get the desired variable. First, we can take these 2, right? We will use this expression for this one. We will use this expression for this one, right? You see that A and L is same for all of them. Delta T for the first one and K for the first one is different. For the first one, K is 2K and delta T is 3T minus T1 minus 3T, right? For the second one, K is K only and delta T is T2 minus T1, right? So you have one expression in T1 and T2 when you are analyzing these 2. Similarly, you have another expression in T1 and T2 when you analyze these 2 and you solve it, you can get the expression of values of T1 and T2, right? Same question, right? Same question. You see that? So for this particular part, you have 2K into A, 3T minus T1 upon L, right? Length is L. And then for the other part, we have K into A, the conductivity is K, T1 minus T2 upon length is again L, right? So this will give you the equation between T1 and T2, which is this. Now at the junction D, this one, T2, think about these two again. So Ka delta T upon L, and again 2K into delta T, T2 minus T upon L, right? And when you solve this particular part, this and this, you will get another expression in T1 and T2. Just you have two equation and two variables, solve them and get the values of T1 and T2. All right. All right. So are you guys getting the whole thing in English, right? I don't know Kannada, that's why. Okay. Right. So the mechanical quantity which has, I forgot to give you the solution of this thing, 5 by 3. So 5 by 3 is option A. Let's see how many of you are actually correct. Oh, only few kids were actually correct. And that is Hussein Walikar, out of nowhere. Awesome. 5 by 3 is the answer. The mechanical quantity which has dimension of reciprocal of m inverse is which of them? The mechanical property which has the dimensions of reciprocal of mass is which of them? Try to answer it. So try to solve it by elimination. Huh? So basically you need to know the dimensional formula of each one of them, and in any of the dimensional formula, if you get m minus 1, L something, T something, that doesn't matter. But if you get m minus 1, that means that is the answer. We are looking for that dimensional formula where we have L m minus 1, right? You see that sometimes they ask the questions from the dimension analysis that is like this, right? Simple, but yeah. In the gravitational constant, there is per kilogram component is there, right? So clearly we know that in the gravitational constant it will be there, right? So option D is the option, correct option. Yeah, so most of the kids gave the correct answer. And Risha Gowda again came up first. And Sudha, then we have Vagesh. These new kids again are topping the chart now, out of nowhere. Okay. The energy that will be ideally radiated by a 100 kilowatt transmitter in 1 hour is going to be. So 100 kilowatt, that means how many joules in a second? 100 kilowatt. Watt means joule per second. That means 100 into 10 to the power 3 joule per second. Okay. Think about it. I gave you a very small hint, right? So in 1 hour, how much energy will be transmitted? Everybody is saying like, okay. Nice. Option is A, because in 1 hour, this is for a second, na? So in 1 hour, you have to multiply how many seconds are there in 1 hour? 3600. Multiply with that. So you have 3600 power 7. Yeah. Option A is correct. So let's see that how many of you are actually correct. 100%. 100%. Very good. So Risha is the first kid who is actually correct. Then Sudha, we have friends and creation, Adda creation. Then we have Chaya, Mamta, Rajashri, Radhakrishna, okay. Yashwina, Yashaswina, Kohli. Nice. Let's move on and talk about the next one. So for this one, we have to talk about the net conductivity, right? So the heat is moving in which direction? Two rods A and B are different materials are welded together as shown in the figure. Their thermal conductivities are K1, K2. The thermal conductivity of the composite rod will be. So this end is at T1, this end is at T2. What will be the thermal conductivity of this combination? What will be the thermal conductivity of this combination? Think about it. What kind of combination is this? It's a parallel combination. Yes or no? Parallel combination. Because the heat will pass through both of them simultaneously. It's a parallel combination, right? So what will be the net thermal conductivity? K1A1 plus K2A2 upon K1 plus K2. Yes or no? Net thermal conductivity will be K1A1 plus K2A2 upon K1 plus K2. So very simple question. They are already giving you, they are identical. They are different materials, but the area is not given. That means the area must be same. So K1A1 plus K2A2 upon A1 plus A2. This is the net conductivity in the parallel combination. Area is same, so that will be cancelled out. So it will become K1 plus K2 by 2, which is the option number D. Yeah, many gets are correct. Rajashri is the first one. Now let's move on and talk about the next one. A piece of iron is heated in a flame. It first becomes dull red, then becomes reddish yellow, finally turns white hot. The correct explanation for this observation is possible by which of the following laws? 30 seconds. So the wavelength is changing, right? You heat it up and the wavelength shifts. We know that lambda into T is constant. And this lambda is wavelength corresponding to the high wavelength wavelength corresponding to the maximum emission, right? Okay. So we can say that temperature and this lambda m are inversely related, right? So this is why we can say that most of the emission is from the shorter wavelength when you increase the temperature, right? Wavelength corresponding to the maximum intensity. Yes or no? So it is called Wien's displacement law, as I said. Yeah. Now, same type of questions. Look at this one. You have already solved this type of question. And again, this is repeated. All right. Let's solve some good questions. All right. So look at this one. We have two gases, A and B. They are filled at the same pressure in the separate cylinders with movable piston of radius RA and RB. On supplying an equal amount of heat to both the systems reversibly under constant pressure, we are supplying the heat at constant pressure. We are supplying the heat at constant pressure. Okay, we are entering into thermodynamics now. The piston of gas A and gas B are displaced by 16 centimeter and 9 centimeter respectively. If the change in their internal energy is same, then the ratio of RA is to RB. What will the ratio of RA is to RB? Right. Think about it. Very good question. You have 2 minutes to think about it and solve it. Very good question, I would say. Based on simple applications of laws of thermodynamics. Very good. Keep on solving. All right, so let's see that how to solve this particular question, right? Some kids are able to solve it. I believe some kids won't be able to solve it. This is asked in the NEET 2025. In the NEET 25, they have asked so many interesting and good questions, right? So this question is also one of them. Okay. You need to know few things so that you can attempt this question. Many kids might be feeling a difficulty in this question as well. You see that when you heat up a certain system at a constant pressure. So pressure is constant. That means the pressure is constant. Let's say you add up some weight. So constant pressure is there, but the system is free to expand. We are not fixing it at the same volume, right? Okay. So what will happen after a certain time? If you keep on adding up the heat, this will expand and reach over here, right? So this is the displacement it will cover, right? This is the displacement it will cover. Okay. Let's call it X. Okay. Let's say the cross sectional area is A. All right. How much work is done in the process? Work done in the process is P delta V, pressure into change in volume. Work done at the constant pressure. Work done in the constant pressure is P delta V, pressure into constant change in volume. Over here, what is the change in volume? Right. This is the change in volume, right? This volume is changing, right? This is expanding, right? So what is that? We can say area into this distance. So we have X into A. All right, X into A. I believe the idea is very, very clear, right? So once you start heating up at a constant volume and piston moves up by a distance X, that much work is done. P into displacement of the piston into cross sectional area of the piston, right? If you are heating system at a constant pressure, how much work will be done? We can say pressure into displacement of the piston into area of the piston, right? Now, once we know that particular part, we can definitely go ahead and talk about the solution of this thing. We have two gases, right? We are heating the first one and the piston is moving. This is the piston. Piston is moving from here to here for a certain distance. What is the displacement of the piston? In the first case, 16. Second case is 9. In the first case, piston is moving by 16 centimeter. In the second case, piston is moving by 9 centimeter, right? So clearly the work done will be different in both the cases. The work done over here in the gas A will be P A and delta V, right? So delta V is simply displacement of the piston into area of the piston, right? So displacement of the piston is 16 into area of the piston is area of A, okay? And work done in the second scenario is going to be PB, right, into 9 into area of B. My dear kids, in these one, A and B, they are filled at the same pressure. So again, you can clearly write PA and PB are same. So you can remove A and B from here. P and PB are same. Okay. So this is the work done in this situation. And they are also giving us one more scenario that they have movable piston with radii RA and RB. On supplying equal amount of heat to both the systems. So first of all, we are supplying same amount of heat to both the systems. And the change in internal energy is also same. You see, the change in internal energy is also same. So now if you apply the first law of thermodynamics to both the system, you can say that supplied heat, which is same for both of them, let's say delta Q, right? It is going to be delta U plus delta W, right? Delta U plus delta W. Yes or no? I hope the idea is very, very clear. My dear kids, this is same and this is same, so work done has to be same as well, right? Same heat is supplied and same change of internal energy is happening, so work done must be same for both of them. So we will try to equate both of them, and then we will get the ratio of areas, right? So let's have a look at that. You see the change of internal energy is same, okay? So delta Q for the first one, for the gas A, is delta UA plus delta UB, right? So just delta work done in the first chamber is P into displacement into area. P into displacement into area. We have written it. Same thing we have written for the second gas, right? Now it is given both of these things are same and internal energies are also same. So work done will also come out to be the same. So this is how it is coming out. In place of area, we are writing pi r square, pi a square. So that's what we have written. Pi and pi will also cancel out, and the ratio of radii will come out, which is 9:16 or 3:4, right? The ratio of radii will also come out 9:16, right? I believe the idea is very, very clear. So look at this question. By the way, let's have a look at how many kids have solved it correctly. So 3:4 is the correct answer, which is option D. Okay. Option D is correct. And wow, Risha has solved it correctly. Mamta is there. Dhanush is there. Then friends, Adda Creation. Then we have Chaya, Yashaswani, yeah, Sangeeta, Sada, Vagesh. Okay, nice. Now let's move on and talk about the next one. Look at this question. We have a cycle, right? It's not a cycle, right? We are, it is a cycle. A, B, C, D, A. It's a cycle. We have a thermodynamic system which is undergoing through a cycle A, B, C, D, A. The work done by the gas along the path BC. The work done by the gas along the path BC. My dear kids, from path B, from point B to C, the volume is not changing. Look at that and think about what will the value of work done. 30 seconds you have. Common sense based question, and this question was asked in the NEET 2024. It is an easy question, right? Which is why the cutoff for NEET 24 is very high, was very high, right? Look at that and try to solve it. Awesome, right? So my dear kids, here as you know, let's see that how many kids have actually answered it correctly, then I will explain it. It was a very common sense based question, but many kids actually got it wrong. But understand that since we are talking about B to C, the work done in the process where the volume is not changing, you see the volume is not changing. Work done is P into delta V, change in volume is 0. So work done in this process will be 0, right? Work done during B to C will be 0, right? P delta V is 0, na? Let's look at the next question. A sample of 0.1 gram of water at 100 and normal pressure requires 54 calorie of heat energy to convert to steam at 100 degrees centigrade. If the volume of the steam produced is 167.1 cc, the change of internal energy of the sample is. So what will be the change of internal energy of the sample? What will be the change of internal energy of the sample? Acha Kohli. All right. So again, a very good question. Try to think about it and solve it. Okay. Meanwhile, if you cannot solve it, I will give you the explanation of this thing as well. You see, a sample of 0.1 gram of water at 100 degrees centigrade and normal pressure requires 54 calorie of heat energy to convert to steam at 100. So think about it. We have water at 100. It is converting to steam at 100. Temperature is not changing. So all of the heating is happening in terms of latent heating, M into L, right? If the volume of the system produced is 167.1 cc, the change in the internal energy of the system will be. So initially, you can assume that the initial volume of 0.1 gram of water at 100, initially the volume of this much water is negligible, right? And finally, after converting into steam, the final volume becomes this much, V2, right? The change of internal energy you have to calculate. Apply the first law of thermodynamics and try to calculate it. So my dear kids, you can say that delta Q, the heat you have given, is delta U plus delta W. Yes or no? Delta Q is equal to delta U plus delta W. Yes or no? Right. My dear kids, we have to talk about the change of internal energy. So that will be delta Q minus delta W. So what is delta Q? You see that 54 calorie of energy is given to it, right? Now, you know that it is written in calorie. We have to put it in joule. So all the heat given is 4.18 into calorie. Just convert it into joule. That many joule. Delta Q is there. And delta W is the amount of work that you have got, which is P delta V, pressure into change in volume. The whole thing is happening at this pressure. Pressure is 1.01 10 to the power 5 and volume is change in volume. Final volume is this, initial volume is 0, right? So we can put it in the terms of final volume. It is centimeter cube. Cc is centimeter cube. Convert it into meter cube by multiplying with 10 to the power negative 6. So the final volume is 167.1 into 10 to the power negative 6 minus initial volume is 0. So here you will have the change of internal energy, right? Just subtract it and you will have the answer. Just subtract it and you will have the answer. Focus, focus everybody. Sometimes I don't get what these Gen Z kids are talking. You guys make me feel old sometimes. All right. So continue. Right. Just solve it and tell me what is the final value that you are getting. So the final value upon solving is 208 point something, which is which option? Option B. So let's see that how many of you are able to solve it correctly. Option B is correct. And the first answer was given by Hussain Walikar. Then we have Risha, we have Sudha, we have Kirti. And we have Pramod and Chaya. All right. Nice. Let's continue to keep on moving in the forward direction. We have a system that is taken from the state A. Achha, this is not a cycle, you see. It is not moving like this. So we are moving from state A to state C by 2 paths. Okay. So we are moving from state A to state C by 2 paths. One is this and other is this. All right. The internal energy at A is 10 joules along the path ADC. The amount of heat absorbed dQ1 is 50 joule and the work done obtained is 20 joule. Okay. Along the path ADC, this path, the path above, right? The internal energy over here is 10 joules, right? And following this path requires heat 50 joules, 50 joule ADC, and the work obtained is 20 joule dW1, 20 joules. Whereas along the path ABC, the heat absorbed dQ2 is 36. Along this path, the heat absorbed is 36. And the amount of work along the path ABC that we have to calculate, right? This is 36 and amount of work we have to calculate, dW. Along this path, dW2 we have to calculate, right? Okay. All right. So now, from this particular question, you can solve it. You can take 2 minutes to solve it. And those kids who cannot solve it, let me give you the solution, right? Just keep on solving this question. Meanwhile, let me explain you this thing, right? If there is any question, any part that you want to write down in a notebook, you can quickly write it down so that I can solve it now. Okay. It is 50, 20, 36 question mark 10. Have you written the data? Let me explain you the concept first of all. Let me explain you the concept. My dear kids, there are two things called path function and a point function. So when we talk about the internal energy, density, mass, temperature, pressure, volume, these are all point function, right? They do not depend on the path, right? For example, if you are moving from this point to this point A to point B, and you are getting certain change in temperature, let's say 10 degrees, right? You have some temperature here, some temperature there, and the difference of temperature you have between A and B is 10 degrees. Doesn't matter which path you follow, the difference between A and B will always be 10 degrees, right? Because temperature depends on points, point function, not on path, right? But the work done in all these processes to move from A to B will be different. The heat involved will be different because heat and work are path dependent, path functions. All right. Okay. Same goes for internal energy. The internal energy change for this path, for this path, for this path, and for all other path is same, because internal energy is also a point function. It is not dependent on the process, right? Okay. So this is the main idea that I wanted to explain you. Now, once we know that the internal energy does not depend on the path, we can talk about this part, right? Here we have it. We are moving it from this point. Let's first draw this one. We are moving it from A to D and C, DC. Look at this process, right? We are moving it from A to C. The amount of work involved and heat involved is 50 and 20. So dQ1 is 50 and dW is 20. My dear kids, when we apply the first law of thermodynamics, we can say that dQ equals to dW plus du, right? Change in internal energy, right? So dQ is given 50, this is 20 plus du. So change in internal energy is how much? 30 joule, right? Change of internal energy in this process is going to be 30 joule. Final minus initial is how much? 30 joule. So final is internal energy at C minus internal energy at A, that is 30 joule. Internal energy at A is already given, which is 10 joules, right? 10 joules. So internal energy at C is going to be 40 joule. Internal energy at C is going to be 40 joule. I believe the idea is very, very clear. So internal energy at A is 10 joules and internal energy at C is 40 joule. And doesn't matter which process you follow, for all the paths, the internal energy change will be same, right? Okay. Now we talk about the second process. Okay. Now we talk about the second process. Tell me, till now, is there any problem? Till now, if you have any question, you can definitely ask me. Clear hai? All right. So now, even if you follow this process, for this process as well, the change of internal energy again be 30 and the amount of heat involved is 36. 36 na? 36 joules, right? So dW can be calculated for the second part. So dQ equals to dW plus du, right? So dW we want to calculate. It is dQ minus this. dQ is 36 minus 30. It is 6 joule. So amount of heat involved in this process A, B, C, right, is 6 joule. Okay. I hope the idea is very, very clear. Okay. Any problem in this part? Right. The amount of heat involved is 6 joule. So option D is the correct option. Option D is the correct option. And let's see. Yeah, most of the kids are correct. And Rajashri is the first one. Then we have Risha, Kishan, and Chaya. All right. Rajashri is the first one. I hope the idea is very, very clear. Okay. Let's move on and talk about the next one. The internal energy chain is a system that has absorbed 2 kilocalorie of heat and done 500 joules of work is. Try to solve it. Try to solve it in the chat box. Very simple question. The internal energy chain in the system that has absorbed 2 kilocalorie of heat and done 500 joule of work is. Simply apply the first law of thermodynamics and solve it. Okay. So dq equals to du plus dw, right? So the internal energy in the system that has absorbed 2 kilocalorie of heat. So heat absorbed is 2 kilocalorie. 2 kilocalorie. So 2 in 10 to the power 3 calorie. Convert that into joules. So 2 into 10 to the power 3 calorie. Convert that into joule, 4.18 or 4.2. Right. The change of internal energy you have to calculate du, and dw is 500 joules. From here you can get the value of du, right? From here you can get the value of du. It is 8400 minus 500, 7900, right? Yes, option C is the correct option. Few kids are actually correct only. Risha, Sudha, and Kala. Kala, Kunda, Patil. Okay. Maybe I'm not pronouncing the name correctly, but anyways. So this is this. Okay. Look at this question, graph-based question. It is asked in the NEET 2015. 1 mole of an ideal diatomic gas undergoes a transition from A to B. Along the path AB as shown in the figure, the change in the internal energy of the gas during the transition is. What will be the change in the internal energy of the gas during this transition? Change in the internal energy of the gas during the transition. So think about it and try to solve it. Okay, answer it in the chat box. One mole of an ideal diatomic gas undergoes a transition from A to B as shown in the figure. The change in the internal energy of the gas during the transition is. Okay, very nice. Very simple question. Just the equations of motion you have to apply. All right. So as you can see over here, I can directly explain you in this part. Change of internal energy in this situation is NCV/dt, right? So this is a very common formula. Change of internal energy is NCV/dt. When you solve multiple problems, this formula becomes a second nature for you. But anyways, NCV/dt is the change of internal energy. And now what are we doing? We are talking about the diatomic gas. So CV for a diatomic gas is 5R/2. Okay. So NCV/dt, we are moving from A to B. So dt is dB minus TA, right? So NCVDT, this is the change of internal energy. Just put all the values and you have the change of internal energy 20 kilojoule. No worries about that. Right. 20 kilojoule negative. Option D should be correct. Okay. And this time Risha, Sudha, Chaya and Abhishek, they are actually correct. Very nice. So try to get an idea about these things. If you are taking more than a minute to solve questions of physics, right, that should give you a time management idea for the final exam, right? If you have not solved many mock tests, my dear kids, and you have an exam day after tomorrow, so you must see that I take around 90 seconds to solve a question, right? So there are 45 questions, and let's say that I am solving 35 physics questions, right? This is my aim. So how much time I should keep for myself, right? So depending upon that, right? Depending upon that, I should compress the other subjects like biology and chemistry. I must not over analyze biology questions and chemistry questions. Otherwise, I'll be very short on time when we have physics, right? Yes or no? All right. If Cp and Cv denote the specific heats per unit mass of an ideal gas of molecular weight m, then what will be the ratio? What will be the relation between Cp and Cv? Right, very popular relation. Okay. So if the molecular weight is given, then Cp minus Cv is going to be what? Right, R upon m. Huh? It's a direct formula. Option C. The equilibrium state of thermodynamic system is described by which of the following equation? The equilibrium state is described by which of the following explanation part? Which of them will describe the equilibrium state? Pressure, total heat, temperature, volume, work done. Pressure, total heat, volume, work done. Okay. How will you define the state? Right, think about it. If I am trying to, this is a thermodynamic process. Let's say I want to describe this point. Will I use the word work done at this point? No. Can I use the word heat involved at this point? No. Because these are path functions. I cannot use those expressions for describing a state. Okay. I can use pressure to describe a state. Okay. Can I use heat? We can say no, it's a path function, right? Can I use temperature? Yes. Can I use volume? Yes. Can I use work done? Work done at this point? No. Work done during a process? Yes. So for a state, we need these three things. Okay. These three things can help us describe a certain situation. So A, C, and D. So which is the option D, right? So let's see that. Only few kids are correct. Why? Why? You see, some kids are giving A and B and C as an option. Work done and total heat, they do not describe the state, they describe a process, right? Heat is given in a certain process. Particle will move from A to B. Work is done in a certain thermodynamic process, right? State is a different thing. A cylinder contains hydrogen gas at pressure of 249 kilopascal and temperature 27 degrees centigrade. Its density is, what will be the density? A cylinder contains hydrogen gas at pressure of 249 kilopascal, temperature 27 degrees centigrade. Its density is, what will be the density? Try to solve it. My dear kids, we already know that there is an equation, a very popular equation of this ideal gas, PV equals to nRT. From that, we will try to derive the equation of density, right? Generally, whenever we have any weird requirement, we try to use the same equation, PV equals to nRT, because we have volume. Once we know volume, we can calculate density as well, right? So, no? Once we know volume, we can talk about density and all those things as well, right? So volume, in place of volume, we can use volume upon mass upon density. Density is what? Density is mass per unit volume, right? So instead of volume, we can put mass upon density, right? So instead of volume, we can put mass upon density, and we can further solve it, right? So over here, you can say that PV equals to nRT, and we can replace that small n is number of moles, m upon capital M, right? So we can now use it that in place of V, we will have this thing, right? Mass upon density. So from here, the density will come out to be this much, right? And now you can replace all the other terms and you will get this much value. So nothing very serious about this part. So now let us have a look at this question. It is asked in the NEET 2022. It is again a graph-based question. Have a look at this question. An ideal gas undergoes 4 different processes from the same initial state, A, B, C, D. Okay, so the initial state is same, final state is different. Those processes are adiabatic, isothermal, isobaric, and isochoric. The curve which represents the adiabatic processes. So quickly tell me. The curve out of these 4 curves, which one will represent the adiabatic process? Out of these 4 curves, which one will represent the adiabatic process? Hello? Yeah. Nice. Very nice. So out of these, this cannot be adiabatic. It's a constant pressure isobaric process. This cannot be adiabatic. It's an isochoric process. Now out of 2 and 3, the one which is flatter is isothermal, and the one that has higher slope is adiabatic. So which one of 2 and 3 has higher slope? Which one of 2 and 3 has higher slope? We can say that clearly the second one has higher slope. So option B will become the correct option, right? Option B will become the correct option, right? I hope the idea is very, very clear. Okay. Option B is the correct option. Let's move on and talk about the next one, right? In which of the following processes heat is neither absorbed nor released by the system? Everybody must know it. Oh, in the previous one, we have to choose the correct option was option B. Okay. All right. Simple questions are being wrong. Why? So two cylinders A and B of equal capacity. Okay, not this one. In which of the following processes heat is neither absorbed nor released by the system? 30 seconds. 30 seconds and everybody should give the answer. In which of them the heat is neither released Very good. So the poll time is up. Poll time is up. By definition, we can say that, I thought 100% kids will give me the correct answer, but no worries. No worries. Dhanush is still there. Nice. Right. So it is the adiabatic process for which heat is neither absorbed nor it is released by the system. Right. The volume of a monatomic gas varies with the temperature as shown in the graph. The ratio of work done by the gas to the heat absorbed by it when it undergoes a change from state A to state B. Right. So think about it. I can give you this question as a homework. Simple question is there. Right. And now let's move on to the other chapter. Right. We have a decent idea about our thermodynamic part. Now we can talk about the next chapter. 3-4 questions I am adding up to your homework problems. So oscillation and waves are there. Right. So now we will be solving some questions from oscillation and waves and our grade 11th part will be over. Right. After that we will be starting with grade 12th part. Right. So without any further delay, let's start right away oscillation and waves. Oscillation and waves. Let's start right away oscillation and waves, right? Look at this question and try to solve it. Oscillation and waves. Look at this question and try to solve it. X equals to 5 sine pi t plus pi by 3m represents the motion of a particle executing simple harmonic motion. The amplitude and time period of the motion respectively are. What will be the amplitude? What will be the time period? Quickly tell me. What will be the amplitude and what will be the time period? Just compare it with the standard equation. Compare it with the standard equation and tell me what will be the amplitude and what will be the time period of this particular situation. So you see that y is equals to a sine omega t plus phi, right? So in place of omega we have pi, right? And in place of phi we have pi by 3, right? So from here we can calculate the amplitude and time period of the motion very easily. Why? Because the time period is 2 pi by omega. Omega is nothing but pi, so 2 pi by pi is 2 seconds. And amplitude, in place of amplitude we have 5 directly, so amplitude is 5. 5 and 2 is the answer. So option, it is given in the meter, na? So 5 meter and 2 second, option B is correct. Option B is correct, right? Very good. Very good. Let's have a look at that. How many kids actually gave the correct answer? 100% kids gave the correct answer. And Dhanush is first. And then we have Risha, Rajashri, Vidha, Sagar, Mamta, and Sudha. Nice. Nice. Look at this question. A simple pendulum oscillating in the air has period of √3 seconds. If it is completely immersed in non-viscous liquid having density 1/4 of the material of the bob, the new period will be, what will be the new time period in this particular situation, right? So we are immersing it, and now in the immersed situation it is oscillating. What will be the effective value? So my dear kids, it's a good question, right? It is asked in the previous year NEET 2023. Look at that. A simple pendulum oscillating in air has a time period of root 3 seconds. A simple pendulum oscillating in air has a time period root 3 seconds. Right now, when the oscillation is happening in the air, the time period is 2 pi under root L upon G. My dear kids, this acceleration due to gravity will be affected when it is not in the air, instead it is immersed in the liquid. When the same pendulum is immersed in a liquid, now the acceleration is not equals to acceleration due to gravity, because the liquid will affect it, right? When it is immersed in a non-viscous liquid having density 1/4 of the material, so density of the material is rho, density of liquid is rho by 4, okay? The new time period will be, so effectively what will be the new time period? We will talk about that, right? Effectively, first of all, length will not change by immersing into the liquid. 2 pi will not change by immersing into the liquid. So what will actually change? We can say the value of G will be changing by immersing into the liquid. Yes or no? So what will be the effective value of G? Right. The effective value of G when you immerse it in the liquid is G1 minus G upon G naught. Yes or no? Right? Oh, not G, rho upon rho naught, sorry. Rho upon rho naught. Okay. So you see that if we are immersing it in a liquid of density rho, then this is the situation we are going to get. Okay. Right. If we are immersing a substance or body of density rho naught, this rho naught is this, right, into a liquid of density rho, you can also call it rho L, right? So the effective value of G will remain this much only. Okay. So G rho L is 1 upon 4 times rho naught. 1 upon 4 rho naught upon rho naught cancel out. It is 1 upon 4 only. So 1 minus 1 upon 4 is 3 by 4. So effective value of G is 3/4 of previous value of G. So once you know the effective value of G is 3/4 of previous value, you can put the value 3/4 over here and get the new time period. No problem with that, right? Yes or no? So let's have a look at that. So for a simple pendulum, 2 pi under root L upon G, it is in the air. When you immerse it, the effective value will be G1 minus density of liquid upon density of the medium. So the ratio comes out to be 1:4, right? So 3 by 4 G, okay? So T dash upon T, time period in the liquid and time period in the air, the ratio comes out to be T dash 2 upon root 3. 2 upon root 3. So previous time period was root 3 second. New time period is going to be 2 seconds. Okay. All right. All right. So let's keep on moving and talk about the next one. The distance covered by the particle undergoing SHM in one time period is. So in one time period, how much distance is covered by the particle? Displacement covered will be 0. Particle will come back to the same place. How much displacement will be covered? Very easy question. Right. Very easy question. What will be the displacement covered by the particle in one time period? It was asked in the NEET 2019. Very nice. Okay, so by common sense, you can say that this is the pendulum. It will first of all go to one side, amplitude A, distance is A, come back again A plus A, distance will be adding up, right? Then it will go here again A, and then it will come back again A, right? So 4 times it is covering the same displacement. So the net distance is going to be 4A. Yes or no? The net displacement is going to be 4a. So the class is pretty much divided between A and D. Specifically, I said it is not the displacement we are talking. We are talking about distance, right? Distance we are talking about, right? So in the journey, the displacement would be 0, but the distance is not, right? Distance is total path length covered by the body. Total path length covered by the body. Got it? Once again, I have to explain. Okay. You see that displacement is, let's say you start from here and you end the journey here, right? This is the distance and this is the displacement as well. But if you come back to the same spot, let's say that this is 10 meters one way. So what is the distance and what is displacement? You start from A to B and come back to the same spot. So in the complete journey, the displacement will be 0, right? Because starting point and the final point are at the same place. But the distance is total path length covered by the body. So 10 meters one way, 10 meters the other way. So total path length is 20, right? So here, when the particle is performing SHM, total path length is going to be A, 4 times A. Is that clear? All right, all right. Let's move on and talk about the next one. The radius of a circle, the period of revolution, initial position, and the sense of revolution are indicated in the figure. Okay. The radius of the circle is 3. Time period of revolution is 4 seconds. Right. Okay. And the sense of revolution is this, right? Clockwise. Y projection of the radius vector of rotating particle P is. The Y projection is going to be which of the following quantity? So answer it, right? I believe when you are studying, alternating current and you're talking about the rotating vectors, there you have discussed this particular part in the phasor diagram. You have, you know about the phasor diagrams, right? If you don't know, I will give you a quick revision of grade 12th part, right? For the grade 12th part, we will only take around 2 hours or so, right? For grade 11th, I know kids are weak, so which is why I gave you so much time. Quickly solve it, right? Think about it for a minute and I will solve it after that. Yeah. All right. So when we talk about the vertical component or the vertical projection, what is that vertical projection? You see, let me explain you from the beginning. Y projection of the radius vector of the rotating particle. So radius vector is this vector. The particle is over here at t equals to 0. Look at that. And it is rotating like this. So at time t, you look at that. This word t equals to 0 has a significance. If it was written here and the sense was rotation was different, we would have done a different thing. But at t equals to 0, the particle is here. And it is rotating in this direction. So after time t, it is going to come like this, right? So this is the new rotating vector, right? So it has covered a certain phase phi. It has covered a certain phase phi. Phi is equals to omega into t, right? Phi is equals to omega into t, right? So you see that what will be the vertical projection right now? The vertical projection is this. What is that? The radius vector is r, so it is r cos phi. This is the vertical projection. That's it. That's it, r cos phi, right? So the vertical projection y at time t is r cos phi. So what is r? It is 3 meters amplitude. Okay. Cos phi, cos omega t. What will be the value of omega? Omega is 2 pi upon time period. Time period is given 4 seconds. That's it. Right. 3 cos 2 pi by 4 into t, or 2 pi by 4 you can write it down in pi by 2. 3 cos pi by 2 into t. 3 cos pi by 2 into t. Right. So option A is the correct option. Okay. All right. No worries. Let's move on and talk about the next one. Okay. So look at this one. The xt graph of a particle performing simple harmonic motion is shown in the figure. Xt graph is shown in the figure. The acceleration of the particle at t equals to 2 seconds is. The acceleration of the particle at t equals to 2 seconds is. Try to answer it. The acceleration of the particle at t equals to 2 seconds is. So look at that. At t equals to 2, the particle is at the extreme position, right? These are the position of the particle x. Here you have position of the particle for different values of time. So at this value, the particle is at the extreme position, right? At extreme position, what is the value of amplitude? What is the value of acceleration? Sorry. At the extreme position, what is the acceleration? So you know that at the extreme position, acceleration is a omega square. We also use a negative sign to show that nature of acceleration is opposite to the displacement, right? So negative a omega square. Amplitude is how much? This is the maximum displacement. This is the amplitude 1, right? Omega square. What is omega over here? Omega is 2 pi upon time period. You see that? 2 pi upon time period, right? So you see, time period is to complete one entire cycle. The time taken is 8 seconds. So omega is 2 pi by time period, 8 seconds. I hope it is making some sense. So 2 and 4 minus pi square by 16. Got it? This is the acceleration at t equals to 2. This is the acceleration at t equals to 2. Option B is the correct option. Yeah. Rajeshri, Patil and Mayur, these kids were able to give the answer correctly. Nice. The phase difference between the displacement and the acceleration of a particle in a simple harmonic motion is. What is the phase difference between the displacement and the acceleration of a particle in a simple harmonic motion? Tell me. Phase difference between the displacement and acceleration. You know that for me, for most of the guys, I can start the time period. You know that for a particle performing SHM, the equation of displacement is simply a sine omega t, right? Now you differentiate it, you will get the expression for velocity, a omega cos omega t. You differentiate it further and you will get the expression for acceleration. Let's call it alpha. A omega square sine omega t with a negative sign, right? Now we have to talk about the phase difference between displacement and acceleration. Displacement and acceleration. You see that? Sine omega t and minus sine omega t. Minus sign will come up over here. You can also write it sine pi minus omega t like that, right? Or in that situation. No, sine pi plus omega t, right? So you see that's why you will get the minus sign like this. So over here you can see the phase is, acceleration is pi phase ahead of displacement, right? Yes or no? So phase difference between y and alpha is pi. Okay, so pi radian. Phase difference between them is pi radian. Okay. Now let's talk about few more things. Look at this question. A particle executing simple harmonic motion with amplitude A has same potential and kinetic energy at the displacement. Right? Same potential and kinetic energy at the displacement. Okay. So we have to talk about these, which of these option is going to be correct. A particle executing simple harmonic motion with amplitude A has the same potential and kinetic energies at the displacement. Good question, but easy question. Try to solve it. Same potential energy, same kinetic energy, right? So what will be the potential energy? We can say that at a displacement x, potential energy will be half kx square. What will be kinetic energy? Half k a square minus x square. They are same, right? Just solve it from here. Just solve it from here. Half k and half k we can cancel out. We have a square minus x square, that is equals to the x square. We have 2x square is equals to a square. So from here, the value of x can be figured out. Nice. Let's continue. And I believe the idea is very, very clear. So x is going to be a upon root 2, which is option C. Hmm? Okay. So Rajashri, Mayur, Vidha, and Natraju. They are all correct. Let's move on and talk about the next one. This one is good. The initial tension of on a stressed string is doubled. Then the ratio of initial and final speed of transverse wave traveling along the string is. This is the last question of grade 11th, right? Okay. So you know that for a wave to travel over a string, it must have certain tension. If the string is slacked, the wave will not travel through that, right? And if we know that the mass per unit length of the string is mu, then the velocity of wave traveling through that is tension upon mass per unit length. This string must be under tension, then the velocity is under root t upon mu. Okay. Yes or no? So what is happening? The initial tension on the stress string is doubled. So the tension is doubled. The ratio of initial and final speed of the transverse wave traveling around the string is going to be. So V dash is under root 2t upon mu. Right? So just solve it and you will have your answer. That's it. You see that this is this and this is cancelling out. So 1 upon root 2 is the answer. Right? 1 is to root 2, which is option C, which is option C. Option C is the correct option. Right? I hope the idea is very, very clear. Okay. So let's do one thing, right? Let's now start talking about the grade 12 syllabus. Let us try to revise that as well, right? So, grade 12 syllabus has been there now. So let's start it. Let's start the grade 12 syllabus. But before we do that, let's take a 15-minute break, right? So let's take 15-minute break and let's start from this particular part. So we'll be starting at 7:45. Okay. So now what are we going to do is we'll be talking about mostly conceptual stuff, and it's going to be very easy for you, right? Just sit back and relax, look at all the formulas, and all the preparation is going to come into the right place, right? So yeah, just I'll see you there after 15 minutes. Okay. Leaderboard I have to show you. This is the leaderboard. At rank 1 we have Sudha Patil. So she never came on the top, I believe, but she was most consistent, right? And she got a lot of questions correct. Then we have Rajashri. She attempted 58 questions, a lot of questions she attempted, right? Then we have Kohli, very consistent kid, 44 questions. Pallavi, 28. Dhanush, 26. Dhanush Gowda, 31. Lot of kids were there. A lot of kids, uh, did a lot of hard work, I would say. Okay. So many, many congratulations to Sudha Patil, right? And I'll see you there after 15 minutes. So at 7:32 is there. Around 7:50 I will come back. 7:50, right? So I'll come back at 7:50. So not 7:45, 7:50. Hello, hello. Hello, 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 hello. Am I audible and visible, everybody? Hello, everybody. Hello, hello, hello. So, if I'm clearly audible and visible, just give me a quick yes. We will start right away with the grade 12 topics. Hello, everybody. Okay. All right. Okay, my dear kids. So, in the grade 12 topics, what are we going to do? Right. I believe you are solving PYQs already. But what happens in the grade 12, we do a lot of silly mistakes, right? Why do we do a lot of silly mistakes? Because we maybe have not revised formulas really well. The concepts are not that well, right? So instead of focusing entirely on PYQs in the grade 12th, I have also included the concepts, right? So my dear kids, it will take around 2 to 3 hours, not more than that. Even I will try to keep it less than 3 hours, somewhere between that, right? And the entire thing will be completed, right? Okay. Is it making sense? Right. So we are going to start with the grade 12 topics and we will be revising with the concepts as well, right? So let's start right away with the first chapter of electrostatics, right? That is here, right? Electrostatics. So as I said, our main focus will be the concepts, right? Okay. So electrostatic charges and field, electrostatic potential and capacitance and current electricity. This is the first set of topics. After this, we will talk about the second set of topics, right? Gradually, we will talk about everything. So let's talk about electric charges and fields. So what is that? You know that by nature, there are two types of charges. One type of charges we call positive, the other charge we call it negative. Same charges will repel each other and the unlike charges will attract each other. By default, we know, right? We denote it by Q, we call it the unit coulomb. Now, the smallest possible value of charge that any body can have is the charge of an electron. And if the total charge is there Q, that must be the integer multiple of the number of electrons or the charge of a single electron. So Q is equals to N into E. So this is, we can say that the charge is quantized. Let's say that in a country, like let's say India, let's remove the digital payments. And right now, I believe none of us have 50 paisa coin, right? So the smallest money that you can give someone is 1 rupee, right? So right now, practically, we can say the money is quantized in 1 rupee. The smallest value that you can exchange is 1 unit, 1 rupee. Similar to that, the smallest charge that you can exchange is the charge of an electron, right? So if any body is charged, you have given some amount of charge, you have given an integer multiple of electrons, or you have taken out the integer multiple of electron, and effectively the amount of charge is n times E. Effectively, the amount of charge is n times E. I believe the idea is very, very clear, right? So over here, let us move on and talk about the next idea of Coulomb's law. This is where the electrostatics actually starts, right? So what is Coulomb's law? In the Coulomb's law, we talk about the force acting between two charges Q1 and Q2, which are placed at a distance r apart from each other, right? We say that if there are two charges placed at a distance r apart from each other, the value of force will be K times Q1 Q2 by R square, right? So there are two charges Q1 and Q2. They are placed at a distance r apart from each other. The value of force that will act between them is going to be K times Q1 Q2 by R square, right? This is electrostatic force, right? Okay. So here it is. The value of K depends on the medium. If the medium between the charges is air, then in that case, K is 1 upon 4 pi epsilon naught. Epsilon naught is permittivity of free space or air, right? If you have a medium in between charges, then the value of K, this constant, will be different, right? We will talk about that later. So here it is. Okay. Now, the force itself is a vector quantity. So we must be able to write the value of Coulomb force in the terms of vector. So how can you do that? Right. Just use a unit vector, multiply the same thing with a unit vector and you can get it. Nothing very serious about it. So force between the multiple charges, right? So there are multiple charges and we want to know that the force between them. So clearly, the nature of the electrostatic force is such that it will remain, the force between two charges will remain unaffected by the presence of other charges, right? So let's say that this is the charge 1, this is the charge 2, right? They are applying some certain force on each other. Let's say that the charge 2 is experiencing force like this. Both of them are positive charge for that matter, right? So let's say that it is experiencing a force of 10 Newton because of the charge 1, right? My dear kids, if another charge particle comes up, let's say we call it charge third, right? This is, let us say, a negative charge. So of course it will attract the second charge, let's say by 20 Newton, right? My dear kids, that force will not change the force which was acting previously between these two charges, right? If we have any other charge 4, let's say this is a positive charge, it will also repel it, right? My dear kids, let us say this force is 5 Newton. Again, the force between these two will not affect the force between them and them, right? I hope the idea is very, very clear. So we can say that force between any pair of charge remains unaffected by the other pairs, right? By the availability of other pairs. But we can say the net force on any given charge is the vector summation of all the forces acting on it, right? So net force on any given charge is the vector summation of all the forces acting on it. Okay. So E is equals to F upon Q. We know that part really well. Okay. Now look at this question, a very small question, right? Okay. An electron experiences a force 1.6 into 10 to the power negative 16 Newton in an electric field E. What will be the value of electric field? My dear kids, the value of electric field or the intensity of electric field is force experienced by a unit charge. Just like the gravitational field intensity is the gravitational force experienced per unit mass, here we have the electric field intensity is electric force experienced by per unit charge, right? So force experienced per unit charge, what is the value of force? It is this much. Per unit charge, charge is what is the charge of an electron? Because electron is experiencing this much force. So the charge of the electron is 1.6 into 10 to the power negative 19. So this is that many newtons, and charge on one electron is 1.10 to the power negative 19. So you see that this is cancelled out and this will go up. It will become 10 to the power 3. 10 to the power 3 Newton per Coulomb. All right. Since the force is in the direction of I cap, this electric field is also going to be in the same direction, right? My dear kids, think about it. Electric field is in this direction. This part we have to think about. Electric field is from positive to negative, right? So what will be the direction in which the force of the on the electron will act? Electron will experience a force in this direction. You see that towards the positive end. So you see, if the electric field is in this direction, electron is experiencing a force in the opposite direction. Electron is experiencing a force in the positive I direction. So the electric field will be in opposite to that. It is going to be in minus I cap direction. So that part we have to correct, right? So the force is going to be opposite. The electric field is going to be opposite to the force experienced by the electron. This is the interesting part, we will say. This one is correct. Option D is correct. Okay. All right. Oh, it is 10 to the power minus 3. It is 10 to the power plus 3. It's not option 3. Option B is correct. All right. So I hope the idea is very, very clear. The direction of force on an electron is definitely opposite to the direction of electric field. So while taking the direction of electric field, we must take that into consideration. That is the important point. I hope the idea is very, very clear. Okay. Now let's talk about the next part. B is correct. Very good. Very good, Archita. Mayur, very good. The magnitude of electric field due to a point charge object at a distance 4 meter is 9 Newton per coulomb. From the same charged object, the electric field magnitude 16 Newton per coulomb will be at a distance of what? Answer it in the chat box. Right? Answer it in the chat box. So the magnitude of electric field due to the point charge object at a distance of 4 meter is this, right? At what distance the force will be 16? Okay, or at what distance the magnitude of electric field will be 16? Right, try to answer it. Let's call that distance is x, at which the value of electric field is 16. So we know that the force, the electric field is kq by r, right? Okay. Let's say the electric field of a point charge, let's say the point charge itself is q, right? At a distance of 4 meters. So it is going to be kq by r, kq by r, right? And electric field over here is 9, sorry. It is kq by r is how much? 4 meter. Okay. And let's say that the value of 16 you get at a distance of r. Okay, so this part will be cancelled out. R upon 4 is 9 by 16. R upon 4 is 9 by 16. So it is 9 by 4, right? Like this. So I hope the idea is very, very clear. Okay. All right. This is 9, kq by 4, and 16 will be kq by r. So r upon 4 is going to be 9 by 16. So roughly it is 2 meters. Roughly it is 2 meters, we can say. Because it is, when you divide it, it will be 2.25. Yes or no? 2.25. So we can approximate it to 2. It's closer to 2 than 3. So let's move on and talk about the next one. Electric field lines, right? So the electric field lines are basically the geometric representation. Huh? The electric field lines are nothing but the geometric representation of the electric field around a given charge distribution. If you have a positive charge, by custom, we show that the electric field lines are going outwards. They have to be perpendicular to the surface always. And if it is negative, then we will assume that it's a sink and the charge lines will enter into it, right? The problem with the electric field lines is they never close a loop, right? They never close a loop. They never do it, right? So what really happens is, if you talk about a magnet for that matter, the magnetic field lines come out of north, they enter into south, and they continue to travel into the magnet. But if you talk about the electric field line, it starts from positive and it terminates at negative. It doesn't come back, right? So magnetic field lines form a closed loop while the electric field lines do not form a closed loop, right? Move on. Electric field lines, okay, like this. So there are certain properties of electric field lines. Many times questions are asked in the NEET exam based on the properties of electric field lines, right? So out of these properties, this one is most interesting. Two field lines will never intersect each other, right? Why so? Because just like the tangent of magnetic field will show you, just like the tangent of magnetic field line will show you the direction of magnetic field over there. Let's say the tangent over here will show you the direction of magnetic field over here. And here, the direction of magnetic field is here, tangent to the point field line over here, right? A given magnet can create a magnetic field at one point in one direction, right? For example, I cannot apply the force on one object in two directions at the same time, right? So just like that, a given magnet cannot create the magnetic field in two different directions at the same time. Yes or no? Similar to that, a tangent at electric field line will show me the direction of electric field over there. If two field lines are intersecting at a certain point, like this, then at the point of intersection, I can draw the tangent to this line as well as this line, right? That means at the point of intersection, the direction of electric field is this as well as this, which is impossible because a given charge cannot apply the force at one point in two directions simultaneously, right? So this is going to be impossible, which is why we can say two electric field lines can never intersect each other, right? Because if they do, then at the point of intersection, there will be two directions, which is impossible, right? Now, so the question is, no two electric field lines can intersect each other. Why? Answer is very clear. Now the electric dipole. Electric dipole is an entity that is consisting of a positive and a negative charge of equal amount placed at a certain distance. In most of the scenarios, that distance is assumed to be twice of A. Why is so? My dear kids, whenever we take a charge and we want to know the electric field at a certain distance from a charge, we can say that distance we can measure directly from the charge itself. This is the point P, where we can talk about the electric field potential and all other things. But when we have a dipole of positive and negative charge, and let's say that a point P is there on the axis of the dipole at a distance of 20 centimeter. So from where we should measure that 20 centimeter? From negative, from positive, from where? So in the case of dipole, it is a custom that we measure all the distances from the center of the dipole, right? So this is the point. We measure the distances from the center of the dipole, and if we take it as D, then every time, let's say that this distance is A, right? And every time will be D by 2 plus A and D by 2. All of that will be making our life very hard. We don't want to do that. Life is already very hard. So we can say that this distance is 2A. We call half of 2A is A and A, right? So what will happen? A plus, come on, right? A plus, let's call this is X. So this distance is A plus X and this is 2A plus X. I believe the idea is very, very clear, right? So this is the idea that should be there. So generally we assume the distance of the dipole or the length of the dipole is 2A, right? Okay. Now, electric field due to the dipole along the axial line. So you see that this is the dipole and there is a point P at which you want to calculate the electric field. So at P, we will assume a unit positive test charge, and the positive charge of the dipole will push it, negative charge of the dipole will pull it, right? But clearly the point P is closer to the positive charge, so the push by the positive charge will be clearly higher than the pull of this thing. So this is why this vector is bigger, this vector is smaller, and the net electric field will be there because there will be net value. This is bigger, this is smaller. You subtract them, you will get something value, right? So at a point which is lying on the axis of the dipole, the net electric field is subtraction of these two, right? So you will calculate the electric field due to positive charge, due to negative charge, and subtract it, and the value comes out to be, is kq by r, kq by, now you have to convert that into terms of dipole moment as well. So there is a term called electric dipole moment. For a given dipole, the length of dipole, if you know, you assume at 2a, so length of dipole and the value of any one of the two dipoles, q, right? Multiply them, you will get the dipole moment. It's a vector quantity. The direction of the dipole moment is from negative charge to the positive charge, right? The direction of the dipole moment is from the negative charge to the positive charge. Very useful quantity. So just look at this thing, 4a into q. So this is the twice of dipole moment. So you can put it over here and you can simplify the expression for yourself. All right. All right. So here we have it. Here we have it. All right. So this is for the dipole. This is for the electric field on the equipotential surface, right? equatorial plane, sorry, this is positive, this is negative, this is the axis, this is center, and the plane passing through the center is the equatorial plane. Any point taken on the equatorial plane is there. Let's call the point is P. Positive charge will repel it. Imagine a unit positive stress charge. The positive charge will repel it, negative charge will attract it, and the net electric field will be resultant of these two, right? So this is what we are trying to calculate, and in the case of equatorial plane, it comes out to be this value, right? Okay, right, it comes out to be this value, right? So it is Kp upon r cube. Kp upon r cube. Look at this question and try to solve it. Look at this question and try to solve it. A point charge situated at a distance r from a short electric dipole on the axis experiences a force F, right? Short point is situated on the axis, it is experiencing a force F. If the distance of the charge is 2r, if the distance of the charge is 2r, the force on the charge will be, what will be the force on the charge? My dear kids, point charge is situated at a distance r from the dipole. So my dear kids, from where I should be measuring that r? Point r is situated at a distance r from the dipole. Should I take r from here? No. The distances are measured from the center of the dipole, right? So here we have the dipole, this is the center, and from the center we will measure the distance of point P, that is initially r, right? Okay. And now you are pushing that part, right? You're pushing the point P away to a distance 2r, right? So clearly the electric field will reduce and the electric force will reduce, right? The force on the charge will reduce, right? So what will be the new value of force? My dear kids, you have seen it. The value of force is inversely related to the cube of distance, right? So following that logic, try to get the value of new force. This is for you to answer. Right? This is for you to answer. Now, initially from the dipole, the point is at a distance r. Now we have pushed it to a new distance 2r. What will be the effective value of force right now when you have pushed it? So as I said already, the value of force, the value of electric field and electric force is proportional to 1 upon r cube in case of dipole. So here we have seen it. When you double the distance, the force will become 1 upon 2 cube times, which is 1 upon 8 times, right? So it is F upon 8. I hope the idea is very, very clear. All right. So option B is the correct option, and let's see how many kids are giving the correct answer. क्या कर रहे हो तुम लोग? So no problem. As Purva, Archita, and Dhanush are giving the correct answer. Nice. Okay, let's move on and talk about the next one. Torque on a dipole in a uniform electric field. My dear kids, just like a magnet placed in a magnetic field wants to experience a torque, just like that, a dipole placed in an electric field will experience a torque. Wow, how? This is the electric field from positive to negative. Here we have a dipole. This is positive, this is negative, let's say, or just put it in a stable condition. This is negative, this is positive. So what is happening? This is a dipole placed at an angle from the electric field. So the negative will be attracted toward the positive end, and positive will be attracted towards the negative end, and this thing will try to rotate the dipole. So clearly a dipole placed in the electric field will experience a torque. Force? No, it will not experience a force because these are same charges placed in the same electric field. It is experiencing a force Q into E. It is experiencing a force Q into E. Both of them are in opposite direction. They will cancel out each other. So net force on a dipole in a uniform electric field is 0. So dipole, however, will experience a net torque. Is that clear? Dipole is going to experience a net torque. I believe the idea is very, very clear. Right. Santosh, I have told you that for the grade 12th part, I am going to give you the theoretical revision, and for grade 11th part, I am going to give you the PYQ revision, right? That was the thing I have explained in the beginning, right? Okay. So, however, we'll be solving some questions as well. So here it is, right? For electric flux is nothing but how much of the available electric field is linked with the given area. For example, here I have, let's say, a surface, right? And the electric field lines are coming in this particular fashion. If electric field lines are coming from this fashion, so most of the electric field lines are associated with it. If I try to tilt it, right, then what will happen? The number of field lines are now sliding away. If I make it like this, so most of the field lines will slide away. So clearly, for a given area, the orientation will also decide how much of our available field is going to be linked with the given area, right? So clearly, right now you can say that the electric flux is basically how much of the electric field is associated with a given area. It is E ds cos theta. E ds cos theta, right? Clear? Okay. Gauss's law. My dear kids, what is Gauss's law? Gauss's law talks about that the net flux and associated with a closed surface, right? The net flux associated with a closed surface. Now, this part I have explained in the main classes in extreme details. Just for a quick note, we can say that the electric flux, if this is a closed surface and this is a charge outside the closed surface, the electric field lines, whatever electric field lines will enter to the closed surface, they will also exit, right? So we can say for any charge which is outside the closed surface, the net electric field due to that is 0. But if there is a charge inside, then it is contributing to the electric flux associated with that particular closed surface, right? So Gauss's law talks about the net flux associated with the closed surface is charged and closed upon epsilon naught. Charged and closed upon epsilon naught. Charged and closed upon epsilon naught. Right. So, yeah. So we can apply the Gauss's law in various situations, right? And this is how we can come about it. So we have, these are the formulas you have to keep in your mind, right? You can get the direct questions from these formulas as well. So here you have a distribution of charge, right? And at a distance r away from it, what will be the electric field from a linear distribution of charge? If the linear distribution charge density is lambda, right, then the value of electric field is lambda upon 2 pi epsilon naught into r. Lambda upon 2 pi epsilon naught into r. I believe the idea is very, very clear. Let's keep on moving. We have to use Gauss's law to obtain an expression for the electric field due to infinitely long thin straight wire with uniform linear charge density lambda. So this is the expression. Lambda upon 1 upon 2 pi epsilon naught lambda upon r, right? Okay. All right. So let's keep on moving and talk about the next idea. Again, another application of Gauss's law. We have a sheet of charge, right? Or you can say the charge is distributed over a plane. So in that particular case, when the charges are distributed over a plane, then what will be the value of electric field? My dear kids, if the charges are distributed over a plane, then what will be the value of electric field? Sigma upon 2 epsilon naught, right? Due to a infinite plane, the charge distribution is there over an infinite plane, and the surface charge density is sigma, then the electric field is sigma upon 2 epsilon naught. Remember that, right? For linear charge density lambda, the electric field in front of it is lambda upon 2 pi epsilon naught into r, and for surface charge density is sigma upon 2 epsilon naught, right? Many times kids do not remember the formulas correctly, and they do not attempt the same question, which is easy as well, right? Now, the electric field in case of thin spherical shell. So there are certain cases, right? When you talk about a spherical shell, thin spherical shell, so what will be the electric field outside? So electric field outside is going to be same, right? Electric field outside the shell is going to be sigma upon epsilon naught, No worries about that, right? And inside the spherical shell, the electric field is going to be zero, right? Inside the spherical shell, the electric field is going to be zero, right? This is the question you have to solve. Two charged conducting sphere of radii A and B are connected to each other by wire. Two charged conducting sphere of radii A and B are connected to each other by a wire. Find the ratio of electric field at their surfaces. Find the ratio of electric field at their surfaces. My dear kids, this is a very interesting question. Try to solve it, right? So in just 2 to 3 hours, we have to go through the entire grade 12 syllabus, right? So you will be able to revise all the formulas of grade 12th and all the essential concepts of grade 12th in just 2 to 3 hours, right? That is how much time I need. Okay. Very good. Right, so just focus on this particular part. What will be the ratio of electric field on the surfaces? My dear kids, these two surfaces, these two spherical conducting bodies will keep on transferring the charges unless and until they acquire the same potential over their surfaces, because you know that charges are transferred because of potential difference. As long as there is a higher potential and lower potential, the charges will keep on moving, right? The charges will move from higher to lower potential, right? Positive charges will move from higher to lower potential, negative charges will move in the opposite direction, right? So clearly we can say that these bodies, when they are connected, right, they will keep on transferring the charges till they acquire the same potential, kq by r. So at the equilibrium, kq by a and kq by b, that is going to be same. Potential of this particular body, it has a radius a, right? It has a radius b. So kq by a and kq by b, that is going to be the value of potential on them. So it is same. So E1 upon E2, the value of electric field, once you know the value of charges ratio other than the ratio of q1 is to q2, so electric field is kq by r square, right? So just put the ratio, q1 upon q2 is nothing but a upon b, and solve it. E1 upon E2 comes out to be b upon a, right? Value of electric field on the surface is b upon a. All right. So good question. All right. So let's move on and talk about the second set of concepts. And the concepts are going to be from this chapter, electrostatic potential and capacitance, right? Let's revise the concepts of electrostatic potential and capacitance. Let's revise the concepts of electrostatic potential and capacitance. A lot of interesting things will come up. Focus, everybody. So over here, electrostatic potential at a point, right? How will you describe it? In an electric field is the amount of work done in bringing a unit positive charge from infinity to that point. What does that mean? Right. This is a charge particle, right? And you can say that another charge particle is interacting as long as it is closer to it. Now it is interacting less when it is further away. The charge particle, now it is interacting even lesser. There will be a space beyond which another charge is not going to interact with this charge that much, right? The interaction between them is going to be negligible. So practically we can call that space as infinity, undefined, right? Beyond that, this charge and this charge, they are not going to interact with each other, right? Beyond that, these two charges are not going to interact with each other, right? Just a second. Hello. All right. So thanks for waiting, everybody. I had to change a few things, but I believe now everything is fine. Am I clearly audible and visible? Okay. All right. So let's continue. Right. So here we have talked about electric potential. Right. So electric potential, you hear right now, like we can say that this particular charge has zero potential, right? But if you have to take it from infinity to this particular point, you have to do some work. If you have to take from this point to this point, you have to do even more work, right? So work done to take the charge, unit charge, from infinity to a certain point inside the field is the potential of that point, right? You take it from infinity to that place, it is the work done per unit charge potential of this point. All right, I believe that is very, very clear. It's a scalar quantity, unit is volt. Okay. And in the integral format, it is like this. So of course there is no problem in this part, right? Okay. So in terms of this thing, if there is a charge, a particle q, right, then what will be the value of electric potential at a distance r away from it? So if there is a point charge q that is creating the electric field around it, so the electric potential of a point which is at a distance r away from it is going to be kq by r, right? The electric potential of a point which is at a distance r away from it is going to be kq by r. I hope the idea is very, very clear. Okay. All right. Now the next thing is potential due to system of charges. So unlike electric field, potential is a scalar quantity, right? So there are multiple charges. Now potential at a distance r from a point charge is kq by r. For in case of all these charges, it is kq by r1, kq by r2, kq by r3 plus and so on. Just add them all up, right? Add them all up. Positive charges use positive sign, negative charges use negative sign, right? Just add them all up, right? So it's an algebraic summation of it. The net electric field is a vector summation at any point. Net potential is a algebraic summation at any point, right? I hope that is very, very clear. Now, at any random place, point P, what will be the net potential? Let's say that there is a dipole, negative, positive. The direction is from negative charge to positive charge, like this, right? This is the center of the dipole. The point P is at a distance r and making an angle theta. So this is a general situation for any particular point to exist, right? For this situation, the electric potential is going to be Kp cos theta over r square. Kp cos theta over r square. 1 upon 4 pi epsilon naught is K. So it is going to be Kp cos theta over r square. This is the potential due to the electric dipole, right, at an angle theta and at a distance r away from it, right? So clearly all the distances are measured from the center, right, and the angle is measured in this way. Okay, let's move on and talk about this particular part. Kp cos theta by r square. So for a spherical shell, clearly you can say that the spherical shell, it is kq by r, the potential is kq by r, and unlike the electric field, if you had the shell like this, the electric field inside the shell was zero. Now understand that the electric field inside the shell was zero. On the surface, the electric field is something, right? Kq by r square. Now you see that at the surface, the potential is also kq by r. Okay, it is non-zero, kq by r. This is the potential at the surface. If inside the potential was zero, from higher to lower potential, an electric field will set up, right? But we know that inside a shell there is no electric field, and since there is no electric field, that means there is no potential difference between these 2 points. That means whatever potential we have on the surface, same potential we have over here, and same potential we have at every point in between, right? So the potential inside any point of the spherical shell is kq by r, kq by r, right? Kq by r. So potential at any point inside the shell is kq by r. Electric field inside the shell is zero, right? Now, this is the relationship between the electric field and the potential gradient, right? So here E is equals to dV by dr. We can talk about that. We can talk about that. If there are two surfaces, right, and these two surfaces are at potential V1 and V2, so the potential difference between them is dV. The separation between them is dr. So clearly, due to the potential difference, an electric field will set up. My dear kids, how much electric field will set up between these two plates or surfaces depends how far they are, right, and how much potential difference there is, right. Now, there is a term called potential gradient. It is dV by dr. So this is how you can decide the electric field. It is potential gradient dV by dr. Negative sign is there as well. That means the direction in which the potential is reducing. Higher potential to lower potential, right? The electric field is in the direction where the potential is reducing, right? Electric field is in the direction where the potential is reducing. Sirish, around 2 more hours, right? Yeah. So let's move on and talk about that, right? Let's quickly revise the concepts. Equipotential surfaces. What do you mean by equipotential surface? As the name suggests, a surface on which potential is same everywhere is called as equipotential surface, right? A surface where the potential is same everywhere is called as equipotential surface. My dear kids, if we have electric field like this, then the point A and point B along the electric field cannot be at the same potential because electric field is from higher to lower potential. If the electric field exists between A and B can never be at the same potential. A must be at the higher potential, B must be at the lower potential, and the reason there is electric field from higher to lower, they cannot be at the same potential. Now apply this knowledge. Here we have a surface, and if the electric field is making some angle with the surface, right, let's call that angle is theta. So there will be two components of electric field, E cos theta and E sin theta. Now if you think closely, if there is an electric field component along the plane, then any 2 points on the plane along the electric field will not be at the same potential. This point will be higher potential and this point will be at the lower potential. Clear? So we can say that if the electric field is making an angle with a surface, then a component of electric field will exist along the surface, due to which the surface will have different potential at different points. And this surface cannot be equipotential because for an equipotential surface, all the points must be at the same potential, right? So how will you get a surface as equipotential surface, right? How will you get a surface equipotential surface, my dear kids? For any surface to be equipotential, all the points must be at the same potential and there will be no electric field components along it. Clear? So if I want no electric field component along a surface, that means the electric field lines must be perpendicular to it. This is the reason why we say that the equipotential surface always have electric field perpendicular to it. This is the reason, right? Electric field lines are always perpendicular to the equipotential surface, right? I hope the idea is very clear. Let's continue and keep on moving in the forward direction. We have equipotential surface like this, right, for a dipole. Okay. Which of the following is not the property of an equipotential surface? They do not cross each other. The work done in carrying a charge from one point to another point on an equipotential surface is 0. For a uniform electric field, they are concentric spheres and they can be imaginary spheres. So which of the following is not a property of equipotential surface? Think about it. Which of the following is basically wrong? Try to answer it in the chat box. Right. Which of the following is not the property of equipotential surface? Which of the following is not the property of the equipotential surface? Very good, Veda. Very good, Dhanush. Very good, Rajeshri. All right, all right, all right, all right. Let's see. So here I can see that Sudha has given the answer first, then Vidha, then Rajashri, Sneha, Likhita, Chinmay, and Amrut. Okay. These kids are giving the correct answer. So for a uniform electric field, they are concentric spheres. No. For a uniform electric field, for a point charge, the electric potential equivalent surface will be the concentric spheres. But for a uniform electric field, think about it. Uniform electric field is like this, right? In this situation, the equipotential surfaces must be parallel to each other, like this. Like this, okay? This is how the equipotential surface will look like. So this is the wrong option. This is not the property of equipotential surfaces for the distribution of in like this. Which of the following is not the property of equipotential surface? We have discussed that. Now, potential energy of a system of 2-point charges. So we have 2-point charges Q1 and Q2. Potential energy of 2-point charges is KQ1 Q2 by R. My dear kids, think about it. In all the pairs, if I have 10 pairs of the charges, in every single pair there will be potential energy. For example, if I have 3 charges Q1, Q2 and Q3, for a single pair the potential energy is KQ1 Q2 by R. The distance between 1 and 2 is R12. Distance between 2 and 3 is R23. Distance between 1 and 3 is R13. What will be the potential energy of 3 charge system? We can say that K times Q1 Q2 upon R12, K times Q1 Q2 upon R12 plus K times Q2 Q3 upon R23, Q2 Q3 upon R23, K times Q1 Q3 upon R13, Q1 Q3 upon R13. Yes or no? So there are 3 pairs and every pair will store some potential energy. So when you have a combination of charges, then whatever number of pairs you are getting, every pair will store some potential energy. For example, imagine a pair of 4 charges, right? If you have 4 charges, this is the charge 1, charge 2, charge 3 and charge 4. This is the distance between R2 and R3, R2 and 3. This is R43, this is R14, this is R12. My dear kids, there are 2 more pairs that you can form. This pair which is RQ2, R42 and this pair which is R13. Every pair is going to have potential energy and every pair will add up. So the net potential energy of a 4 charge system is K times Q1 Q2 upon R12 plus K times Q2 Q3 upon R23 plus K times Q4 Q3 upon R43 plus K times Q4 Q1 upon R14 plus K times Q1 Q3 upon R42 plus K times Q1 Q3 upon R13. Q1 Q3 upon R13 we should write over here, and Q1 Q4 Q2 upon R42. All right. So 6 pairs are there, and every pair is going to have potential energy. I believe the idea is very, very clear, right? Okay, let's move on and talk about the next one. Now, if we have talked about the potential energy of a pair, right? But what will be the potential energy or the energy stored in a dipole when you have placed it in the external electric field? Think about it. If we have a mass that is placed in a gravitational field at a height h, it has a gravitational potential energy with respect to this level. Gravitational potential energy right now is mgh, right? But if you have two masses, if you have charges, right, positive and negative charges, they are forming a dipole like this, q and minus q. They are placed in the electric field. So what will happen? They want to rotate. They have a potential energy due to which they will want to rotate, right? So how much potential energy is there? It is simply torque acting on it is P sine theta, we know, right? So whatever work is done to rotate an angle d theta, that is the energy stored in it. So we can say that potential energy is P dot E or Pe cos theta. If you want to rotate a dipole by an angle theta, how much energy will be stored in the process? Pe cos theta, right? Or you can say Pe cos theta naught minus cos theta dash, right? Okay. All right. So P dot E is the energy stored in the dipole. P dot E is the energy stored in the dipole. Let's keep on moving and revise further. The next thing is capacitance. Quickly revise about the capacitance. Capacitance is, we can say, the ratio of the charge stored for a given potential difference, right? Capacitance can be defined for a body. Anything can store charges, and anything can have capacitance. So the charge is stored for a given volume, not volume, it for a given voltage. So C is equals to Q by V. Okay. Capacitance of a parallel plate capacitor. So for a parallel plate capacitor, the net capacitance depends on the geometry and the material that is filled inside, right? So geometry means the cross sectional, the area of the plate is A and the separation between the plate is D. So in that situation, the capacitance of a parallel plate capacitor when there is air in between is epsilon naught A by D, right? But if you fill that capacitor, the capacitance will increase by k times, right? We will talk about that. If the capacitors are connected in series, the net capacitance is linked with this fashion, pretty much similar to how resistors behave in parallel combination, capacitors behave in a series combination, right? Remember that. And opposite, the way capacitors behave in parallel combination, resistors behave in the series combination, the net capacitance adds up. Effect of dielectrics on the capacitor of parallel plate capacitor. So clearly, when you introduce a dielectric, the purpose of the dielectric is it reduces the net electric field between the plates, and by reducing the net electric field between the plates, it allows you to store more energy on the same given capacitor, right? So if you introduce a dielectric with dielectric constant K, right, how much more energy you will end up storing? So we can say the new capacitance is K times epsilon naught A by D. The previous capacitance was epsilon naught A by D. Now it is K times of previous capacitance. If the dielectric constant is 100, so the new capacitance is 100 times previous capacitance, right? Now let's talk about the energy stored in the capacitor. So the energy stored in the capacitor is Q square upon 2C or half CV square, just half CV square, remember that one. And in this one we are substituting every time. So Q equals to CV, right? We can substitute any of C or V from that expression. Q equals to CV, right? We can subtract V from here. V is Q by C, so just put it Q square by this expression, you will get C square, right? And if you remove C from here, you will get this expression. So any expression you can get from this one. Q is equals to half CV square. Energy is stored in the dipole. My dear kids, there is another quantity that is called energy density. That is energy stored per unit volume. It is half epsilon naught into E square. If a capacitor is placed in the electric field E, then the energy density is half epsilon naught E square. Right. Now let's revise the concepts of current, electricity. Right. It's not taking much time. It's not going to take much time. And we will end up revising the entire grade 12 syllabus. Right. Current, electricity. Right. I believe you have already solved many problems of grade 12. So that's why I invested so much time on the grade 11 topics. Right. If you want, I can give you questions on grade 12 as well. If you want, just put it in the chat box and I will bring some questions for grade 12th for you as well. So current, electricity. Current, electricity is electric. It starts from the electric current is rate of flow of charge Q by T. The rate of flow of charge is Q by T. All right. Just a second. We are providing quick revision, right? So rate of flow of charge is Q by T. Okay. Drift velocity. So you see that the charges, electrons inside the conductor, when it is carrying current, they are not moving with a uniform velocity, right? But we can assign them with an average velocity. We can assume that the electrons, while carrying the current, are moving with an average velocity from one end to the other end, right? That average velocity is a drift velocity. What is that drift velocity? So the force acting on the electron is Q into E, E into E, right? The charge of the electron is E into E, and mass you divide that will give you the acceleration. So here you will get the drift velocity, which is like this, right? In terms of relaxation time, the drift velocity is EEM upon tau, right? EEM upon tau. Tau is the relaxation time, right? Okay. From here, the term of mobility comes up. What is mobility? What is mobility? Mobility tells you how easy it is for the electron to move through the given conductor, right? So here it is, higher mobility means higher drift velocity. Mobility is drift velocity per unit electric field, right? So think about it. There are two conductors. If conductor 1 has higher mobility than the second one, then what does it signifies? We can say that for a same electric field, right, the electrons will only move when there is electric field across the conductor. If the conductor 1 has higher mobility, that means for a same electric field, electrons will have higher drift velocity, right? For a same electric field, electrons will have higher drift velocity. Okay, that means the higher mobility. Okay. All right. So there's another expression of current in terms of drift velocity, that I equals to NEAVD. Okay. N is number of electrons per unit volume if there is a conductor. And you know that what is the number of electrons per unit volume inside that conductor? That NEAVD, that will give you the current that flows through it. That will give you the value of current that flows through it. Okay. All right. Right. Now, the next thing is Ohm's law. So whenever we have a given resistor, right? So whenever we set up a potential difference across a resistor, because of potential difference, some current starts flowing through it. And greater the value of potential difference across the resistor, greater will be the current that will flow through it, right? This is called as Ohm's law. V remains in proportional with the current, right? And as long as these things are proportional, the circuit is called ohmic circuit. If these things do not fall proportional to each other, the circuit is not called ohmic circuit anymore. It becomes non-ohmic circuit. Now, the resistance of the circuit. Now, the question on resistance are asked multiple times, right? So, resistance formula, you must remember that the resistance of a conductor depends on its geometry and the material, right? That means longer wire means more resistance, thicker wire means lesser resistance, right? So, resistance is proportional to length, inversely proportional to cross-sectional area, right? And if you join them, the resistance for a given material of resistivity rho, R is rho L upon A, right? R is rho L upon A. Now the next thing is conductivity. So you see that conductivity is basically in this particular fashion, we can describe the conductivity like this. Okay. Opposite of resistivity, just inverse of opposite resistivity is conductivity. Limitations of Ohm's law, ohmic conductors. So Ohm's law do not valid on the non-ohmic conductors. Okay, so this is something you don't need as much as of now. Okay. So now the next thing is electrical energy. So when a circuit is carrying some electrical circuits, in an electrical circuit, some energy is associated with each component, right? So how much electrical energy is there? So you see that the electrical energy is, VI into T, right? So in case of a resistor, all that energy is wasted in a form of heat. But if there was an appliance, whatever energy you have invested will do some work. Right. Okay. Energy is VIT, right? So V is equals to IR, you know, right? So you can convert the expression into multiple format, I square RT and all that, right? This energy will convert to heat when applied across a resistor, because resistor cannot do anything. So in the time T, resistor will produce the heat, I square RT, right? Power. Power is work done or energy produced per unit time. So energy you already know, per unit time you have the power. So power is V into I, or V square by R, or I square R, right? The same variations of the same thing, right? Now when we talk about a cell, the symbol of a cell is this, a one bigger line, one a smaller line, you know that. Internal resistance of a cell, you know that when the electricity comes out of the cell and it follows through the closed circuit, some potential drop happens when the electricity leaves the cell itself, right? So due to the material of the cell, that is the internal resistance, right? So the current is EMF upon total resistance. EMF of the cell is E. Total resistance is combination of these two, they are in series, so just add them up. So this is going to be the value, right? So Kirchhoff junction rule is there. Kirchhoff junction rule says that at a given junction, no current can be stored. That means the charges are conserved. Whatever current is entering at a junction, same amount of current has to leave the junction as well. So here I1 and I2 are entering the junction. If you add them up, the net current entering the junction is I1 plus I2, and net current leaving the junction is I3 plus I4 plus I5, right? Now the next thing is Kirchhoff loop or voltage rule. So here it is saying that in a loop, whatever potential rise you get across the elements, the same amount of potential drop you will see across the elements as well, right? So or you can say the net change of potential you will observe is going to be zero. Whatever potential rise you will observe, same amount of potential drop you will observe as well. Wheatstone bridge. So if the four resistors are connected in such a way that this arm is balanced, right, then we will call this arrangement is Wheatstone bridge. That means there is no current flowing across BD. In that situation, the resistances R1, R2 and R4 and R1 and R3, they are in the same ratio, right? R1, R3 and R2, R4 are going to be in same ratio. Right. Now let's revise these things as well. Now let us revise these things as well, right? Now let us revise these things as well. Moving charges and magnetism, magnetism and matter, electromagnetic induction, alternating current, and electromagnetic waves. Quickly revise it, right? Quickly revise it. So in moving charges and magnetism, we can say that if a charge is static, it will only create electric field. If a charge is moving, it creates not only electric field but also magnetic field if the charge is moving at a constant velocity. But if the charge is moving at a variable velocity, that means it is accelerating as well. So it will produce electric field, magnetic field, and it will also lose its energy in form of electromagnetic radiation, right? Okay. So now what are we doing? We have moving charges. Now, if the charges are stationary in the electric field, they were experiencing a force Q into E, right? But if the charges were stationary in the magnetic field, they were not experiencing any force. My dear kids, if in a space we have electric and magnetic fields both, and the charges are moving through them, so electric field will still apply the force QE through on it. But now the magnetic field can also apply the force if the charged particle is moving. And that force is QV cross B. Alright. So the charged particle can experience a force by the magnetic field if it is moving. Right. Now the Lorentz force, right? The direction of the Lorentz force you can calculate by this rule, right hand rule. F is ILB. If the current carrying conductor is placed in the magnetic field, it can also experience a force ILB, right? Okay. So you see that a charged particle which is entering perpendicular to the magnetic field will start rotating in a circular path, and the radius of that circular path will be mv upon qb. The radius of the circular path will be mv upon qb, right? And the time taken to complete one circle is 2 pi r upon velocity. Velocity you have just seen, right? Okay. Let's keep on moving. So Biot-Savart law is there. So Biot-Savart law talks about how much magnetic field will be created by a small current carrying element, right? By how much magnetic field will be created by the small current carrying element. So this is what we are going to know. Right. How much magnetic field will be created by a small current carrying element. So it is mu naught upon 4 pi I dl cross r upon r cube. Right. It is in the vector format. But if it is written in the unit vector format, it depends on r square. Right. Like this. The magnitude of this thing is mu naught upon 4 pi I dl sin theta by r square. Right. Okay. Now, the next thing is what will be the magnetic field because of a current carrying current carrying loop. So it's you can calculate by this formula mu naught upon 2 IR square upon r square plus x square power 3 by 2. Right? These are the basic formulas. You have to remember them. Right? If you have a current carrying ring, then what will be the magnetic field at this place? Right? Okay. And magnetic field, just put x equals to 0. So we have calculated magnetic field on the axis at a distance x. Put x equals to 0. Put x equals to 0 and you can get the magnetic field at the center. Right, so what will be the magnetic field at the center? Mu naught I upon 2r. So if you have a current carrying loop, then the magnetic field at the center is going to be mu naught I upon 2r. Remember these formulas? I have, highlighted all these formulas, download all these notes and revise it, right? Revise these formulas so that you don't make silly mistakes in the final exam, right? Okay. So Ampere's circuital law, it says that the circulation of the magnetic field, integral of BDL, circulation of magnetic field, that is equals to mu naught into current enclosed by the imaginary Amperian loop. Mu naught into current enclosed, right? Okay. So just quickly revise the formulas of these parts, right? We have done enough practice and now we are quickly revising the formulas, right, of grade 12th. So this is the solenoid, right? So in case of solenoid, how much magnetic field will be there? It is mu naught into N into I, right? All right. Now we have two parallel current carrying conductors. How much force will act between them per unit length? So my dear kids, if there are two parallel current carrying conductors, then force acting per unit length will be mu naught upon 2 pi I1 I2 upon D, right? This L is the force acting on the entire length. So here we have force acting per unit length is mu naught upon 2 pi I1 I2 by D, okay? All right, these are just the formula based questions. right? And we can definitely solve them. Now, we have a rectangular loop. As I said, every closed loop is going to behave like a magnetic dipole, and that magnetic dipole will experience a torque when it is placed in the external field, right? So if there are n loops carrying the current I, it will become a magnetic dipole. It will experience a torque, right? The magnetic moment of that dipole is I into A, right? Or there are n loops, then n into I into A, right? And the torque experienced by such thing is going to be m cross b, right? You can call it NIAB. All right. So if there are loops, right, of cross sectional area A carrying current I, number of turns n, torque will be, the torque it is going to experience in the external field is going to be NIAB. Okay. All right. So these are the basic formulas, right? Do that as a homework. So I will give you this sheet, right? So you can practice these basic formulas as well, basic questions. So the moving coil galvanometer, after that we have seen it. The torque experienced by the moving coil galvanometer, the coil of the galvanometer will experience a torque M cross B, NIA cross B, which is NIAB sine theta, right? Maximum torque, sine theta must be 90. So maximum torque that the galvanometer coil experiences is NIAB, right? So this is the coil, right? And the coil is connected with a little wire, right? So what really happens as the coil rotates, the wire goes under torsion, right? So it wants to keep back the it wants to turn the coil back in the same place, right? So the torsion angle is phi, right? We can say that the restoring torque starts acting, and let's say for a phi angle the restoring torque is k phi. At equilibrium, when you are taking the reading, the torsional force, or you can say the torsion that is acting on this thing, the torque which is acting in the wire is k phi, that will be equals to the maximum torque acting on the coil, NIAB. So the phi is going to be this much, right? All right. And this entire expression k upon NBA is called as galvanometer constant, right? Now galvanometer and ammeter, galvanometer can be converted to ammeter, and the same thing can be done in reverse, ammeter, So if you shunt, that means if you add a resistance in parallel to the galvanometer, it starts behaving like a ammeter, and the value of shunt resistance is Ig upon I minus Ig, right? And if you want to convert a galvanometer into voltmeter, you can also do that, right? By adding a great high resistance in series, right? Resistance in series, so that what you can do is, what will be the value of that resistance that you will add in series? V upon Ig minus G, right? V upon Ig minus G, all right. Okay. Now the next part is magnetism and matter, right? So bar magnet is this. We have this magnet, and doesn't matter how many times we break it, we will never be able to achieve a place where the magnet is, separated from its one of the any poles. For example, if you break the magnet, new magnets will be created, and every time there will be two poles in a given magnet, right? Every time there will be two poles in a given magnet, right? Quickly revise it. Okay. Properties of magnetic field lines and everything I've already explained while explaining the electric field properties, right? Magnetic field acts as an equivalent solenoid. So if you have a magnet with magnetic moment M, the magnetic field created is going to be mu naught upon 4 pi 2 upon r cube, right? Now every formula that you have covered in the electrostatics can be used in the magnetism as well, just you have to do the certain replacement. In the case of electrostatics, you were using 1 upon epsilon naught. Here you will be using 1 upon mu naught. Here you were using P, that is the electric dipole moment. Here you will use M, which is magnetic dipole moment. Here you were using P upon 4 pi epsilon naught r cube. It is the equatorial field for a short dipole. For a short dipole, this is the net electric field. Now, for a short magnetic dipole, what would be the net magnetic field? In place of P, you can place M, and in place of epsilon, 1 upon epsilon, you can put mu naught, right? Similarly, for all other factors, you can go about it, right? So magnetization and magnetic field intensity. So what really happens is when you try to convert a magnetic material into a given in a strong magnet, what really happens is there are domains, tiny regions of random dipole moment. So what happens, effectively they cancel out each other. So here north south is there, north south is there. So effectively they cancel out each other, and a piece of iron, this is like this, it does not behave like a magnet anymore, because small regions inside that particular thing do not add up, right? But what really happens, if you apply the external magnetizing field, then the domains align their dipole moment and the whole thing acquires a net magnetic moment. The phenomena is called as magnetization, and the degree to which these magnetization is achieved is called magnetization intensity or magnetic intensity, right? So these are the expressions for it, right? If H is the magnetizing field, right, and M is the intensity of magnetization which is produced, then the B is equals to B naught plus mu naught into M, right? So these are the basic stuff. All right. Now we have the electromagnetic induction. In the electromagnetic induction, what really happens is, if we have a surface and the electric field lines are moving at an angle theta from the surface, so electric flux is associated from it, B dot A, oh sorry, magnetic flux is associated from it. So here we have the surface, magnetic field lines are at an angle theta from the surface. So the magnetic flux is associated with it, it is BA cos theta. It is what? BA cos theta. All right. BA cos theta. All right. And if there is anything that changes the net magnetic flux associated with the surface, what does happen in that case? We will be able to create an EMF across the terminals. If we somehow close the circuit, a current will start forming as well. Okay. So EMF is rate of change of flux. This is the Faraday's law. So if there is a closed or you can say there is a coil or something like that. So if the magnetic flux passing through that coil is changing, then how quickly that magnetic flux changes will decide the amount of electric flux which will be EMF that will be created, right? So EMF produced across the coil is equals to the rate of change of magnetic flux that passes through it. The rate of change of magnetic flux that passes through it. So EMF is d phi by dt. Now we have Lenz's law. Lenz's law explains that what should be the direction of magnetic field lines, right? Okay. What should be the direction of induced current? That can be explained by Lenz's law, right? So here is a formula for inductance and all, right? So EMF is L di by dt. EMF is L di by dt. And the energy stored in the inductor is half Li square, right? Energy stored in the inductor is half Li square. Okay. So let's revise mutual inductance as well. Just a second. All right. So I'll give you the sheet, right? You can revise the remaining parts after the class itself, right? You can just go through it, revise the formulas of the remaining chapters. I'll be doing till EMI itself, right? Okay. So you see that there are in the case of mutual inductance, the current flows through a primary coil, and whatever variation happen in the primary coil, that is linked with the secondary coil, and that reflects in this form. EMF in the secondary coil is m di by dt, right? Okay. So this is the AC generator. Need not to worry about that. All right. So let's do this part only, right? Remaining portion, what I'll do is I'll be sharing the notes with you, right? And you can revise the formulas for the remaining chapters, right? I believe it's getting way too late now, and the session has gotten way too long. Okay, my dear kids, right now, if you have any question of your own, you can definitely ask me. Any question? If you have any question of your own, you can definitely ask me. Okay. All right. All right. So what I'll do is I'll be sharing the entire notes of the remaining part, and you can revise it at your own place, right? So make sure that you download it, and so that you can revise the formulas of grade 12th part as well. And if you want a long session on PYQs, just quickly let me know after the class. I will definitely try to help you with that as well. Okay. All right. Okay. So let's see the leaderboard at the end, right? So at the end, I will say, no problem, Anu. Okay, good. So at the end, in the leaderboard, we can say that Sudha Patil performed best, right, with 44 questions, but Rajeshri has performed best in my eyes, because she attempted 60 questions. She tried harder, right? But my dear kids, the NEET will reward this one. Attempted less questions, but got more correct answers, right? So in the reality, Sudha Patil will get more marks in NEET than Rajeshri, even if she tried harder, right? They got nearly same number of questions correct, but the attempt is higher. So make sure that you do not attempt the question that you don't know properly in the final exam, right? Yes. And then we have Kohli, 44 questions and 28. Pallavi, 28 and 25. Dhanush, 26 and 19. Right? All these things are there. All right. Okay, so Sudha Patil, gate concept of semiconductor. Like, if you don't know the entirety of it, beta, so I will suggest you to drop it at this moment, right? Semiconductor is a large topic. It is asked multiple times in the gate in the NEET exam as well. But if there is any portion that you want to read fresh right now, I will tell you to avoid it. Okay. So that's it for now, right? Let's keep this a lecture till here only, right? I hope you got decent practice and some decent revision as well. Remaining chapters, I believe I will be leaving up to you, right? You can just, because it's getting too late, right? We have very long lecture, right? So you can definitely go ahead and download the class, right? And revise it, right? Revise all the formulas, okay? Sure, Sudha, sure. Okay. All right, my dear kids, right? I'll see you there in the next class. Till then, take care and bye bye.